Welcome to the UI/UX Design Principles course. This course will empower you to create meaningful, user-focused designs that adapt across devices and meet diverse accessibility needs. By mastering these skills, you'll craft engaging, inclusive experiences and enhance your design workflows, making you well prepared for impactful roles in the evolving field of UI/UX. You will begin by exploring the core principles of UI/UX design, focusing on user-centered and accessible design to create inclusive experiences. You'll explore design thinking, understanding how each stage supports a clear, user-focused process. Then, you examine the process of creating prototypes with Figma or Adobe XD, practicing wireframing and high-fidelity mockups. You'll also learn to collaborate effectively, sharing and refining designs in real time. Next, you will implement responsive design using CSS, mastering techniques like media queries and mobile-first principles to ensure designs are adaptable across devices. Finally, you'll leverage Microsoft Copilot to streamline CSS development and generate responsive design improvements, enhancing your UI/UX workflows with practical AI support. By the end of this course, you'll be ready to create intuitive, accessible, and responsive designs that meet real-world needs. We're excited to support you on this journey to mastering essential UI/UX skills and enhancing your design impact. Hi, I'm Dr. Sharon Jumper, and I'm excited to be your instructor for this course. My journey into front-end development began when I was a teenager, experimenting with code for fun. I would write simple scripts on computers in big box stores that turned their displays into silly little interactive experiences. After high school, I spent 4 years in the U.S. Army as a signals intelligence analyst, where I deepened my understanding of how computers facilitate global communication. These early experiences shaped my career and fueled my passion for learning. As a lifelong learner, I've adapted my skills to the rapidly changing landscape of technology, applying front-end development principles in my roles as a lawyer, professor, enterprise learning architect, cybersecurity consultant, and entrepreneur. Whether building prototypes or launching full-fledged platforms, the ability to create dynamic, user-friendly interfaces is invaluable in today's digital-first economy. Today, we will explore the core aspects of front-end development, creating engaging, responsive, and accessible web pages that captivate and communicate effectively with users, as well as applications that make their lives and businesses more productive. From designing visually appealing layouts to adding interactivity, you'll gain the skills to craft modern web experiences. Whether you're planning to enhance a personal project, scale a business, or simply learn a new skill, front-end development opens a world of opportunities. And with technologies like Microsoft Copilot assisting you, you'll find the development process smoother and more intuitive. I'm excited to guide you through this journey of learning and discovery. Let's get started.
The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select Enter to check your work. I'm not totally sure here, so I'm going to click on Hint and get some help. And the hint says use console.readline, and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click Continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or you-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development. To bring together all that you've learned in this course, you'll complete a project that highlights the best practices for front-end development with the assistance of Microsoft Copilot. By the end of this project, you will have created a fully functional and visually compelling portfolio website for Alex Styles. This platform will showcase your creative work while demonstrating your skills in CSS, responsive design, and UI/UX enhancements. Whether you're building this project to enhance your portfolio, strengthen your front-end expertise, or take on an exciting challenge, this is your opportunity to showcase your capabilities. And the best part? You won't be working alone. Microsoft Copilot will be your coding assistant, helping you generate, refine, and optimize your work throughout the process. In this video, we'll outline the end-of-course project. By completing this project, you'll build a portfolio website that reflects professional design standards. You'll also showcase your expertise in CSS, responsive layouts, and user-focused features. Microsoft Copilot will streamline coding tasks and implement best practices. By the end, your site will include thoughtful typography, a well-coordinated color scheme, and interactive design elements. Whether you're new to front-end work or already have some experience, this project is designed to develop practical and impactful skills. Let's break it down. First, you'll add CSS styling. This will establish a strong visual foundation with cohesive layouts, color schemes, and typography. The portfolio will also use responsive design to ensure the website adjusts effortlessly to different devices and screen sizes using media queries. You'll also build interactive features to add animations, hover effects, and other user-friendly touches for a polished, professional experience. Finally, you'll optimize the code, focusing on keeping it clean and efficient to maintain performance. Microsoft Copilot will support you throughout the project by helping you create CSS that aligns with professional design principles. It'll generate responsive design techniques for various screen sizes. It'll offer ideas and code for animations, transitions, and other interactive elements. And it'll identify and resolve inefficiencies in your code for a better overall result. This project is divided into 3 structured activities. In Activity 1, you will focus on building the foundational styles for typography, color schemes, and layouts, and use Copilot to establish a cohesive and professional aesthetic. In Activity 2, you'll adapt your site for mobile, tablet, and desktop screens using media queries to ensure your layout and content scale properly across various devices. In Activity 3, you'll incorporate animations, hover effects, and transitions to create a dynamic user experience and refine the overall design to make it visually appealing and user-friendly. After completing these activities, you'll submit your project for peer review. This final step allows you to receive feedback and reflect on your development process, gaining insights into how you've grown as a front-end developer. Each activity builds on the last to ensure steady progress in a comprehensive learning experience. Microsoft Copilot will offer suggestions on how to debug issues and keep you on track towards your goal. Following this structured approach, you'll create a professional-grade portfolio website to highlight what you've learned. This project not only demonstrates your skills in front-end design, but also showcases your ability to integrate AI tools like Copilot into your workflow. This end-of-the-course project offers you the chance to showcase your creativity and expertise as a front-end developer. It's both challenging and rewarding, leaving you with a professional-grade portfolio website and a strong foundation in modern web development techniques.
Welcome to Principles of UI/UX Design. In this module, you'll gain the essential skills to create user experiences that captivate and serve diverse audiences. By the end, you'll be ready to design interfaces that look great and feel intuitive and accessible, setting you up to make a real impact in the digital world. We will begin by exploring the core concepts of UI/UX design, uncovering how thoughtful user interface and experience design can shape your user interactions and drive engagement in web applications. Next, we'll identify the essential principles of effective design, focusing on balance, alignment, and visual hierarchy. You'll discover how these principles guide the creation of visually compelling and intuitive interfaces. Then, you will examine user-centered design, understanding how to keep user needs and goals at the forefront of every design decision. This approach ensures that interfaces are not only functional, but also resonate with users on a practical level. Next, you will explore accessibility best practices, learning how to make digital content more inclusive. You'll identify techniques that improve usability for all users, ensuring equitable access and compliance with accessibility standards. Finally, we'll introduce the design thinking process and apply its stages to front-end development. This structured approach will help you build solutions that are creative, user-focused, and responsive to real-world challenges. By the end of this module, you'll have a solid foundation in UI/UX principles, enabling you to craft interfaces that are engaging, intuitive, and accessible for all users. Let's begin. A beautifully designed website is meaningless if users struggle to navigate it. The real success lies in the seamless combination of user interface and user experience, ensuring visual appeal and a smooth, intuitive experience. In this video, we will explain the user interface and user experience and their roles in design. Before we explore these concepts further, let's clarify what user interface and user experience mean so you can understand how they complement each other. A user interface, or UI, is the set of visual elements like buttons and icons that enable interaction between the user and a digital device or product. Front-end engineers use coding languages like HTML, CSS, and JavaScript to create a website's visual elements, making it functional and appealing. User experience, or UX, encompasses all aspects of the end user's interaction with the application, focusing on the overall feel and the ease of using the product or service. User interface and user experience are related, but they're different. User interface focuses on a product's visual design and structure, like how buttons are laid out. User experience focuses on the experience, how easy and enjoyable it is to use the product, and whether users can complete tasks smoothly. Although both serve different purposes, they work in tandem. A great user interface captures attention, but a strong user experience keeps users engaged. Together, they create a seamless experience that encourages users to return. In today's digital world, a product's user interface/user experience can make or break its success. Consider an app with stunning visuals but complicated navigation. Users might be impressed initially, but quickly frustrated if they can't accomplish their goals easily. Alternatively, an app with a plain user interface but excellent navigation or user experience may keep users satisfied, but it might not attract many users due to its lack of visual appeal. Together, a great user interface and excellent navigation, user experience, lead to an enjoyable user experience. When both elements work in harmony, they achieve the best results. Now that we've covered the importance of user interface and user experience, let's examine what web designers should focus on to create great experiences. When designing for the web, front-end engineers must consider both user interface and user experience to ensure the best user experience. Additionally, they create designs that are visually appealing but also functional and accessible. Furthermore, they include feedback mechanisms like a pop-up that says, "Your form has been submitted," to confirm actions. Similarly, they ensure user flows, the paths users take to complete tasks, are clear and easy to follow. Mastering both user interface and user experience means creating products that are visually appealing, enjoyable, and easy to use. Users who enjoy using a product are more likely to explore it further, complete actions, and become loyal customers, a valuable asset in a competitive digital world. In the world of design, user interface and user experience are like two sides of the same coin. Understanding their relationship is helpful in creating a cohesive and engaging experience for users. UI, or user interface, focuses on the visual elements, the colors, buttons, and layout that users interact with directly. UX, or user experience, is all about how users feel when they use an interface, whether it's intuitive, enjoyable, or frustrating. But how do these two disciplines connect? In this video, we will describe how user interface and user experience work together to create cohesive design experiences. Let's start by exploring user interface design and the tools developers use to create successful apps or website designs. UI, or user interface, focuses on the visual elements such as colors, buttons, and layout that users interact with. For front-end developers, there are three essential tools they use to create user interfaces: CSS, HTML, hypertext markup language, and JavaScript. CSS, cascading style sheets, controls the design and layout. For example, the color contrast of text or images can be done using CSS. HTML, hypertext markup language, structures the content. Well-organized content is created using tags and other elements associated with HTML code. JavaScript adds interactivity to elements like buttons and menus. Now that you have an understanding of UI and the tools used by developers to create UI, let's move on to explore how UI directly affects UX or user experience. There are 5 key ways UI affects UX in web design. The first is visual hierarchy. A well-designed UI guides users through content by establishing a clear visual hierarchy. By using layout, size, color, and spacing effectively, users can quickly identify important elements, improving their experience with easier navigation. The second way UI affects UX is via responsiveness. UI design that adapts smoothly across devices enhances UX by providing a consistent experience, whether users are on a desktop, tablet, or mobile device. Responsive UI makes content accessible and enjoyable regardless of screen size. Next is through intuitive navigation. An intuitive UI layout with clear menus, buttons, and links helps users easily find what they're searching for. When navigation is simple and logical, it enhances user satisfaction and reduces frustration. The fourth way UI directly affects UX is with consistency. A consistent UI across the entire website improves UX by creating familiarity. When design elements like fonts, colors, and buttons are uniform, users can interact with the site more confidently and efficiently. And finally, loading speed. UI elements like images, animations, and scripts affect how quickly a website loads. A fast-loading interface leads to a better UX, as users expect quick, responsive sites and are more likely to stay engaged with a site that performs well. By working together, these elements ensure a seamless interaction between the user and the user interface, enhancing overall user satisfaction. User interface and user experience must work together to create cohesive experiences. Think of user interface as the menus, buttons, and forms, while user experience ensures that these elements function smoothly. For example, paying a bill using a mobile app. If the app's design is clear and intuitive, you can complete the payment without frustration. However, if the app is hard to navigate despite its visual appeal, the experience will be frustrating. User interface sets up the layout, and user experience ensures it's intuitive for users. As UI directly affects UX, iterative design based on user feedback allows for the continuous improvement of user interface and overall user experience. Iterative design is a process of repeatedly refining a product through testing and feedback to improve its functionality and user experience. For example, if users struggle to find a key button, the design can be updated to make it more prominent. This process of testing and improving is called iteration. Each update aims to make the product easier to use and more enjoyable. Interactive design consists of 3 main components: prototyping, user testing, and feedback, and refinement. Let's discuss each of these 3 components in more detail. First, let's discuss prototyping. In interactive design, creating prototypes is essential. These can be wireframes or interactive mockups that represent the website's structure, layout, and functionality. Prototypes allow designers to test ideas quickly and gather feedback before committing to final development. Next, designers often rely on user testing and feedback to guide improvements. After each iteration, conducting user testing to gather feedback helps identify usability issues, understand user preferences, and ensure the design aligns with user needs. Continuous feedback from real users guide improvements in the next iteration. Lastly, based on the insights gained from testing and feedback, refinements are made to the design. This process includes tweaking layouts, adjusting functionality, and optimizing user experience. The cycle of refining and retesting continues until the design meets the desired goals and user satisfaction. These 3 components ensure a user-centered approach, continuously improving the website with each iteration. Designing a product that is visually appealing is just the beginning. When user interface and user experience are refined together, the result is something users love and keep coming back to. Every time you use an app or website, you interact with a carefully crafted design that enhances or hinders your experience. Have you ever wondered why some apps are intuitive and others frustrating? That's the power of user interface, user experience design at work. In this video, we will explain why user interface, user experience design is critical in modern web and app development. Before we discuss user interface and user experience, it's important to understand the front-end tools that bring them to life: HTML, CSS, and JavaScript. These three tools create websites and apps structure, style, and interactivity. With these tools in mind, let's start by understanding what user interface and user experience are and how they shape your experience with a product. Good user interface, user experience keeps users returning by making apps easy to use and fast to load. Think of a streaming app where you can easily find and watch your favorite shows without lag. That's the kind of experience that retains users. Additionally, front-end engineers ensure that buttons are large enough to be easily pressed, especially on mobile devices. For instance, large buttons on a banking app make it simple to transfer money or check your balance with just a tap. Adding alt text to images makes apps more accessible for users who use screen readers. Front-end engineers include this alt text in the HTML code to ensure screen readers can describe images. Color choices are also important for apps and websites. Consider an accessible color contrast ratio of at least 4 to 5 to 1 for normal text and 3 to 1 for larger text to help users view your content clearly and easily. Checking color choices in the design using a color contrast analyzer can indicate if the colors are within the appropriate range or in need of updating in order to be easily perceived. If an online store's product pages take too long to load, customers might leave before buying anything. Fast performance is crucial for keeping users happy. By optimizing code like reducing image sizes on a blog, front-end engineers ensure content loads quickly, keeping users satisfied with a smooth browsing experience. Front-end engineers use HTML, CSS, and JavaScript to bring these user interface, user experience designs to life. In HTML, elements like buttons are created using opening and closing tags. This specific tag, open caret button, close caret, tells the browser to create a button on the page. Whatever you place between the opening button and closing button, which is caret / button, close caret, tags will be displayed as the button label that appears to users and is clickable. In HTML, many elements require both an opening tag, like button, and a closing tag, /button, to define where the element begins and ends. Let's build the HTML code for a button. First, we insert button, which is the HTML tag that defines a button element. Users can click this button to perform an action. Then we use ID equals open quote color button close quote. The ID attribute uniquely identifies this button in the HTML document. IDs are used to apply specific styles or behaviors to a single element. In this case, the button is given the unique identifier color button. IDs must be unique within the document. That is, no two elements should have the same ID. Click Me is the text displayed on the button. When the button is rendered in a browser, the words Click Me will appear inside the button. Close button tag, /button. This is the closing tag for the button element. Now that we've introduced you to how UI, UX designers might use HTML to create their designs, let's move on to CSS. This CSS code on the right changes the button's background color. This line selects all button elements on the page. In CSS, selectors target HTML elements. Here, button is the selector, meaning it applies styles to every button on the page. This line of code sets the background color of the buttons to blue. In CSS, properties like background-color change specific aspects of an element's style. The value after the colon, blue, tells the browser what color to use. You can change blue to other color names, codes, or values. The closing curly brace signifies the end of the styles for the button element. Let's explore how JavaScript can be used by designers to create interactions with a button. Front-end engineers use JavaScript to add interactivity, like changing the color of a button when it's clicked. The code tells the browser to find an HTML element with the ID color button. In JavaScript, document refers to the web page, and the method getElementsById selects an element by its unique ID attribute in the HTML. As soon as the script runs, the button's background color changes to green. When user interface, user experience design is implemented thoughtfully by front-end engineers, it leads to happier users, better performance, and more engagement. Have you ever wondered why some websites feel easy to use while others don't? The secret lies in using balance and contrast to guide the user's eye and make the layout easy to understand. In this video, we will describe balance and contrast in UI development. Balance is the even distribution of visual weight in a design. It makes sure that images, text, and other elements feel evenly spaced out. Let's discuss how you can add balance to your website designs using 3 key benefits. The first benefit of using balance is an improved user experience. Balanced layouts create a sense of order and harmony, making the website easier to navigate. This enhances the user experience by helping users find content more intuitively and comfortably, reducing confusion or overwhelm. Next is visual appeal. A well-balanced design ensures that no single element dominates the page. By distributing content, images, and white space evenly, balance creates a visually pleasing and professional appearance, which can keep users engaged and make the site feel polished. Balance helps structure the page in a way that emphasizes the most important elements, such as headlines, images, or calls to action. This makes it easier to communicate key messages without overwhelming the user while maintaining focus on the overall flow of the content. Together, these benefits create a more enjoyable and effective browsing experience. Now that you have an understanding of the benefits of balance in website design, let's discuss a few examples that you can use in your designs. For example, if you place a large image on one side of a web page, you can balance it with text or another element on the other side. When we think of balance, the easiest type to understand is symmetrical balance. This happens when elements are mirrored on both sides of an axis. For instance, a centered title with an image on the left and a block of text on the right feels balanced and structured. A less common type of balance is asymmetrical balance, which occurs when elements on both sides differ but still feel balanced. Imagine a large image paired with smaller text. Even though the sizes differ, the layout can still feel balanced. Now, let's use CSS to create balance by controlling the size of a box. This line defines a CSS class called box. Classes allow us to apply the same style to multiple elements. In your HTML, you'll assign class equals open quotes, box close quote to an element on the page. This tells the browser to apply all the styles defined in the box class in the CSS file to that particular element. The width property sets how wide the box will be. In this case, 50% means the box will take up half of the available space on the page. We use percentages to make the layout flexible so it adjusts to different screen sizes. The background-color property fills the box with a color. Here, the box will have a light blue background, making it stand out. CSS uses color names like light blue, hex codes, or RGB values to define colors. This curly brace closes the box class. All the styles between the opening curly brace and closing curly brace are applied to any element that has the class equals box in your HTML. Now, let's explore how contrast helps important elements like buttons or headings stand out. Contrast is a visual difference between two elements. Think of dark text on a light background. It's easy to spot and read because of the strong contrast. Color contrast is an easy way to make elements pop. Imagine a stop sign with white text on a red background. The sharp color contrast makes it stand out. Now, let's explore a few benefits of using contrast in web design. The first benefit of using contrast in web design is improved readability. Contrast between text and background colors ensures that content is easy to read. High contrast helps users, especially those with visual impairments, quickly understand the information on the page. Next is an enhanced visual hierarchy. Using contrast effectively allows designers to emphasize important elements like buttons, calls to action, or headlines. It helps guide the user's attention to key areas, making navigation more intuitive. The last benefit we will discuss is aesthetic appeal. Proper contrast can create a visually striking and engaging design. It adds depth and dimension to a page, making it more dynamic, which can enhance user engagement and make the website more memorable. By leveraging contrast, these three benefits can create a more user-friendly and aesthetically pleasing web experience. Now that you understand the value of contrast in web design, let's discuss how we can use CSS to apply contrast to an interactive element like a button. With CSS, we can create contrast by setting a background color for buttons. This line creates a CSS class called BTN. Any HTML element with the class BTN will have the styles we define here. Using classes lets you apply the same styling to multiple elements, like all buttons on a page. The background -color property sets the background color of the button. Here, the button will have a green background. The background helps the button stand out visually, making it easier to interact with. The color property defines the text color inside the button. In this case, the button's text will be white, which contrasts well with the green background. This makes the text easy to read. This curly brace closes the button class. All the styles between open curly brace and close curly brace are applied in every element with the class equals BTN button in the HTML. By understanding and applying balance and contrast, you can design websites that are both functional and visually appealing. CSS gives us the tools to achieve these principles with ease. Have you ever wondered why some websites feel effortless to use? It's all about alignment and proximity, two simple yet powerful design principles that guide the user experience. In this video, we'll explain the principles of alignment and proximity and their role in front-end development. Alignment means arranging elements in a straight line to create an organized look. Proper alignment guides users' eyes, making content easier to read. For example, when headings and paragraphs are centered or left aligned, they appear more structured. In CSS, text align is a simple way to center text within an element. Here's how to use it. Use text align to center text inside a container. In our CSS file, we first start with .heading open curly brace. This selects an HTML element with the class heading. In CSS, a period is used before the name to indicate a class selector. Next, open curly brace, text-align, space, center, semicolon, centers the text horizontally inside the element. Last, close curly bracket, closes the CSS rule set. Text-align is great for centering text, but what if you want to center other items like images or buttons, or control alignment in more than one direction? That's where Flexbox comes in. Flexbox allows you to easily align multiple elements inside a container, both horizontally and vertically. Flexbox, also known as Flexible Box Layout, is a CSS layout model that allows items in a container to be automatically arranged in a flexible and responsive manner. It is designed to distribute space dynamically between items within a container, even when their size is unknown or varies. Flexbox helps to align items, control the spacing between them, and manage how they wrap within a container. Now, let's use Flexbox to center items both horizontally and vertically. First, .container curly brace. This selects the container element, which holds other elements you want to align. Second, display : flex semicolon enables Flexbox, allowing for flexible alignment of items within the container. Third, justify -content, center, semicolon. Centers the items horizontally within the container. Fourth, align -items, center, semicolon. Centers the items vertically within the container. Fifth, height, 200px, semicolon. Sets the height of the container, giving it enough space to vertically center its content. Sixth, close curly bracket, closes the CSS rule set. Now, let's move on to proximity and why it's important to design. Proximity refers to the principle that elements that are physically close to each other are perceived as related or grouped together. This helps users quickly determine which items are connected. For example, putting labels near input fields indicates that they belong together. In CSS, you manage proximity using margin and padding. Here's a simple way to create space around elements. CSS.section, open curly brace, margin -bottom, 20px, semicolon, close curly brace. This adds space below the element, creating a visual gap between sections. Now that we've explored how to align elements and manage spacing, let's apply these concepts to a simple product page. On a product page, centering the product title and image creates a clear focal point. Grouping the product description close to the Buy Now button helps users quickly find related information. Adding space between sections like product details and reviews ensures a clean, organized layout. By aligning elements and using proximity wisely, the page feels intuitive and easy to navigate. Mastering alignment and proximity can turn a cluttered interface into an intuitive experience, making it easy for users to find what they need and interact seamlessly. Have you ever wondered why some websites are easier to use than others? It all comes down to how they guide your attention with design principles like hierarchy and repetition. In this video, we'll explain how hierarchy and repetition guide users through a user interface. Let's start by explaining what visual hierarchy means and why it's important to guiding users. Visual hierarchy arranges elements by importance, guiding users to key information first. This improves user experience by making the interface clearer and easier to navigate. Visual hierarchy can guide the user's focus using size, position, and color. Let's break down each of these elements. First, larger elements grab more attention. For example, on a product page on an e-commerce website, the product title might use a big, bold headline or product name to draw consumers in, while smaller text is used to describe the product details. A larger image might also be used to show the product in detail, with smaller thumbnails of alternative views or related products placed underneath. This would guide the user's focus towards the featured item first. Next, where something is placed on the screen affects its importance. Items at the top or center, such as product name, draw attention. The Add to Cart button is prominently placed on the product page, making it easy for users to find. Its strategic placement near the top, adjacent to the size, ensures that it is seen quickly, encouraging users to complete their purchase. Finally, color creates contrast and highlights important information. Consider a bright green check mark to indicate the color of a product on a gray background. The contrast makes the indicator stand out, signaling its importance. While visual hierarchy grabs the user's attention, repetition makes the design predictable and easier to understand. Repetition means using the same visual elements like styles and layouts across different parts of the UI. This consistency helps users know what to expect. Repetition creates predictability and ease of navigation. Here's how it works. To start, applying the same style for buttons, fonts, and colors creates a cohesive experience. For example, an app might use the same green button for Submit, Next, and Cancel, making actions easy to recognize. Designers often use CSS to apply these styles consistently. Additionally, keeping layouts the same across pages helps users find information quickly. For example, on an e-commerce site, Product pages might always have the image on the left and the description on the right. This can be done using standard layouts, making navigation simpler for users. By thoughtfully arranging elements and repeating key patterns, you can create a UI that feels natural to navigate and keeps users engaged.
Ever wonder why some websites seem to know exactly what you need? It's not magic. It's thoughtful design centered around user needs and behavior. In this video, we'll explain the importance of considering user needs and behavior in front-end design. User-centered design focuses on creating easy-to-use interfaces that solve real problems for users. This makes their interaction with the product smoother and more enjoyable. When designs meet user needs, tasks are made easier and more satisfying. Let's examine why this is important. First, thinking about user needs helps make websites and apps easier to use. For example, placing the shopping cart icon in a visible spot on an online store makes the experience smoother. Second, designs that match user behavior lead to higher satisfaction. For instance, a music app that suggests songs based on listening habits makes the experience more personal and enjoyable. Once you have identified and addressed user needs, then you gather user feedback. These are various ways to gather feedback, each providing unique insights into user needs and behaviors. Let's go through some of the most common methods. One way to gather feedback is through surveys to collect opinions on features or experiences. For example, a smart home tech company that is developing a new interface for their HVAC thermostat app might ask users to rate their experience setting a schedule for their air conditioner to turn on and off. The survey will reveal what users find helpful or confusing. For example, the icons might be helpful, but setting the air conditioner's schedule might be challenging due to the many options. Another way to collect user feedback is through interviews, where we talk directly with users to learn about their needs and difficulties. For example, asking users to identify areas of the app they found challenging may provide insights needed for improvements. Finally, usability testing means watching real users interact with an app or website. If users struggle to find the schedule page, it might need a clearer label or better placement. For example, if users' feedback indicates wanting 1 or 2 clicks to access schedule page, the UI designers might consider moving it to the home screen to reduce the workflow and help users access it more quickly. Once we gather feedback, designers use it to identify key issues and make targeted improvements that enhance the user experience. First, designers identify common issues reported by users. Next, designers outline changes, such as adding a search bar or changing button colors to make things more clear. These instructions guide front-end engineers on what to do. Afterward, front-end engineers implement these changes. Then, designers test the site again using usability testing to ensure it meets user needs. This process helps refine the design. Let's examine how these steps work in real life. Imagine a user utilizing the smart home HVAC thermostat app. They want to set their kitchen to 68 degrees Fahrenheit and their office to 74 degrees Fahrenheit. The user has difficulty accessing the menus that allow them to specify temperature by room and can only seem to access the schedule page. Now, imagine you're a user interface designer working on the smart home HVAC thermostat app. You have identified that users struggle to implement the room temperature settings with the current interface. You and your design team decide to create a simpler version of the room temperature settings page, where the user selects the room and then the desired thermostat temperature to discover if this improves their experience. The new version is going through the next round of usability testing, and users find the new layout much easier to navigate. Interpreting and acting on user feedback can transform a user interface design from good to great, creating easy and satisfying experiences that keep users coming back for more.
Have you ever wondered why some apps feel like they were made just for you? That's the power of understanding users through personas. In this video, we will describe how to create and leverage user personas in design. Before we discuss how they're used further, let's define a user persona and why it's important in design. User personas are fictional profiles representing different types of users. They include information like age, goals, preferences, and challenges, giving designers a clear idea of who they're creating for. Now that we know what a user persona is, let's explore how they help improve the design process. Personas help focus design on real user needs, making products easier to use. Here's why they're important. First, personas ensure the design meets user needs. For example, a busy professional might prefer a simple layout with quick access to key features. Next, for a tech-savvy student, engineers might add interactive features that match their expectations. Personas can also represent users with different abilities, reminding designers to include accessibility features. For example, an older user might need larger fonts and simpler navigation. Now, let's go over a simple process to create user personas. First, conduct research to understand your target user's demographics and goals. For example, if you are designing a fitness app, you might identify target users as busy professionals who need quick workouts. Second, find patterns in user data and group similar characteristics to form a persona. Through your research, you discover that busy professionals want workouts that are 20 minutes or less and require little or no fitness equipment. They also want smartwatch integration and step-by-step instructions with videos to follow along easily. Third, create a basic profile with a name, age, job, goals, and challenges. By creating a persona, designers can better understand the audience they are designing for and keep design parameters within their persona's needs, likes, and dislikes. For example, Fitness Fiona, a 30-year-old marketing specialist, works long hours sitting at her desk. She appreciates workouts that target the upper back, neck, and shoulders, and prefers features like built-in workout timers that sync with her smartwatch to keep her exercises on schedule. By sharing Fitness Fiona with designers and engineers working on the fitness app, the user persona can guide design choices and app functionality, like adding targeted workouts for the upper body or a smartwatch timer or scheduling features. With user personas created, front-end engineers can use them to guide their design choices using 3 simple steps. To start, personas help engineers focus on user needs. Knowing Fitness Fiona values targeted workouts, engineers might add a search feature or one-click access to start a session based on her workout interest, or add a smartwatch feature that beeps when a workout set is done. Next, personas influence layout and styling. If a persona prefers a clutter-free interface, engineers might use more white space and larger fonts. Being that Fitness Fiona is a marketing specialist that values clean design, engineers might organize workouts with short and descriptive titles like upper body workout, or leverage a simple flat design style that limits visual distractions. Lastly, if personas represent users with accessibility needs, engineers add features like clear text, high contrast, and keyboard navigation. Fitness Fiona works long hours typing on her computer, leaving her hands sore and tired, so engineers might include simple voice features so she doesn't even need to use her hands to access her workouts. By designing with user personas, you can create products that not only meet specific user needs, but also make every interaction feel seamless and intuitive. What makes some websites frustrating to use while others feel effortless? The secret lies in usability, the key to designing experiences that keep users engaged and coming back. In this video, we will identify key usability principles in user-centered design. Usability refers to how easy and efficient it is for users to interact with a product or system, such as a website or app. It considers factors like ease of learning, efficiency, memorability, error management, and user satisfaction. It's important because it ensures users can complete tasks easily without frustration. Consider a food delivery app. When a user opens the app for the first time, it should be easy to navigate with a clear display and intuitive icons for key actions like searching for restaurants, browsing categories, and placing an order. A new user should be able to quickly and easily figure out how to use the app without needing instructions. Now that we understand usability, let's explore our first key principle, simplicity. Simplicity means keeping an interface design straightforward, easy to understand, and free of unnecessary complexity. The interface is clear and easy to understand, helping users focus on their tasks without distractions. Simplicity has three components. To keep things simple, remove unnecessary elements to create an uncluttered design. For example, our food delivery app might have a favorites or recent orders section that makes it easy for users to find their favorite sandwich or reorder their stir fry quickly and easily. This helps users focus and prevents overwhelm. Another important part of simplicity is using familiar elements. Using familiar icons like a magnifying glass for search or a trash can for delete makes the interface intuitive. Users won't have to learn new symbols, making navigation easier. Lastly, the fewer steps a user has to take, the better. Instead of asking users to type what they are seeking in the search bar, help users find what they need quickly by using predictive text or autofill features that can streamline the search process. Keeping workflows simplified can also keep users engaged and reduce frustration. With simplicity explained, let's move on to the next principle, feedback, which helps users understand what's happening when they interact with the system. Feedback refers to the information or signals provided by the system to users in response to their actions. The first way to offer feedback is by confirming user actions. For example, after submitting a food order, the user receives a confirmation message that says, "Your order has been placed." When an action takes time to process, feedback is important to reassure users. In cases where there's a delay, if the order form takes a moment to process, show a loading spinner indicating the system is handling their request to prevent frustration. Feedback tells users about their actions. Now, let's discuss error prevention, which helps users avoid mistakes before they happen. Error prevention refers to designing interfaces that reduce the likelihood of users making mistakes and help them avoid potential errors during interactions. One way to prevent errors is by guiding users as they fill out an order form. For example, when users start typing their delivery address on the food delivery app, autocomplete suggestions can help them choose the correct option and reduce typos. Another way to prevent mistakes is by allowing users to review their input. A final review screen can allow users to double-check their details before submitting the food delivery order form, ensuring everything is correct. Lastly, preventing errors can be as simple as disabling certain choices. For instance, if a user selects an invalid availability date, the option should be grayed out to prevent it from being chosen. Every design choice impacts how users experience your app or website. By applying these usability principles, you can create interfaces that users love without them even realizing why. Have you ever wondered how someone with a disability navigates a website? Designing with accessibility in mind isn't just a nice to have. It's essential to ensure that everyone can experience the web equally. In this video, we will define accessibility and its importance in front-end development. So what exactly is accessibility in front-end development, and why is it so important? Let's begin by defining it. The Web Content Accessibility Guidelines define accessibility as ensuring websites and applications are usable by everyone, regardless of their abilities. Now that we understand accessibility, let's explore why it matters for everyone, not just people with disabilities. Accessibility helps people with disabilities, such as vision or hearing impairments, use websites. For example, someone with low vision might use a screen reader to hear the content aloud. Making a website accessible also improves the experience for all users. Adding captions to videos benefits everyone, not just those with hearing impairments. To create accessible websites, we follow 4 key principles. Let's break them down. First, content needs to be perceivable, which means users need to be able to see or hear it. For example, add text labels and ensure color contrast so the text is easy to read for everyone. Once the content is perceivable, the next step is to make sure it is operable. To be operable, users must be able to navigate a website. Some people may not be physically capable of using a mouse and rely on the keyboard to help them navigate, using the Tab key to move through content. Make sure your website supports this. After making your website operable, it's important to keep it simple and easy to understand. The website should be easy to follow. Use clear, simple language for form labels and instructions. Arrange the layout logically so users can find what they need without confusion. Lastly, your website should work well across different devices and browsers. The site must be compatible with various devices, browsers, and assistive tools like screen readers. These tools help users with vision impairments by reading the content aloud. Now that we've covered the 4 principles of accessible design, let's discuss how front-end developers apply them. Developers use semantic HTML to make websites accessible. HTML is the code used to build websites, and semantic HTML uses tags that provide meaning to the content they enclose, making it easier for users and technologies to understand the structure and purpose of the web page. So how can you apply accessibility to your website? Let's go over some practical steps. To start, use the correct HTML tags to describe content. Use label to connect form fields with their labels, making it easier for screen readers to explain them to users. For example, you can use label to name a form field for information like your name. Label space 4 equals open quote full name close caret enter space your space name open caret slash label close caret space input space type equals open quotation text close quotation space ID equals open quotation full name close quotation name equals open quotation full name close quotation slash close caret. Next, ensure that users who can't see images still know what's being shared. Alt text describes the content of an image for accessibility purposes, particularly for visually impaired users who rely on screen readers. Add descriptions for images and videos using alt text so users who can't see them can still understand what's there. For instance, imagine a visually impaired user searching for puppy products on a pet products website. As they scroll, they come across a picture of a puppy that they cannot see. By including alt text that describes the image, the user doesn't miss out on valuable information. An example of an alt text for an image of a puppy might be written as open caret img space src equals open quotation puppy dot jpg close quotation space alt equals open quotation a small brown puppy playing with a red ball on the grass close quotation slash close caret. This is the alternative text that describes the image. If the image fails to load, or if a user is using a screen reader, they will receive this description instead. Let's continue by ensuring that your website is easily navigated by everyone. Make certain that users can move through your site using just a keyboard. For instance, pressing the Tab key should let users move logically between form fields. Color is important for design, but it shouldn't be the only way to convey information. Don't rely on color to display important information. Combine color with text. For example, show error messages like, "Please enter a valid email," in red text with clear instructions. Finally, testing your website with tools is critical to making sure it works for everyone. Use tools like screen readers to test your website for accessibility. A screen reader reads the content aloud, helping people with vision impairments to understand a website. Accessibility isn't just about compliance, it's about building a web that everyone can use, no matter their abilities. By prioritizing accessibility, you're ensuring a better experience for all. What if a simple design choice made it impossible for someone to apply for a job? Accessibility is about ensuring that everyone, regardless of ability, can use the web without barriers. In this video, we will describe key accessibility guidelines and how front-end engineers implement them. To make websites like a job search platform accessible, we follow accessibility guidelines called WCAG. Let's explore what they are and how they work. WCAG, or Web Content Accessibility Guidelines, are a comprehensive set of guidelines for making web content more accessible. These guidelines are based on four main principles: perceivable, operable, understandable, and robust. Front-end engineers use specific coding techniques to make certain that websites meet accessibility standards. Semantic HTML is the first key to making websites accessible. By using the right descriptive tags, developers can create a more intuitive and structured experience for all users. Imagine you're a user with a visual impairment trying to navigate a job search website. You are having difficulties navigating to the search button using your keyboard. What went wrong? If the site is missing the proper tags, the user will have difficulty navigating it with just a keyboard, which can create a frustrating experience. Using tags like nav for navigation and section for job application forms helps screen readers understand the structure of the page. This ensures users know where they are and how to navigate the site, even without seeing it. Sometimes semantic HTML isn't enough, especially for more complex elements. That's where ARIA comes in. ARIA, Accessible Rich Internet Applications, attributes provide extra information to help assistive technologies. Let's say the job search website's search button only shows a magnifying glass icon. As a visually impaired user, you are unable to access the search function using just a keyboard. What went wrong? It could be that the button was too complex and needed an ARIA label to make the function more accessible. Using the element ARIA-label equals open quote, search space jobs close quote ensures that a screen reader announces it as a search jobs button so users know its function. Another important aspect of accessibility is verifying that the website works with just a keyboard. Keyboard navigability ensures users can interact with all elements on the site using only a keyboard. Visually impaired users may rely solely on keyboard navigation to get the information they need. By ensuring that users can navigate through job search filters, complete applications, and submit them using the spacebar and tab and enter keys, we create a more inclusive experience for individuals who can't use a mouse. But accessibility doesn't stop there. Front-end engineers rely on tools like Wave or Axe to further enhance usability by scanning for common accessibility issues such as missing alt text or keyboard traps. These tools help identify and fix problems, ensuring the site is truly accessible for all users. Building accessible websites isn't just about following guidelines. It's about creating a space where everyone can participate and engage. By ensuring accessibility, you're opening your platform to the world. If your website's design isn't accessible, a user might struggle to read the text, navigate using a screen reader, or fill out a form. Accessibility ensures that everyone, regardless of ability, can interact with and benefit from your content. In this video, we'll explain practical techniques for implementing accessibility in front-end design. Accessibility ensures websites and applications are usable by everyone, regardless of their abilities. Now that you understand why accessibility is important, let's walk through how we can improve a website's design to be more accessible, starting with visual accessibility. Let's say we have a web page with a light gray background and a pale yellow text. Users with visual impairments might struggle to read this text, so we need to improve the color contrast. First, we'll use a tool like WebAIM or Chrome's DevTools to check the contrast ratio. A color contrast analyzer tool will tell us if the text is legible. For body text, we need a ratio of at least 4.5 to 1. The color contrast analyzer shows that pale yellow text on a light gray background fails the contrast check, with a ratio too low for legibility. Since our ratio is too low, we'll darken the text to a stronger color like dark gray or black while keeping the background light. This creates enough contrast to meet accessibility standards. Now, we change the text color to dark gray on the light gray background. Our contrast analyzer now shows a ratio of 7:1, which verifies that the text is legible for most users. After improving color contrast, let's make sure our site works well for users who rely on screen readers, which convert digital text to speech or braille. Our job is to confirm that the page's structure and elements are easy to navigate. We'll use proper HTML tags to make the structure clear for screen readers, instead of using generic div tags that are used to group together elements to apply styling or layout. We'll apply semantic HTML tags like nav for the navigation menu and section for different content areas to convey meaning to browsers and assistive technologies like screen readers. In our navigation menu, we replace the div tag with nav semantic HTML tag. This tells screen readers that this section of the website is a navigation area, so users know how to move through the page. Screen readers will read the tags out loud and move the user through each of the items in the navigation menu so that they can easily find what they are searching for. HTML tags alone might not always give enough detail. This is where ARIA attributes help. We can add ARIA labels to describe interactive elements more clearly to screen readers. To make certain that interactive elements are fully accessible, we can provide additional descriptions for screen readers. By adding ARIA-label equals open quote search close quote to a search button within the user interface, screen readers will announce it as a search function, helping users to understand its purpose. In the example on the right, the button is given an ARIA label of search. ARIA-label equals open quote search close quote, which provides an additional description specifically for screen readers. Now that our page is compatible with screen readers, let's focus on making forms accessible. Forms are one of the main ways users interact with a website, and they should be easy for all users, including those using screen readers or keyboards for navigation. Each form field should have a clear, descriptive label. This helps screen readers identify the purpose of the input fields. For an email input field on a form within our web page, we'll add open caret label space for equals open quotation email close quotation close caret email address open caret slash label close caret above the input field. This tells screen readers that the user needs to enter their email address here. When users make a mistake while filling out a form, provide clear, specific instructions for fixing the issue rather than vague error messages. If a user enters an invalid email address, instead of displaying the word error, we'll display the message, "Please enter a valid email address" to guide them. Now that we've covered how to make individual elements accessible, let's ensure that accessibility is integrated into the development workflow from the beginning. Accessibility shouldn't be an afterthought. Consider it from the start at the design phase and use testing tools throughout development to catch issues early. For our page, we'll choose high contrast colors for the text and background, use semantic HTML for structure, and ensure all elements are accessible via screen readers. This will ensure that the design is inclusive from the beginning. Use tools like Axe or Lighthouse during development to check for accessibility issues. This helps identify problems early and ensure compliance with accessibility standards. Running an accessibility audit on our web page with Lighthouse, we find a few areas for improvement, such as missing alt tags on images. We can fix those issues before launching the site to ensure full accessibility. Accessibility isn't just about meeting standards, it's about creating a better user experience. By applying these techniques throughout the design and development process, you'll make sure your site is usable by everyone.
In this lab, you're going to use CSS and HTML to modify an existing web page so you can meet basic accessibility standards. You're going to focus on visual and navigational accessibility. In step one, just reviewing the existing web page. We have a fairly simple web page here, head section at the top. The body section includes a main section with subsections below it. Just has some links to various sections that talk about this community project. In this first step, you're just looking this over to make sure that you understand what the content is on this page and how it's structured. In step two, you'll be applying semantic HTML elements. Semantic elements help describe what the page contains for screen readers as well as for automation systems that might want to consume the content on the page. It just gives it some a better ability for tools to be able to read what's on the page. In the first section here, you're going to be modifying the image, and you're going to be applying alt text to that image. Alt text is good for screen readers. So if a screen reader is trying to read the page, the screen reader obviously at this point can't see the image that's on the page. So the alt text describes what's in the image. And here you're just adding alt equals as an attribute to the image tag and describing what is in that image. In step three, you're adding CSS for visual accessibility. So we're going to make the page a little bit better for those with visual impairments. To do this, you're going to add a style that's going to apply to the entire body. So all of the text on the body will get this style, and you'll be able to improve the overall presentation of the text on the body by applying this style. So here I'm going to display the page in the web browser, and I'll pin this to the side. We'll put our code on this other side here. So this is a extension in Visual Studio Code called Live Preview. And as I make changes to the code, they'll appear on the web page itself. So in step three, in order to add the body style, you're going to change the head, and you're going to actually add a style to the head section, the head element. And to do that, we're just going to I'm going to paste in the code here. So you see I have a style element, and in that style element, I've added the body CSS, the style. And again, that body style will apply to the body element in your HTML. And I've just made sure that the color's white in the background. The color of the text is going to be black. I've increased the font size to 16 pixels and the line height to 1.5 to make it a little bit easier. Now, if I remove that, you can see on the right side, you can see the difference in the page. When I remove the style, as I add it back in, you'll be able to see how it changes the page. Okay, step four, you're going to enhance keyboard navigation to make the page a little bit more accessible. So we're going to add some borders around the buttons and the link. We're going to change the way that the submit button is displayed by creating a class and then modifying and applying that class to the button. So the first thing we're going to do is add to our style element here in the head. And so I'm going to put in the styles for the buttons. You can see how that changed on the right here. For the buttons and the links, we're adding a black border. And then for the button, we're going to create no outline before the button has focus, and then we'll reapply the outline when the button does have focus. Now you'll notice that the button still has a border around it. That's because we haven't applied the class to the button yet. So I'm going to add that here. And we're going to add the modal class to the button. Now you can see the outline has disappeared. And then when we tab over to the button, you can see that it gets the highlights. That just makes it a little bit clearer that that button now has focus. The other thing that we did in our style is we set the Z index to 1. So the Z index brings the button to the top of the page in case there's anything else going on the page that might overlap the button. We're making sure that the button has focus. So that's what you're going to do in step 4. Step 5, we're going to address error handling. You're going to address error handling by adding a area described by attribute to the email field. And then you're going to add a message that will help inform the user for screen readers as well as visually for the user about what the input field for the email needs to have, what's required. So the first thing we're going to do is add this area described by. You can see that that's already here. Area described by error message. We don't yet have an error message field yet, but when we add that, whatever's in that field, a screen reader will be able to read it and then describe it to the user. So we're going to add the error message field, and that's just going to be a span below the input field. And you can see that that appeared here. The email is required. So we're letting the user know that that field must be filled in before they can submit. And when a screen reader sees detects the area described by attribute, it'll look for the error message span and then read whatever's between the span tags. Email is required. We want to color the span that we just created and make it a little bit more visible, and then add some other features to it to make it obvious that this is a required field, and to make it look just a little bit better so it doesn't blend in with the rest of the text. So you can see we have this class error applied to the span. And I'm going to go back up to the top in the style element and add the error class. So what that did is it colored the email as required message red. It made it bold and it made the font size 14. So that gives our element a little bit more style and helps the user to be able to see that it's there and that field is required. So those are ways that you can use HTML and how you're going to do this in this lab to apply some accessibility and style features to your web page.
Front-end engineers face a unique challenge, building interfaces that work and meet real user needs. How can we ensure that our solutions are functional and meaningful? In this video, we'll define design thinking and explore how front-end engineers can apply it in their workflow. First, let's start by defining design thinking. Design thinking is a problem-solving approach focused on understanding users, generating ideas, and testing solutions to create intuitive products. It is a strategy that leverages iterative and user-centric design and is used throughout a development's workflow to ensure the product meets the user's needs. This mindset is important in front-end development since everything built is meant to enhance the user experience. Let's explore what principles design thinking uses to remain user-centered. First, front-end engineers use empathy to understand your users. They consider what users need, what frustrates them, and how they will interact with your interface. As a front-end engineer, empathy guides how you approach wireframes, UI components, and responsive designs. Once you've understood user needs, you start designing. But the first design is rarely perfect. This is where iteration comes in. Front-end engineers collaborate with designers, developers, and stakeholders to test components across browsers, screen sizes, or environments to ensure the design holds up. Sometimes standard solutions aren't enough, and this is where creativity comes into play. Design thinking encourages front-end engineers to push boundaries, finding new ways to solve a performance issue or creating an interactive UI that engages users. Once you have brainstormed potential solutions, the next step is to create prototypes or wireframes. Collaboration with team members and users is key here, as their feedback can shape the final product. After prototyping, it's crucial to test the designs with real users to gather feedback. Usability testing allows front-end engineers to identify any pain points or issues users may encounter and make necessary adjustments. You're tasked with designing a job application portal. To begin, you gather insights on the users, job seekers with varying levels of digital skills. Many will access the portal on mobile, and some may have limited time to apply. With empathy, you create a user journey map to identify frustrations like long forms or poor mobile navigation. This helps you simplify the process by breaking it into steps, removing unnecessary fields, and designing mobile-friendly navigation. After building the first version of the form, you test it on different devices and browsers. You notice the layout appears cluttered on smaller screens. Through iteration, you adjust the CSS for better responsiveness, ensuring it works well on all devices. Team feedback suggests resizing text and improving button clarity. You make these changes, enhancing the form's usability with each round of feedback. Next, you realize that users may abandon the form if it takes too long to load or complete. To address this, you apply creative solutions like introducing autosave features, allowing users to return to the form later without losing their progress. Additionally, you implement lazy loading for the job listing section, ensuring that only relevant data loads first. This improves the page's performance while keeping the user engaged. Before finalizing the development, you create a clickable prototype of the application form using Figma. This allows you to present the design to stakeholders and users, enabling them to interact with the interface and provide feedback before moving into full development. The prototype helps you gather important feedback, such as adding a progress bar to show users how far along they are in the application process. This collaboration ensures that the design meets both user needs and business goals. Finally, after making necessary adjustments based on feedback from the prototype, you conduct usability testing with real job applicants. During the testing, you notice that some users struggle with the drop-down options when selecting job categories. Using these insights, you make the final adjustments by improving the drop-down's accessibility and implementing keyboard navigation for easier selection. This testing phase ensures the design is fully optimized for the end users. Design thinking shifts your focus from just coding to creating user-driven solutions that solve real problems. When you apply empathy, iterate, and collaborate, you create designs that are both functional and impactful. Why do some apps make everything so easy while others frustrate us at every turn? The answer lies in design thinking, which helps front-end engineers create solutions that meet user needs. In this video, we'll describe the stages of the design thinking process and their application in front-end engineering. To fully understand how design thinking works, we'll explore each of the 5 stages and discuss how it plays a vital role in front-end development. By following these steps, engineers can craft user interface, user experience designs that address user needs while solving practical challenges. In the initial stage, empathize, engineers learn about the users and their challenges and preferences. This might involve talking to users, conducting surveys, or observing how they interact with the app. Users of a fitness app, for instance, might struggle to find workouts suited to their available equipment, like needing routines that don't require weights. Understanding these pain points is key to finding effective solutions. After understanding user challenges, engineers analyze the data to pinpoint the primary issue. In the define stage, they clearly identify the core problem. In the fitness app, a user challenge could be user struggles to find workouts that match their equipment availability. Defining the problem helps engineers concentrate on addressing the most critical concern. With the problem identified, the next step is exploration, which occurs in the ideate stage. Here, engineers brainstorm creative solutions. Potential solutions for the fitness app could include adding filters for workouts based on available equipment or creating personalized workout plans tailored to user fitness goals and gear. After exploring possible solutions, engineers proceed to the prototype stage, where they create a simple version of their idea to test its functionality. Prototypes enable testing and feedback before fully developing the feature. This could involve creating a basic workout filter in the fitness app that allows users to select their available equipment and receive matching exercise routines. After creating the prototype, engineers test it with real users in the test stage. Users interact with the prototype, providing feedback that helps engineers refine it. This process reveals whether the feature meets user needs and is user-friendly. If users find the filter hard to navigate, engineers can improve the design to make it more intuitive and accessible. Now that we've covered the 5 stages of the design thinking process, empathize, define, ideate, prototype, and test, we can understand how crucial each step is in crafting user-centered designs. By following this process, front-end engineers can ensure that they address real user problems effectively and create more intuitive, accessible, and enjoyable apps. To build products that truly work for users, front-end engineers need more than code. They need design thinking, a process that ensures every solution is focused, tested, and improved with the user in mind. Have you ever wondered why some websites are easy to use while others leave you frustrated? For front-end developers, making a website intuitive isn't just about design. It's about solving real problems using a structured approach like design thinking. In this video, we'll provide examples of applying design thinking to solve front-end development challenges. Design thinking is a human-centered approach to problem solving that emphasizes empathy, creativity, and iterative testing. It is widely used in product design, innovation, and business strategy to create solutions that meet users' needs while also being technologically feasible and economically viable. Now, let's explore how a development team uses design thinking to solve a problem and improve the user experience. To start, the team needed to understand exactly what was causing users to struggle with the website. The company noticed that many users were leaving the site. To understand why, they interviewed users and observed how they navigated the website. Users mentioned that product categories were unclear and the menus were difficult to use. By gathering this feedback, the team identified that users were having trouble finding what they needed. After analyzing the feedback to identify common issues, the team needed to define the specific problem that they would address. Based on user feedback, the team defined the problem. Users need a clearer and easier navigation system to find product categories. This helped the team focus on improving the menu layout and product categories. With the problem defined, the next step was to come up with a creative idea for solving it. The team brainstormed ideas to improve how users could find products more easily. Some ideas included grouping similar products into clearer, more intuitive categories, providing an easy way for users to search for specific items, and designing a simple and clear menu to help users navigate the product options. After selecting the best ideas, the team created an early version of the new navigation system. It included changes like a clearer menu for product categories and a search option that allowed users to quickly find what they were searching for. This version wasn't final. It was just a starting point to test how well the new system worked for users. The team's next step was to test the new navigation system with real users to determine if it solved the problem. The team tested the new system with a small group of users. They watched how users interacted with the updated menu and search option. Most users found the changes helpful, but some suggested that the product categories could be even more specific. Based on this feedback, the team made further improvements and tested the system again. With the feedback from testing, the team made final adjustments and was ready to launch the improved version of the website. After making the necessary adjustments, the new version of the website was launched. It had a clearer menu for product categories and an easy-to-use search feature. As a result, users were able to find products more quickly, and the website saw a 20% increase in searches. The power of design thinking is in its ability to turn user frustrations into opportunities for improvement. By following this process, front-end teams can solve real problems, improving the user experience and driving business success. Mastering UI/UX design principles is essential to creating impactful digital experiences. By applying these foundational concepts, you'll be able to design interfaces that are visually appealing, user-centered, and accessible, key elements that enhance user engagement and drive the success of any digital product. We began by exploring the foundational concepts of UI/UX design, revealing how intentional design choices transformed user interactions and enhanced engagements in digital applications. Next, we identified the key principles of effective design, such as balance, alignment, and visual hierarchy, uncovering how these elements contribute to creating visually appealing and intuitive interfaces. Then, you explored user-centered design, learning to prioritize user needs and goals in every design choice. This approach ensured that interfaces were both functional and genuinely connected with users on a practical level. Next, you examined accessibility best practices, discovering ways to make digital content more inclusive. You identified strategies to enhance usability for everyone, promoting equitable access and meeting accessibility standards. Lastly, you engaged with the design thinking process, applying each stage to front-end development. This method equipped you to develop creative, user-focused solutions that effectively address real-world challenges. Understanding and applying UI/UX principles is essential for crafting interfaces that are visually compelling, user-centered, and accessible. Each design decision, from layout to accessibility, contributes to a more engaging and inclusive digital experience, setting the foundation for impactful, user-focused solutions. Welcome to Using Design Tools for Mockups. This module will guide you through essential prototyping and interaction design skills, from using Figma and Adobe XD to building wireframes and high-fidelity mockups that elevate user experiences. By the end, you'll be equipped to create dynamic, visually engaging designs and collaborate seamlessly with your team to bring your ideas to life. We'll start by introducing the core principles of prototyping and interaction design. We'll focus on creating dynamic and interactive elements that enhance user engagement in your front-end projects. Next, we'll identify essential design tools like Figma and Adobe XD and uncover how to easily navigate these platforms to streamline your UI/UX development process. After that, you'll examine creating effective wireframes using design tools to structure and organize interface layouts for a smooth user journey. Then, you'll explore how to develop high-fidelity mockups, building realistic visual representations that bring your design ideas closer to a final product. Finally, we'll identify the best practices for collaborating and sharing your designs, ensuring seamless teamwork and clear communication to bring your UI/UX concepts to life. By the end of this module, you'll have the tools and techniques to create interactive, user-friendly designs and collaborate effectively with your team. Let's get started. What if you could catch design flaws before they become costly mistakes? Prototyping allows you to do just that, helping to shape user-friendly products by testing and refining ideas early in the process. In this video, we'll define prototyping and explain its role in user interface, user experience design. To begin, let's define prototyping. Prototyping is the process of creating an early, simplified version of a product to explore ideas and functionality. Prototyping helps uncover design flaws early, enhancing the user experience before moving into full development. Prototyping starts with ideation. Ideation refers to the creative process of generating, developing, and refining ideas to solve design problems or improve user experiences. With that in mind, let's outline the steps for prototyping so you can understand how the process works in practice. The first step in prototyping is ideation. During the ideation process, designers will brainstorm features and think about how users will interact with the product. For an app that helps users track their water intake, the development team might brainstorm features like reminders to drink water or charts to show progress. Ideas like this may start out simple, but through ideation, they can be developed into something practical and actionable. That's where wireframing comes in. After ideation, the next step is to organize your ideas visually through wireframing. Wireframing is the process of creating simple layouts for an app or website. These layouts focus on structure and user flow without adding fully fleshed out details like colors. In the water tracking app, a wireframe might display the layout of the main screen with buttons for adding a water drinking schedule and viewing progress. The wireframe helps the team focus on how users navigate the app and decide the best placement for interactive elements. Once the team has decided on an appropriate user flow and visual layout, they move on to the next step, which is low-fidelity prototyping. After organizing the layout, designers create a low-fidelity prototype to test basic interactions. A low-fidelity, lo-fi prototype is a basic, clickable mockup of app screens that are sequenced to mimic a user flow. Lo-fi prototypes are created with tools that organize the mockups into a series of actions that a user might take to perform something, such as locating the weekly water progress chart. A low-fidelity prototype is like a rough draft of the prototype. In the water tracking app, a lo-fi prototype could allow users to navigate between the home screen and progress charts. By user testing of the lo-fi prototype, this helps gather feedback and how easy or difficult it is to use. Once the lo-fi prototype is tested, the next step is to incorporate user feedback and add details to create a high-fidelity prototype. The high-fidelity or hi-fi prototype includes colors, fonts, and interactive elements. It feels like the final product and allows for testing both the design and user experience. For the water tracking app, the hi-fi prototype would include design elements like branding, colors, and animations. Design teams use ideation, wireframing, lo-fi prototyping, and hi-fi prototyping to meet the needs of their intended users. If their needs are not successfully met, this iterative process may start again. With user interface, user experience, the user experience is the most critical aspect of the design. Prototyping isn't just about creating a product. It's about ensuring the design works for users. By testing ideas early, front-end engineers can ensure the final design is functional and user-friendly. Every time you interact with a website, subtle design choices guide your experience. Understanding these design principles is a key to building websites that users find intuitive and easy to navigate. In this video, we will describe the key principles of interaction design relevant to front-end engineers. Let's start by exploring the key principles of interactive design. The first key principle, feedback, lets users know their actions were successful, like a button changing color after being clicked or a message confirming a form was submitted. For instance, when a user clicks Submit on a form, JavaScript can display a confirmation message letting them know the form was sent. Now that users are receiving clear feedback from their actions, the next step is to ensure consistency across all parts of the site. Consistency ensures that design elements like buttons and colors appear and behave the same across the site, so users know what to expect. CSS ensures elements appear consistent, while JavaScript makes sure actions are predictable. For example, CSS can style all buttons the same, and JavaScript can ensure all buttons trigger the same action, like confirming a submission. After consistency, we have affordance, which provides visual cues that help users understand how to interact with design elements. The design or appearance of an element suggests its function, like a button that appears raised indicating it can be clicked, or a field with a blinking cursor indicating it's ready for typing. Affordance is made clearer with JavaScript by enabling interactive elements. For instance, a drop-down menu with an arrow indicates that there are more options when clicked, and JavaScript can be used to expand it when the user interacts with it. Finally, there is usability, which is about how easily users can complete tasks on a website, such as finding and purchasing a product. CSS and JavaScript work together to improve usability by making the site responsive and interactive. For example, JavaScript can display additional product details, when users hover over an item, making the browsing experience more efficient. As we've explored the foundational principles of interaction design, feedback, consistency, affordance, and usability, it's clear how each plays a vital role in creating seamless user experiences. By mastering these interaction design principles, feedback, consistency, affordance, and usability, you can create natural web experiences to keep users coming back. Turning a static design into a fully functional website requires more than just coding. One key step in the process is using prototypes to connect design and development. In this video, we will explain how front-end engineers use prototypes to bridge design and development. A prototype is an early simplified version of a product to explore ideas and functionality. Prototypes help front-end engineers show both stakeholders and developers how a website will function and appear. They reduce misunderstandings early on, ensuring everyone is clear on the design before development begins. With prototypes in place, let's discuss how they help communicate ideas with stakeholders, like clients or managers, who have a vested interest in the project. Imagine a front-end engineer tasked with creating a product page for an e-commerce site. The designer provides static mockups, but now the engineer needs to demonstrate how the page will function. Next, the engineer develops a prototype to demonstrate how users interact with the design, providing clarity on user actions. The engineer uses a clickable prototype to show stakeholders how users will interact with the design. For example, the prototype allows users to hover over a product image, click Add to Cart, and navigate to checkout. After showing interactions to the stakeholders, the next step is to ensure the design is understood before moving to development. The front-end engineer shows the prototype to developers to ensure the design's interactions and transitions can be implemented correctly. In the next step, the engineer shares important details about specific interactions to guide development. The engineer explains interactions like hover effects and page transitions, showing how product images zoom when hovered over and how the cart slides into view. This helps developers understand exactly what needs to be built. After collaborating with developers, the next step is to verify that the design is technically feasible for implementation. The prototype helps bridge the gap between design and development, ensuring developers understand how the design should function in real time and making it feasible to build. Once the feasibility is confirmed, it's time to test how the website's user interface behaves, ensuring it works as expected before full development begins. Engineers use prototypes to test features like drop-down menus, hover effects, and page transitions to ensure they work correctly. After testing general user interface behavior, engineers need to confirm that specific interactions, such as how buttons respond to user actions, function properly. For instance, engineers test whether the drop-down menus open and close smoothly and if product images resize correctly when hovered over. Adjustments can be made if needed. Now that specific interactions are tested, we need to ensure the design works properly across all devices and screen sizes. Engineers test prototypes across devices, ensuring features like animations and responsive design perform smoothly on all screen sizes. This prevents issues later in development. Finally, let's confirm that the design and interactions function consistently on various devices, ensuring a smooth user experience. For example, they check how animated transitions perform on mobile phones and adjust them if there's any lag. Testing ensures that interactions function well across different platforms. As we've discussed, prototypes play a crucial role in bridging the gap between design and development, allowing engineers to communicate clearly with stakeholders and developers. By thoroughly testing the prototype, engineers can confidently move into development, knowing the design is functional. Early testing helps identify issues, making the transition from design to development smoother and more efficient. How do front-end engineers ensure that a design not only looks good, but functions exactly as intended before writing a single line of code? Tools like Figma and Adobe XD make this possible by transforming ideas into interactive prototypes. In this video, we will explain what design tools like Figma and Adobe XD are and why they are important for front-end engineers. Let's start by defining Figma. Figma is a cloud-based tool that allows teams to design user interfaces, UI, and create interactive prototypes or mock-ups of the final product. These prototypes show how users will interact with the interface. Figma allows multiple people, including front-end engineers, to work on the same project in real time. Now that we've covered Figma, let's examine how Adobe XD works and differs. Adobe XD is part of Adobe's Creative Cloud suite, making integrating with tools like Photoshop or Illustrator easy. It's used for designing interfaces and creating prototypes just like Figma, but it's often preferred by teams who already use Adobe products. Adobe XD also allows you to work offline, which is helpful when an internet connection isn't available. Now that we know what Figma and Adobe XD do, let's discuss when to use each. Let's start by discussing when to use Figma. Using Figma when your team needs to collaborate in real time makes it easy to communicate critical design features and information to your teammates. It also stores all of the communications in one place. Because Figma is cloud-based, everyone, especially front-end engineers, can access and work on the latest version of the design from anywhere. This ensures that the whole team is always aligned with the most up-to-date changes. Now, let's discuss when to use Adobe XD. Use Adobe XD when you're working heavily with other Adobe products like Photoshop or Illustrator. The seamless integration allows you to easily bring assets into your project without disrupting your workflow. Adobe XD is also great when you need to work offline or in environments with unreliable internet access. Now that we've compared the two tools, let's discuss how they might be applied in a real-world project. When developing a complex project like a mobile app interface, both Figma and Adobe XD can be leveraged to maximize efficiency and collaboration. Let's discuss an example scenario illustrating when to use each tool and how they complement each other. A team of front-end engineers is tasked with developing a mobile app interface. The design team has decided to use both Figma and Adobe XD for the project in different phases. For the first phase of development, research and initial design, the team uses Figma. Collaboration and feedback are crucial in the early stages of design. Figma's real-time collaboration features allow multiple designers, product managers, and stakeholders to brainstorm and iterate on wireframes and initial design concepts together through the creation of a low-fidelity prototype. The second phase of design involves creating a high-fidelity design, which the team plans to use Figma for. As the design evolves into high-fidelity mockups, Figma's component libraries and design system capabilities make it easy to maintain consistency across the app, ensuring the typography, colors, and UI elements are consistent. For the third phase in the development, prototyping, the design team uses Figma. Figma's prototyping features allow for the creation of interactive prototypes that mimic a user flow to complete an action easily. It is extremely valuable to be able to share these prototypes with stakeholders and user testers for quick feedback. As the design team prepares to hand the design off to their developers, they decide to use Figma. Figma's handoff features provide developers with necessary design specs and assets directly within the platform. Using Figma's features to generate CSS, export assets, and create design specifications, developers can easily inspect the designs without needing additional tools. For the final phase of developing a mobile app, the design team uses Adobe XD to make detailed iterations and updates as user feedback is analyzed. Adobe XD can be beneficial for making detailed visual tweaks or integrating assets created in other Adobe tools. The development team can easily refine UI elements or create specific design assets that require advanced graphic features like animations and transitions. In this scenario, Figma is primarily utilized for its collaborative features, ease of prototyping, and design system capabilities, while Adobe XD is introduced in later phases for specific tasks where its strengths, like detailed graphics or animations, can complement the overall design process. Ultimately, the choice of tool may also depend on team preferences and existing workflows. Establishing clear guidelines on when to use each tool can streamline collaboration and maintain efficiency throughout the project. By using Figma and Adobe XD, front-end engineers can bridge the gap between design and development, ensuring that the final product aligns with the user's needs and the design's vision. Turning great design ideas into functional, consistent, and scalable products is no easy task. To bridge the gap between creativity and development, front-end engineers rely on key tools like Figma and Adobe XD. In this video, we will identify the key features of Figma and Adobe XD that are relevant to front-end engineers. We will be exploring the key features of Figma and Adobe XD that front-end engineers use to ensure their designs are consistent, scalable, and aligned with development. First, both programs use artboards, which help engineers organize screens, ensuring consistency across devices like desktops and mobiles. They also make sure your design adapts well across various screens. Now that we've covered artboards, let's continue on to layers, which organize design elements like text and buttons. Layers allow designers to stack, group, and reorder elements like text, images, and shapes, ensuring a clear hierarchy. This feature makes it easy to inspect and adjust each part of the design without affecting the rest. After organizing with layers, you may need to reuse components. Component libraries store reusable design elements such as buttons, icons, or branding, ensuring consistency. For example, updating the Add to Cart button in the library will automatically update it across the entire site. Next, let's discuss real-time collaboration. Designers and engineers can work on the same project together at the same time with changes visible instantly to keep everyone aligned and working efficiently. Once your team is aligned, it's time to test the design through prototyping. Prototyping lets you test interactions like buttons and menus, ensuring the design is user-friendly and helps catch issues early, preventing costly mistakes during the development process. After testing, it's time for developer handoff. Built-in handoff tools allow engineers to extract CSS values and assets directly from the design, ensuring accuracy in the final code. Finally, let's explore how these tools come together in a real-world project, a responsive e-commerce website. To create a responsive e-commerce website, the designers use artboards that mimic the sizes of a desktop or mobile phone to create their website layout. Next, the designers add elements to the artboards and arrange them using layers. For example, the designers add background colors, business branding, logos, and icons, assigning each to its appropriate layer, making it easier to edit later. The company logo may lay on top of the website background, while the Add to Cart button may lay over a product image carousel. To keep the design consistent, the design team creates components like brand banners, logos, and icons that fit the design needs. These components are saved in a component library and pulled from each time an asset is needed, like a business logo, for example. As the designers work on the website layout, they can share their designs with the front-end developers who can view the design in real time and collaborate with designers. Developers can leave notes or add questions directly on the design that the design team can address immediately, keeping the developers informed. Once the design layout is approved by the stakeholders, it moves on to prototyping. For the e-commerce website, this may include a featured products section on the website homepage that makes it easy for customers to find new products. By creating a prototype, the design team can test the actions of their users and discover if the featured product page works properly and easily for their users. By mimicking the actions of an actual website, the design team can collect feedback and address any challenges the users may experience while using the website. With a prototype complete and user feedback addressed, the e-commerce website design is exported from Adobe XD or Figma into HTML and CSS and handed over to the developers, who will bring the design to life, including the featured products section of the home page. By using these features in Adobe XD or Figma, design teams can ideate, design, collaborate, and problem solve quickly and easily in real time. With tools like artboards, layers, component libraries, and real-time collaboration, front-end engineers have everything they need to turn creative designs into fully developed, scalable, and consistent user experiences. Front-end engineers are the key to turning creative designs into dynamic, responsive websites and applications. With powerful tools like Figma and Adobe XD, they seamlessly connect the world of design and development. These tools not only streamline the process by generating code and exporting assets, but also ensure that the final product stays true to the original vision, with consistent, polished results every time. In this video, we'll describe how front-end engineers can leverage Figma and Adobe XD to generate code snippets, export assets, and maintain design consistency in their work. Now that we've established our focus, let's begin by exploring the features of Figma and Adobe XD. First, Figma and Adobe XD allow front-end engineers to directly generate code snippets like CSS or SVG from design elements. This saves time by eliminating the need to manually write code for design specifications and ensures accuracy between design and implementation. To generate the code snippet in the program, you select the element you're working on in your design tool, like a button, icon, or any other user interface component. Next, use the built-in inspector to check out the code behind it. This tool automatically generates the CSS or SVG code for the selected element, making things easier. Then, copy the automatically generated CSS or SVG code. For example, let's say you're designing a button in Figma. The tool might give you a CSS snippet like this. From here, all you need to do is copy that code and paste it into your own CSS file, making sure your button matches the design perfectly. In addition to generating code, front-end engineers can use Figma and Adobe XD to export assets such as icons, images, and UI elements in formats suitable for web and mobile development, for example, PNG, SVG. Select the asset, such as an icon, in the design file. Export it in the desired format, SVG, PNG, JPEG. Use the exported asset in your development environment. For example, if you've designed a set of icons for a navigation bar, you can export each icon as SVG. You can embed the SVG code directly into your HTML or link to the exported file using img space src equals open quotation icon.svg close quotation space alt equals open quotation navigation icon close quotation space backslash close caret. One of the most important aspects of front-end development is ensuring that the final product remains consistent with the original design. Figma and Adobe XD help engineers maintain this consistency by using shared component libraries and design systems. Using shared components such as buttons or forms across multiple pages or screens. Any design updates, for example, changing the color of a button, automatically apply across all instances of that component. Suppose a designer updates the color of a submit button in the component library. In that case, the new color is applied throughout the project. Using the updated component in your code ensures that the final website or app consistently reflects the changes, preventing discrepancies between design and development. Front-end engineers leverage Figma and Adobe XD to streamline their workflow by directly generating code snippets and exporting design assets with ease. These tools ensure that designs are accurately translated into code and that assets like icons and UI elements are optimized for development. Figma and Adobe XD are invaluable tools for front-end engineers. They enable them to generate code snippets, export assets, and maintain consistency between design and development. By using these tools, front-end engineers can streamline their workflow, reduce errors, and ensure that the final product matches the original design vision. Mastering these features will improve your efficiency and enhance the quality of your work, bridging the gap between design and code seamlessly. Every great building starts with a blueprint. In user interface, user experience design, wireframes are that blueprint, laying the foundation for a functional, user-friendly product. Without them, creating a clear and well-organized design would be nearly impossible. In this video, we'll explain why wireframes are essential in the user interface, user experience design process. Let's begin by defining the meaning of a wireframe. A wireframe is a basic outline that shows the structure of a website or app without including visual elements like colors or images. It's like a blueprint that focuses on how the layout is arranged. Wireframes do more than just map out structure. They are critical to the overall design process. Let's examine the importance of their role. Wireframes are essential because they help organize content, plan structure, and ensure everyone, designers, developers, and stakeholders, understands the design before detailed work begins. Now that you understand the important role wireframes play in the design process, let's discuss how design teams further benefit from using them. One key reason wireframes are important is that they establish a clear information hierarchy. Let's examine how that works. Wireframes show what content is most important and should be seen first. For example, on a news website, breaking news stories would be placed at the top, while sections like weather or opinions follow. This way, users easily find the most critical content first. Once you know what content is most important, the next step is organizing it logically. This is where wireframes help with content organization. Wireframes arrange content in a way that makes sense for users. Think of a shopping cart page. The items, total price, and checkout button need to be organized clearly so users can complete their purchase without confusion. After organizing the content, wireframes also help ensure that the layout matches the goals of the product stakeholders. Let's discuss this next. Wireframes let stakeholders, such as clients or business managers, review the layout before visual design begins. This ensures the design aligns with business goals. For example, if a company wants a large call to action button for subscribing to a newsletter, the wireframe ensures it's placed prominently on the homepage so the stakeholders can approve it early. By keeping stakeholders aligned, wireframes also save time and resources in the process. Wireframes help avoid costly changes by catching layout issues early. It's much easier to adjust a wireframe than to change a fully developed design. For instance, if a wireframe for a blog layout shows there isn't enough space for text or images, it's simple to adjust at this stage, saving time later. Now that we've talked about planning, let's move on to how wireframes guide the next step, development. Wireframes give front-end engineers a clear guide for coding the layout. This helps them focus on structuring elements like buttons or menus without needing to consider colors or graphics yet. For instance, on a restaurant website, the wireframe would show where the menu, reservation button, and contact information should be. This would make it easier for developers to start building the site. Wireframes not only outline the structure of a design, but also connect the design and development stages. They give front-end engineers a clear guide for where key elements like buttons and menus should go, allowing them to focus on building the layout without worrying about visual details. This helps designers and developers work together smoothly, ensuring the final product is both functional and visually appealing. Without a solid wireframe, even the best designs can fall apart. It's the wireframe that turns ideas into a functional structure, ensuring a clear, organized, and successful design process. Building a website without a clear plan can lead to confusion and wasted time. Wireframes provide a structured way to organize your ideas and communicate them effectively before any design or coding begins. In this video, we'll identify tools and techniques for creating wireframes suitable for front-end engineers. To start, let's explore some of the most commonly used tools for making wireframing straightforward and collaborative: Microsoft PowerPoint, Figma, and Adobe XD. First, Microsoft PowerPoint offers a simple, accessible way to create wireframes using basic shapes. By offering an intuitive interface with a variety of drawing tools, alignment features, and formatting options, it allows users to easily arrange and customize shapes to represent different UI elements, group and layer components, add text, and simulate interactions. This makes it a practical choice for wireframing without the need for specialized design software. Second, Figma is perfect for teams. It allows real-time collaboration and editing and enables multiple users to work on the same design simultaneously. Team members can view each other's changes as they happen, share feedback directly within the design file, and leave comments for discussion. This streamlines the design process, reduces the need for back and forth communication, and ensures everyone stays aligned. Finally, Adobe XD provides advanced features for high-quality wireframes and easily sharing with developers. It offers advanced design tools, interactive prototyping, and interaction with design systems to create high-quality wireframes. Its developer handoff features and seamless sharing options ensure an efficient transition from design to development, making it ideal for collaborative workflow. Now that you know the tools, let's walk through the steps of creating a wireframe using these tools, starting with the layout structure. After selecting your tool, the first step is to structure your web page using shapes and grids. A grid system divides the page into sections, making it easier to align elements like text and images. It also ensures the design adapts well to different screen sizes, such as mobile and desktop. For example, in Figma, you can organize the layout using a 12-column grid. Place a large image at the top with 3 sections below for the menu, special offers, and reviews. This ensures the design is clean and responsive. With the layout in place, it's time to add placeholder content to see how the elements fit together. Now, you add placeholder text for the coffee descriptions and gray boxes to represent images. For example, placing a placeholder for the Order Now button shows where it will go, even if the real text and images aren't ready yet. After adding placeholder content, the next important step is to gather feedback from stakeholders and your team. Once the wireframe is ready, share it with the coffee shop team for feedback. This step helps clarify where everything will go, like the featured coffee carousel or Order Now button. When gathering feedback, ask whether key elements are in the right place and if the navigation feels intuitive. Sharing early ensures everyone understands the design before moving to the next steps. After getting feedback, the final step is refining your wireframe based on the input you've received. Once you gather feedback, make adjustments to improve the layout. For instance, if the shop owner suggests making the Order Now button more visible on the page, you adjust the layout accordingly. Focus on structure such as moving buttons or simplifying navigation, and avoid worrying about design details like colors at this stage. The better your wireframe, the smoother the design process will be, making sure that everyone from developers to stakeholders stays aligned. Starting with a solid wireframe saves time and helps avoid costly mistakes later. Before any visual design comes to life, the foundation of a great user experience is laid through wireframes. So how do you ensure your wireframes are effective and communicate the right structure? In this video, we will describe best practices for creating effective wireframes. Now that you understand the role wireframes play in building a seamless user experience, let's explore some best practices for designing wireframes. First, we have simplicity. Instead of worrying about colors or detailed graphics, focus on the core elements of your web page, like the layout and functionality. For instance, if you're designing an online store, you can use rectangles to represent images and boxes for text. This helps you focus on how everything is organized, not on the final visual design. It's also important to ensure that your wireframes are easy to understand. To achieve this, you should use a consistent visual language. This means using the same shapes and icons throughout your wireframes so that everyone can interpret them correctly. For example, if you're using a circle to represent buttons, make sure all buttons across your wireframe follow the same style. This consistency helps others recognize and understand the design quickly. Even with consistency, some details might still be unclear. That's where annotations come in. Annotations are brief, explanatory notes added to wireframes to clarify how design elements will function. Annotations help explain what elements do. Include annotations to explain how things will function. These notes describe what each element does and how users will interact with it. For instance, if you're working on a login page, you might add a note next to the Submit button explaining that it validates the form and submit user data. This ensures developers or other stakeholders understand the functionality. Once you've added annotations, it's time to gather feedback by testing and refining your wireframes early in the process. This step helps you catch issues and make improvements before committing to final designs. For example, if you're working on a dashboard wireframe, sharing it with users lets you notice if they can navigate it easily. Their feedback gives you insights to enhance the layout before moving forward. Testing and refining at this stage ensures your wireframe is both user-friendly and effective. By following these wireframing best practices, you're ready to engage in a well-organized and effective design process. Clear, consistent, and simple wireframes help communicate ideas effectively and set the foundation for a successful project. This creates a foundation for a great user experience for any web page or application. Have you ever wondered how a rough sketch becomes a polished, detailed design ready for development? Understanding the journey from wireframes to high-fidelity mockups is the key to creating products that function well and captivate users. In this video, we will explain the transition from wireframes to high-fidelity mockups. Let's first examine what wireframes are and why they are so important in the design process. A wireframe is a basic outline that displays the structure of a website or app without including visual elements like colors or images. It's like a blueprint that focuses on how the layout is arranged. They allow teams to collaborate and align on the placement of essential components early in the process. For example, in a homepage wireframe, you might notice where the navigation bar, search box, and content will go, but without any color or images. Now that we have explored wireframes, let's examine high-fidelity mockups. High-fidelity mockups are fully designed versions of the product, including all visual elements like color, fonts, and images. They provide a realistic representation of the final product. Now that we have explored both wireframes and high-fidelity mockups, let's examine how they come together. As designers move from wireframes to mockups, they begin to add layers of detail through visual elements that transform the mock-up's skeleton structure into an engaging, polished design. A basic homepage wireframe, for example, evolves into a mock-up by incorporating colors, fonts, and placeholder images to represent the final product. Once these visual elements are in place, it's time to gather feedback to refine the design to ensure it is both functional and visually appealing. Mock-ups allow for feedback from stakeholders or users, which helps improve the design's appearance and functionality. This stage is crucial for refining usability and ensuring the design aligns with user needs before development. For example, in a shopping app mock-up, users might suggest changing button sizes or colors to make the interface easier to use. Collecting and acting on feedback ensures the design is not only aesthetically pleasing, but also optimized for functionality. Once mock-ups are refined and approved, they are handed off to developers. The mock-up serves as a guide for how the product should be built, with exact instructions for colors, fonts, and images. For example, developers building an e-commerce site will follow the finalized mock-up to match the product's layout and interactions exactly as designed, ensuring consistency between the design and the final result. Imagine you're creating a homepage for an e-commerce website. The process starts with a wireframe, a simple outline that displays the structure and placement of key elements without any color, fonts, or images. In this wireframe, you position the logo in the top left corner, the navigation bar along the top, and a large hero section just beneath it. Below, you block out spaces for product categories and a footer with contact information. The goal here is to determine the layout and ensure that everything is arranged logically for easy navigation. Now that the wireframe is complete, it's time to transition to a high-fidelity mock-up. The mock-up keeps the same structure as the wireframe but introduces visual elements that bring the design to life. For example, the previously empty hero section now features a colorful banner with an image of products on display and a large eye-catching Shop Now button. The navigation bar includes stylish fonts and color palettes that are chosen to reflect the brand's personality and tone. This mock-up transforms the wireframe from a bare-bones layout into a visually compelling and engaging user interface that represents what the final product will appear like. Once the mock-up is created, it's essential to gather feedback from stakeholders or potential users to ensure that the design is both attractive and functional. During this stage, you might receive feedback that the Shop Now button isn't prominent enough. To address this, you adjust the button size, make it a brighter color, and place it higher in the hero section, ensuring it grabs the user's attention. This stage is critical because it helps fine-tune the design, ensuring it meets both business goals and user expectations. After refining the mock-up with feedback, the next step is handing it off to the development team. The mock-up serves as a detailed visual guide that includes exact specifications for fonts, colors, images, and spacing. The developers use this mock-up to ensure the final product appears and functions exactly as intended. Transforming wireframes into high-fidelity mockups involves more than adding visual details. It's about turning the structure into a complete, user-ready design. Mastering this transition ensures a seamless handoff from concept to creation. The way a web page appears and feels can define how users connect with it. High-fidelity mockups helps you combine the key visual elements of your design to create a visual identity that resonates with and engages users. In this video, we will identify the elements that make up high-fidelity mockups. High-fidelity mockups showcase detailed visual elements like colors, topography, and layout. Let's explore each of these elements. First, let's examine an important element of high-fidelity mockups, topography. Topography refers to the style and appearance of text used in your user interface, and it plays a very key role in how users perceive and interact with your design. Typography is important not only for readability, but also for establishing a brand's tone and personality. For instance, a tech company might use a clean, modern font like Roboto to communicate a sense of simplicity and innovation, qualities that match the company's image. Color schemes are another element that heavily influences your design by helping set the overall tone and mood. Brand color should match the brand's identity and help communicate its appeal to users. For instance, a fitness app might choose a lively color scheme that includes vibrant colors like green and blue to help create a feeling of energy and health. Icons are another key element of high-fidelity mockups. They enable you to define and lay out user interaction and navigation within your design. Icons are small graphics that represent functions or concepts. They help users quickly identify and understand options without relying solely on reading text. Icons provide visual cues that help guide users intuitively through an interface. For instance, a finance app may use a wallet icon to represent payment options and a lock icon to reassure users that their security is a priority. Visual cues like this help users interact with your design intuitively. While choosing the right icons can help your users interact with and navigate your design, selecting the right imagery can help you communicate a particular tone and enhance overall visual appeal. Choosing the right imagery, such as photos, illustrations, and graphics that enhance your design, will help you tell the brand's story visually. For example, a travel app might use images of incredible vistas or beaches to inspire users to take action by booking their next adventure. Now, let's bring these elements together to examine brand identity. A brand's visual identity consists of a combination of typography, color scheme, icon, and imagery. Visual identity helps tie a specific design to a specific brand. Consistency in these key elements creates a recognizable and trustworthy interface. For example, an eco-friendly brand can use simple fonts, earthy tones, and organic imagery to highlight its focus on sustainability. These cues form a visual language that helps users immediately connect with the brand's mission. Let's explore some examples of how typography, color scheme, icons, and imagery can help you build a high-fidelity mock-up that establishes the right visual identity for a brand. First, let's examine typography. You should always pick a font that is not only easy to read on different screen sizes, but also consciously matches the brand's character and style. For example, a luxury brand might opt for an elegant serif font to convey sophistication, giving users a sense that they're interacting with a high-end, premium experience. You should also use colors that align with the brand and work well together for a consistent appearance and feel. For instance, in a children's app, using bright, playful colors instantly creates a fun and inviting atmosphere, drawing young users in and keeping them engaged. Choose icons that are coherently designed, simple, and intuitive. A good example is a familiar e-commerce staple, the shopping cart. This icon is instantly understood to represent items that you've selected for review and purchase. Iconography like this helps users easily and intuitively interact with your site with a minimum of effort. Imagery is another critical component of your design that enables you to communicate the right visual identity while enhancing overall visual appeal. Use impactful, high-quality images and graphics that align with the brand's message and enhance user interest and engagement. For example, if you're designing a food delivery app, you will want to use images of fresh ingredients or deliciously prepared dishes to build trust and make users excited to place their orders. By combining the key elements of high-fidelity mockups to establish the right visual identity, you can create designs that align with your brand and deliver a cohesive, engaging experience for users. In this video, we explore the key elements that make up high-fidelity mockups, like typography, color schemes, icons, and imagery. Using these elements in the right combination will help you shape your application's visual identity, ensuring the final design aligns with brand guidelines and delivers a coherent user experience. If you're designing a new website for someone else, chances are your client wants to know exactly how it will appear and function before it's built. That's where high-fidelity mockups come in. They help you create a realistic, polished design that accurately represents the final product's style and functionality. In this video, we will describe tools and techniques for creating high-fidelity mockups. Figma and Adobe XD are powerful tools used by designers to create realistic, interactive mockups that showcase style of the final product. Let's explore the different capabilities they offer to designers. Figma is ideal for collaborative design, allowing teams to create detailed mockups that include interactive elements. For instance, Figma allows you to design clickable navigation bars with links that change colors on hover, simulating user interaction on a live site. Adobe XD excels in helping you build responsive mockups that feel like real products. It allows you to create mobile versions of your design along with interactive workflows, like adding items to a cart, giving clients and stakeholders an authentic preview of the final design and functionality. Now, let's explore some essential tools in both Figma and Adobe XD that help manage the design process while maintaining consistency in your mockups. We'll start with components in Figma. A Figma component is a reusable design element, like a button or icon, that you'll use multiple times throughout your design. Components in Figma are great for keeping designs consistent because they allow you to make changes in one place and apply them throughout your mockup. Let's say you create a button component for the Add to Cart call to action in an e-commerce mockup. This button will be used multiple times in your mockup, and no matter where you use it in your design, you can be assured that it will always have the same design and behavior. This saves time and effort and keeps your design cohesive. Now, let's go over how to create and use components in Figma. In Figma, you create a component by designing an element, selecting it, and choosing Create Component. This creates a reusable component based on the element design, so if you make any future changes to the component, all instances of it will update automatically. For instance, if you later adjust the color of the Add to Cart button component, Figma will instantly update every instance of the button across the mockup, saving you the effort of repetitive manual updates. Now, let's explore styles in Adobe XD, another tool that helps ensure visual consistency in your mockups. In Adobe XD, styles are preset colors, fonts, or effects that keep designs consistent across the entire mockup. Imagine you have a style for headers throughout your app design. If you need to adjust the font size or color, you can update the style once, and it will automatically apply to every header throughout the mockup. This saves time and effort and keeps your design consistent. In Adobe XD, you can set up colors, fonts, and effects as styles in the Assets panel. Once applied, any changes you make to a style automatically update across all instances where it's used. For instance, you might define a style for button text. If you later decide that the button text needs to be larger, you can simply update the style, and all buttons in the mockup will adjust to the updated size automatically. Finally, let's move on to libraries, a Figma feature that allows teams to share and manage design elements across multiple projects. Figma libraries are collections of shared components and styles. Libraries are great for collaboration because they allow everyone on your team to share the same assets, ensuring that the overall design remains cohesive and on brand. For example, if you're working on a collaborative project, your team library might include your brand's colors, fonts, and icons, giving every designer easy access to these elements and helping to keep the design consistent. Figma makes it easy for you to do this by enabling you to organize components and styles in a specific team library so everyone on your team can access and use the same design assets. Any updates made in the library reflect across all related designs. For instance, if your primary brand color changes, updating it in the team library will apply to all mockups using that color. By mastering these capabilities and consistently using them in your projects, you and your team will be able to design professional, consistent, high-quality mockups efficiently and collaboratively. In this video, you learned about key tools and techniques for creating high-fidelity mockups. Mastering the capabilities provided by tools like Figma and Adobe XD, such as components, styles, and libraries, will greatly enhance your ability to design professional, high-fidelity mockups. The most user-friendly designs come from teams that work together seamlessly. When designers, stakeholders, and developers combine their strengths, the result can be more impactful than any one person could achieve alone. In this video, we will explain why collaboration is crucial in the UI/UX design process. Collaboration enhances the design process by integrating multiple diverse perspectives, leading to solutions that are both creative and practical. For instance, a designer might conceptualize a visually appealing layout, but when a developer provides input on performance constraints or technical limitations, the design evolves into one that is both pleasing and functional. Throughout this iterative process, the team refines ideas, ensuring that the final product delivers a well-designed and seamless user experience across devices. This collaborative approach helps ensure that both creative vision and technical feasibility align, resulting in a well-rounded, high-quality outcome. Collaboration also keeps everyone focused on the same design goals. In UI/UX design, achieving consistency requires teamwork. Collaboration ensures that designers, developers, and other stakeholders align their efforts to support shared visual and functional principles. For example, the team might collaboratively decide on navigation design and button style across all app pages. Through an ongoing dialogue, they ensure that each member applies such design choices consistently, whether working on navigation elements, buttons, calls to action, or other components. This unified approach results in a visually balanced and intuitive interface. By fostering alignment through collaboration, the team ensures every component of the design works together harmoniously, leading to a seamless user experience that meets both aesthetic and functional expectations. Collaboration enhances the final design and helps streamline the project by facilitating smooth and efficient progress. When teams collaborate openly, they align efforts early and often, enabling more efficient decision-making and preventing costly delays. For instance, when a designer and developer work closely from the beginning, they can identify potential challenges, such as code limitations or layout inconsistencies, before they become problems. This proactive collaboration helps the team avoid rework, keeps the project on schedule, and ensures that every feature is implemented with as little downstream churn as possible. By staying aligned throughout the process, the team saves time and delivers a more polished, high-quality product. Next, let's explore open communication, an essential component of effective collaboration. Open communication helps ensure that team members freely exchange ideas and provide constructive feedback. For example, when a designer shares a new layout concept, the developer can immediately highlight technical constraints or offer suggestions for improvement. This continuous dialogue allows both parties to align their expectations, preventing miscommunication and fostering a deeper understanding of what's achievable. Through this collaborative exchange, the team creates a design that balances innovation with functionality. Regular cross-functional meetings are a key element of effective collaboration. They ensure smooth communication across the entire team by bringing together team members from various roles, keeping everyone aligned and informed. For example, during weekly check-ins, designers, developers, and stakeholders share updates, discuss challenges, and address evolving needs. This collaborative approach ensures that every team member stays abreast of progress, becomes aware of potential roadblocks, and can quickly make any necessary adjustments. By maintaining this ongoing alignment, the team keeps the project on track and adapts efficiently to changes. Along with meetings, regular feedback loops are essential for effective collaboration, enabling continuous improvements throughout the project. Feedback loops provide structured opportunities to review progress and refine the work at every stage, ensuring each iteration is better than the last. For example, after the first draft of a UI layout, team members might offer suggestions on button placement or font size to enhance usability. With every round of feedback, the design evolves, becoming more refined and user-friendly. The iterative process helps foster continuous improvement, driving high-quality results. In this video, you learned why collaboration is crucial in the UI/UX design process. Collaboration is the foundation of impactful design, enabling UI/UX teams to work together effectively to create experiences that are cohesive, accessible, and resonate with users. Imagine you're part of a team designing a new app. You've created the initial layout, but now it's time to gather feedback from developers, stakeholders, and users. Collaboration tools make this process seamless by letting everyone share ideas, make suggestions, and see changes in real time. With the right tools, every piece of feedback contributes to a polished, user-centered design. In this video, we'll identify tools that make collaboration and feedback easier in UI/UX design. Collaboration in UI/UX design brings designs to life by blending diverse insights and refining ideas. 3 tools make this process smoother: Google Slides for gathering early feedback and aligning ideas, Figma, and Adobe XD for creating interactive designs and prototypes. Each adds unique value at different stages of the journey. Together, these tools support a seamless progression from initial ideas to a fully interactive prototype. Let's start with Google Slides, a tool commonly used to present and receive feedback on initial design ideas. Google Slides allows team members to add comments directly to a slide, ideal for sharing early feedback on design concepts. Real-time commenting ensures everyone can see and respond to each other's ideas right away. For instance, a designer might leave a comment suggesting a layout change to improve visual balance, which other team members can respond to and discuss on the same slide. Google Slides also supports link sharing, which makes it easy to share presentations with team members or stakeholders. Shared links allow others to view and provide feedback without needing special permissions. For example, a designer might share a link to an initial layout, making it simple for everyone to access and give input before moving forward. Once initial ideas are discussed in Google Slides, Figma allows the team to work with the actual design elements, adjusting colors, layouts, and styles in real time for a more precise visual experience. Let's explore how Figma supports this stage of design refinement. Figma is designed for interactive, real-time design work. Multiple team members can work on the same design file at once, making live edits and adjustments. This feature reduces delays and miscommunication, as team members can instantly see and respond to changes. For example, a team might adjust the placement of icons or buttons as the team collaborates, creating a unified vision in real time. Figma's commenting feature allows feedback directly on specific design elements. This makes feedback highly relevant, as team members can comment precisely where changes are needed. If someone suggests a different color for a button, they can leave a note directly on that button, allowing the designer to quickly see and implement the suggestion if it aligns with the team's vision. As designs become more detailed, moving on to Adobe XD can help take them to the next level by making them interactive. Let's see how Adobe XD supports feedback and interaction testing for a realistic user experience. Adobe XD allows designers to create interactive prototypes, giving teams a feel for the final product. With features like clickable buttons and page transitions, stakeholders can navigate the prototype as users would, providing feedback on the user flow and overall experience. For example, a project manager might test the prototype and suggest adjustments to make navigation smoother. This level of feedback is invaluable for refining the user journey. Adobe XD also supports direct comments on specific interactive elements. This targeted feedback lets team members clarify how each interactive element should function. For instance, a developer could leave feedback on the functionality of a drop-down menu, ensuring it meets accessibility and usability requirements before development. This attention to detail helps create an intuitive, user-friendly design. Each of these tools may not be needed on every project, but design teams can transform initial concepts into polished, user-centered products by choosing the tools that will help the use based on the project and design preferences. In this video, we identified tools that facilitate collaboration and feedback in UI/UX design. Google Slides, Figma, and Adobe XD each play a vital role, from early feedback to interactive prototyping, making it easy for every team member's insight to shape a seamless, effective design. Great ideas only reach their full potential when teams can work together seamlessly. Effective collaboration and clear feedback transform creative concepts into successful, polished results. In this video, we will describe best practices for effective collaboration and feedback. Effective collaboration starts with clear and consistent organization. Let's start by understanding how to organize our files in ways that help us collaborate more effectively as a team. While collaboration tools make sharing and updating files simple, using them effectively requires that your team keep all its design files organized. Organized files help your team work efficiently and easily identify the latest file versions, so everyone knows they're working with the most current information. First, use consistent naming conventions like project underscore, name underscore, version underscore, date. This helps everyone quickly identify the latest version without confusion. For instance, naming a file website underscore homepage underscore v3 tells the team it's the third version of the homepage, so everyone knows they're working with the latest version. Second, create folders for each project stage, like drafts, feedback, and finals, so team members can find exactly what they need without searching through multiple versions. When your team uses a finals folder, everyone knows that's where to find the most current design that's ready for review. Finally, archive older versions to keep the main folder clutter-free. This helps everyone focus on active versions of the latest design files with minimum distraction. With our files organized, the next step is to ensure clear feedback and communication. Organized files keep everyone up to date, but clear communication ensures that everyone is on the same page, helping reduce errors and keeping the project focused and on track. Let's discuss how clear communication can keep everyone aligned and make feedback more effective. First, be specific with feedback. Instead of saying something like, make X better, use more specific feedback like, increase the background contrast on this page to improve readability. This gives clear guidance so designers know exactly what to adjust and why. Second, use visuals to support comments. For example, you can add sticky notes to highlight specific details or circle things that need adjustment to help everyone know exactly where to focus their edits. Finally, encourage questions to ensure everyone understands the feedback. When team members ask questions, they're more likely to address feedback thoughtfully and accurately, saving time and reducing the need for future revisions. Along with clear and consistent communication, structured design reviews help ensure that everyone is aligned and that expectations are clear. Design reviews are meetings to discuss progress, share updates, and collect feedback. Regular reviews help teams stay on track and catch any issues early, preventing delays. Design reviews also create opportunities to address issues early, making the collaboration process smoother. Let's explore how regular design reviews can keep us aligned and ensure that feedback is applied consistently throughout the project. First, set up a regular schedule, like weekly or bi-weekly, to review design work. Regular and consistent check-ins prevent issues from piling up so the team can make steady progress. Second, have all necessary files ready and accessible before the meeting. Uploading files to a shared platform in advance lets everyone review them ahead of time, which keeps meetings focused and efficient. This way, everyone arrives prepared, and the meeting time can be used for meaningful discussions. Third, ask participants to prepare comments or questions in advance. When team members bring prepared feedback to the meeting, discussions stay focused and on point, making the review more productive. Preparing questions or notes in advance also helps ensure that everyone's insights are heard. Finally, summarize feedback at the end of the meeting to clarify action items and maintain workflow efficiency. Documenting each piece of feedback and assigning it to specific team members helps ensure that everyone understands the next steps and knows what to do after the meeting. In this video, you learned about best practices and techniques for effective collaboration and feedback. Mastering these concepts will help you and your team leverage your strengths more effectively as you work together to share ideas, collect feedback, and iterate on designs. By keeping communication clear, organizing your team's project assets, and holding regular reviews, you'll streamline your workflow and uplevel your team's ability to create designs that truly connect with users. Understanding prototyping, wireframing, and mockup creation is essential for crafting user-friendly interfaces that captivate and guide users. By mastering these techniques and tools like Figma and Adobe XD, you'll be equipped to build seamless, interactive experiences and collaborate effectively, setting the stage for successful UI/UX projects. We began by exploring prototyping and interaction design fundamentals, emphasizing how to create engaging, interactive elements that brought your front-end projects to life. Next, we discovered key design tools like Figma and Adobe XD, learning to navigate these platforms to simplify and enhance your UI/UX development process. Following that, you examined the process of building purposeful wireframes, applying design tools to lay out and organize interfaces, and guiding users effortlessly through their journey. Then you moved on to developing high-fidelity mockups, creating detailed visual representations that transform your design concepts into near-final visuals. Finally, you explored strategies for effective collaboration and design sharing, promoting smooth teamwork and transparent communication to bring your UI/UX visions to reality. Mastering prototyping, wireframing, and high-fidelity mockups lay a strong foundation for creating intuitive, user-centered designs. With skills and tools like Figma and Adobe XD and effective collaboration techniques, you're equipped to bring your UI/UX concepts to life in a streamlined, impactful way. Welcome to implementing responsive design using CSS. Here, you'll gain essential skills to create adaptable, user-friendly designs that look great on any device. With these techniques, you'll be ready to build modern websites that engage users and deliver a seamless experience across all screen sizes. We will begin by introducing responsive design principles and exploring core concepts that ensure web content looks great on any device. Next, we will examine media queries, discovering how to adjust layouts and elements for different screen sizes to create truly adaptable designs. Then, we will discover techniques for building flexible layouts and apply practical approaches for arranging content fluidly across devices. After that, we'll explore mobile-first design principles, emphasizing strategies that prioritize mobile functionality and smoothly scale to larger screens. Finally, we'll examine testing and validating your responsive designs, practicing methods to check functionality across various devices for a seamless user experience. By the end of this journey, you'll have the skills to design adaptable, responsive websites that captivate users on any screen. Let's begin. If you opened the website on your phone only to find the text and buttons spilling off the screen, it would make your experience on that website incredibly frustrating. Responsive design addresses issues like this and many other UX challenges by ensuring a smooth user experience on any device. In this video, we'll define responsive design and its role in web development. Let's start by defining responsive design. Responsive design is a web development approach that ensures websites appear and function optimally across all devices. The goal of responsive design is to create a seamless user experience, enhancing usability and accessibility regardless of the device being used. To achieve this, web developers follow a few key principles to ensure that content appears good and works properly on all devices. First, they use fluid grids instead of fixed sizes to let content resize smoothly across different screens. The fluid grid system is a responsive web design approach that uses flexible, proportional measurements to create layouts that adapt smoothly to different screen sizes. Fluid grids use percentages instead of fixed sizes to let content resize smoothly across different screens. Think about setting an image to be 50% of the screen width so it changes size automatically as the screen gets bigger or smaller. Another important principle of responsive design is flexible images. Flexible images are images that automatically scale to fit within the parent container, adapting to different screen sizes. Flexible images scale with the screen so they don't overflow or get distorted. Without flexible images, they might get cut off or appear stretched on smaller screens. While flexible images ensure that media scales correctly within a design, media queries control how a design adapts to screen size. Media queries adjust layouts, fonts, and other styles based on the device's screen size. This ensures that the overall structure of the web page remains usable and aesthetically pleasing on any device. Media queries let developers change the layout based on the device features like screen width. In CSS, you can write a media query that says, if the screen is less than 600 pixels wide, switch to a single column layout. This way, the site automatically adjusts for smaller devices like phones. While media queries handle the visual adjustments for responsive web design, meta tags provide essential information to browsers and search engines. Meta tags are informational elements included in a web page that provide essential details about the content, purpose, and context of the page. They are crucial for ensuring that web pages scale and render correctly on various devices and screen sizes, enabling better adaptability and user experience. Without meta tags, a website could appear zoomed in or out on mobile devices, making it harder to navigate. In this video, you learned about the importance of responsive design and its role in web development. By following the key principles of responsive design, you can develop websites that are flexible and easy to use on any device, ensuring a smooth and consistent experience for everyone. Users access websites from a multitude of devices, each with different screen sizes and resolutions. Web developers use responsive design to create web pages that work across devices, improving the user experience. In this video, we'll describe the key benefits of implementing responsive design. Let's first define what responsive design is. Responsive design is a web development approach that ensures websites appear and function optimally across all devices. Now, let's explore some of the benefits of working with a responsive design approach. One benefit of responsive design is enhanced accessibility. This means that websites are easier for everyone to use, including those relying on screen readers or keyboard navigation. Choosing a responsive design ensures that a web page will be user-friendly for a broad range of customers, including those with color vision deficiency, or CVD, and individuals who rely on screen readers. This approach not only increases a page's reach by broadening its potential market, but also fosters inclusivity. Responsive design also improves your site's search engine optimization, or SEO. Search engine optimization determines how high your site appears in search results. Search engines like Google tend to favor mobile-friendly sites that offer a great user experience. A responsive, mobile-friendly website boosts a web page search rankings, which translates to more visits and ultimately more business for the site. Another benefit is how responsive design keeps users engaged. A responsive site increases user engagement by encouraging users to stay longer and explore more. No matter what device a user happens to be using, a responsive site will adjust smoothly to their screen size. This ensures that design and functionality remain consistent and that they won't need to zoom in or scroll horizontally on smaller devices. This leads to higher engagement and longer time spent on a site. A final benefit of responsive design is that it significantly lowers development and maintenance efforts by eliminating the need to build and support separate websites for desktop and mobile users. This saves time, effort, and money. By implementing a single website that automatically adjusts and optimizes layout and functionality based on the device being used, developers offer a seamless, low-maintenance solution that gives their users a consistent user experience. In this video, you learned about the key benefits of implementing responsive design. By leveraging responsive design, you can help ensure your website stands out with a seamless cross-platform user experience while enhancing accessibility, SEO engagement, and reducing cost. Crafting sites that offer seamless, enjoyable experiences across devices demands both responsive and adaptive design approaches. Each of these methods offers its own advantages for building visually appealing, user-friendly sites that meet accessibility standards and provide an inclusive experience for all users. In this video, we'll explain the difference between responsive and adaptive design approaches. Let's first examine how adaptive design displays content for varying screen sizes. Adaptive design is a web design approach that uses multiple preset fixed layouts for different device types and screen sizes and serves the most appropriate layout based on the user's device. Unlike responsive design, which uses flexible grids and adjusts fluidly to any screen size, adaptive design focuses on delivering unique, predefined layouts for different devices and screen sizes. Let's explore some of the key characteristics of adaptive design. Adaptive design calls for creating multiple layouts that are optimized for particular device categories, such as desktops, tablets, and mobile devices. These layouts don't automatically scale, but instead are designed to work best on specific devices. So when a user accesses a site, the appropriate layout is served based on the detected screen size. In adaptive design, you use breakpoints, which are specific screen widths at which the layout breaks or changes to determine which layout to serve the user. For example, your breakpoints might be 320 pixels for mobile devices, 768 pixels for tablets, and 1024 pixels for desktop. The website detects the user's screen size and, based on predefined rules, serves the layout that best fits that size. Adaptive design allows you to create custom experiences for different device categories, so you can optimize each layout individually for the best experience on each type of device. For example, content-heavy features like large images or detailed product descriptions may be included in the desktop version, but reduced or removed in the mobile version to optimize the user experience. Now that we've explored how adaptive design works, let's compare it with responsive design to help us decide which approach is most appropriate for specific scenarios. Let's start by exploring some of the main differences between these two approaches. Adaptive design requires creating and maintaining multiple versions of the site, each with a distinct layout. This increases upfront development time and means that updates need to be applied separately to each layout type. By contrast, responsive design may require less upfront design and coding time because it relies on a single, fluid code base that works across all devices. Any changes made to the website automatically apply across all devices, making responsive sites faster to spin up and comparatively less complex to update or troubleshoot. Adaptive design can offer better resource loading and performance since each device gets only what it needs. For example, you can serve smaller images or simplified layouts to mobile users, which improves load times. By contrast, responsive design loads all of a website's resources and adapts them to the user's device. Since the same code, images, and scripts are sent to all devices, larger assets may slow down the experience for mobile users if not properly optimized. As new devices or screen sizes become popular, adaptive design may require additional layouts or updates to accommodate these devices. As such, it's better suited to situations where the target devices are well known and unlikely to change rapidly. Since responsive design is fluid, it can automatically adapt to new devices, screen sizes, and resolutions without needing additional work. As new devices such as foldable phones, smartwatches, or ultra-wide monitors emerge, a responsive design can more easily adjust to fit those screens. While adaptive design and responsive design have key differences, they also share several similarities. Let's examine where these approaches overlap. The primary goal of both adaptive and responsive design is to deliver a high-performing, aesthetically pleasing, and accessible experience regardless of a user's device or screen size. In addition, both adaptive and responsive design recognize the growing dominance of mobile traffic and aim to deliver an experience optimized for mobile users. This means that both approaches base their design strategies on ensuring fast load times, easy navigation, and usability on smaller screens before scaling up layouts to larger screens like tablets and desktops. Both the flexible grids of responsive design and the device-specific layouts of adaptive design have a single purpose: to maximize usability, readability, and accessibility on different devices. Each approach aims to optimize the user experience by adjusting layouts, menus, images, and other components to ensure ease of use across various device types and screen sizes. While responsive and adaptive design are distinct web design approaches, each offers its own advantages for building visually appealing, user-friendly sites that work seamlessly across different devices and screen sizes. In this video, you learned about the difference between responsive and adaptive design approaches. Both adaptive and responsive design offer features that help you develop applications that provide great experiences to all users. Have you ever noticed how a website can look perfect on both your phone and your computer? That's not magic. It's responsive design, and it all starts with understanding how media queries work. In this video, we'll define media queries and their role in responsive design. Let's start by defining what media queries are and how they help us create responsive designs. Media queries are a CSS feature that lets you apply styles based on a device's characteristics, like screen width, height, resolution, or orientation. Now that we understand media queries and how they work, let's examine why they're crucial for responsive design. To use media queries effectively, it's essential to understand how they are written in CSS code. Media queries start with the @media CSS rule, followed by conditions and styles. Web developers use breakpoints to define the conditions and styles and determine media query behavior. Breakpoints are specific screen widths that determine how a responsive design adapts to different devices or viewports. Typically, breakpoints are set in a logical sequence: 600 pixels for mobile, 768 pixels for tablets, and 1024 pixels for desktops. In this example, the breakpoint specifies that the media query will apply only when the screen width is 600 pixels or smaller. It's a good practice to place media queries right after the styles they modify. You can certainly place them at the end of your CSS file as well, but placing them near the related styles, like your navigation bar or image gallery, keeps your CSS organized and easy to maintain. Let's bring this all together with an example. In this example media query, when a user views the website on a screen 600 pixels or smaller, the page's background color changes to light gray. Additionally, the dot container element, which allows you to apply styles to a group of content within a specific area, expands to 100% of the screen's width and adds a 10-pixel padding around its content to make the layout responsive and readable. Finally, the dot navigation element, which defines a section of the page that contains navigation links, is hidden from view. This could potentially simplify the page for mobile devices or allow for a different type of navigation system, like a collapsible menu. This dynamic flexibility offers several key benefits for responsive design. Let's take a look at some of these benefits. By adjusting styles based on device characteristics, media queries ensure that content remains accessible and usable, improving readability, navigation, and overall user engagement. Media queries also allow developers to maintain a single code base that adapts to different devices. This reduces the need for separate websites or applications for each device, making development and maintenance easier and more efficient. Additionally, media queries make it possible to implement a mobile-first design strategy, where the base styles cater to mobile users and more complex layouts are added as the screen size increases. Now that you have a better understanding of media queries, let's take a look at how you can leverage them to ensure your content works seamlessly on any device. Media queries are essential for changing the layout based on screen size, ensuring that the design is appropriate for mobile devices, tablets, and desktops. Use them to collapse multiple columns into a single column, reorganize content, or hide certain elements on smaller screens. Media queries are also used to adjust font sizes for different screen widths to ensure readability. Text that is too large on a mobile device can cause excessive scrolling, while text that is too small can be difficult to read. Use media queries when the default font size will not scale well on larger or smaller screens. You can also use media queries to facilitate navigation on different devices. Complex navigation menus on desktops may not fit well on smaller screens, so media queries can be used to switch a horizontal navigation bar to a hamburger menu or hide certain navigation elements on mobile devices. Additionally, large images that load easily on desktop screens may take too long to load on mobile devices. Use media queries when you need to serve different image sizes or adjust image dimensions to improve performance and usability on mobile devices. You can use media queries to improve accessibility and usability across a wide range of displays by enabling a site's layout and content to adjust dynamically based on the user's device. This enables you to better tailor the experience to the user's context. For instance, a user accessing your site on their desktop would be presented with a wider grid layout that takes advantage of the greater screen width and ease of navigability offered in this setting. When accessing the same site on a tablet, the user would be presented with a tighter grid, optimized images and fonts, and more compact, touch-friendly navigation. And finally, on a smartphone, layout and navigation can be adjusted to better align with one-handed use when users are on the go, with images and fonts further optimized for fast loading and content stacked in a single column. Media queries are a critical tool in responsive design. They help ensure your website or a web application adjusts smoothly to different screen sizes, orientations, and devices. By using them thoughtfully, you can create a flexible, responsive design that provides a great user experience across all devices. In this video, you learned how media queries are essential to building flexible, responsive websites that provide an optimal user experience to your target audience, no matter what device they happen to be using. When browsing the web on different devices, whether a desktop, tablet, or phone, the layout often adjusts itself to fit the screen. This adaptability is a cornerstone of responsive design, and it's made possible by media queries. In this video, we'll identify common scenarios where media queries are used in responsive design. Media queries in responsive design are often used to enhance usability on various screen sizes by adjusting font sizes, rearranging layout grids, showing or hiding elements, and modifying navigation styles, ensuring the best reading experience on any device. Let's start with one common use, adjusting text size for tablets and mobile devices. Here's an example of a simple media query that applies styles when the screen width is 768 pixels or smaller, typically targeting tablets. Here, our media query is using the font size CSS property to reduce the body text size to 14 pixels to improve readability and avoid overcrowding the layout on medium-sized screens. For smaller devices such as phones, we can use the same CSS property to reduce the font size to 12 on screens with a max width of 480 pixels. This keeps things manageable on a smaller screen while helping maintain readability. You can also use media queries to rearrange your layout for improved readability. While multiple columns work well on desktops, they can feel cramped on small screens. Stacking the layout into a single column helps keep content clear and easier to read. Let's stack a multi-column layout into a single column that's more suitable for smaller screens. Here's another example of a simple media query that applies styles when the screen width is 768 pixels or smaller, typically targeting tablets. Here, the media query uses the Flex Direction CSS property to stack everything in the container vertically to form a single column layout on smaller screens. Rearranging the layout based on screen size helps organize content, but sometimes it's best to hide certain elements completely on smaller screens. Some elements, like banners or images, may be helpful on large screens but take up too much space on small screens. Hiding them keeps the design usable and focused. Let's use a media query to hide elements on screens that are 480 pixels or smaller to improve the user experience. This example media query targets small devices like smartphones and uses the display:"none" CSS property to completely hide the promo banner element from view on small screens. This helps to maximize the available visual real estate and provide a more targeted and usable experience on mobile devices. Now that we've covered hiding elements, let's adjust the navigation layout to ensure users can easily navigate your website on any device. A horizontal menu works well on a large screen, but on small devices, a vertical stack or drop-down menu is easier to navigate. You can use media queries to create a responsive navigation layout. Let's explore how we can do this. In this example, the media query uses the Flex Direction CSS property to switch the nav element to a single column layout on screens that are 480 pixels or smaller. This stacks the navigation links vertically and makes the navigation mobile friendly and more conducive to one-handed use. In this video, you learned about common scenarios where media queries are used in responsive design. By using media queries, you can ensure that your site provides a seamless user experience across a variety of devices and contexts and is usable, organized, and easy to navigate on any screen size. Building responsive websites that smoothly adapt to different screen sizes is essential to create an inclusive experience. Media queries help tailor layouts for various devices, but it's important to use them effectively for the best results. In this video, we'll explore the best practices for using media queries effectively to create flexible, responsive designs that work seamlessly on any screen size. Media queries are CSS techniques used to apply styles based on the properties of the user's device, such as its width, height, or orientation. They are essential in responsive and adaptive web design because they enable a web page to adjust its layout and appearance based on the screen size, resolution, orientation, or other media features. Now that we understand what media queries are, we'll discuss how to use them effectively. When implementing media queries, make sure to use breakpoints based on content needs, not devices. By focusing on how the content should flow and adapt, rather than targeting specific devices, you can ensure your design is flexible and adapts well across all screen sizes. For example, if your page layout consists of 3 columns and becomes cramped as the screen size decreases, set a breakpoint that switches to a single column layout when the content needs more space. By setting breakpoints based on content, your design maintains flexibility and naturally adapts to different screen sizes. This method ties directly to our next best practice, the mobile-first approach. A mobile-first approach means designing for the smallest screen sizes first and then adding enhancements for larger screens as needed. Starting with the smallest screen size ensures your core content is accessible while giving you the flexibility to add enhancements that optimize the experience for larger screens. For example, when designing a news article page, start with a single screen column of text with a few images for mobile devices. As the screen size increases, add enhancements like a sidebar for related articles on tablets or desktops. The mobile-first approach helps set clear breakpoints based on content and keeps media queries minimal. Reducing the number of media queries can simplify your design. Use a few well-planned breakpoints to cover major screen size changes. Using too many media queries can make your CSS harder to manage and debug. Think of a photo gallery. To simplify your design and keep code easier to maintain, use one breakpoint for a single column layout on mobile and another for a 3-column layout on desktops, rather than creating separate media queries for each small change. By keeping your media queries minimal, your layout becomes easier to test and debug. The next step is ensuring that your media queries work effectively across different devices through testing. Testing ensures that your media queries respond well across various devices and browsers. Once you have your breakpoints set, it's important to test your design on multiple screen sizes. This helps you identify any layout issues and ensure everything works as expected. Browser development tools are built-in features in web browsers that let you test your layout by emulating different screen sizes, using these tools to ensure your design adjusts properly on devices from mobile to desktop. Alternatively, online tools like Responsive Design Checker can help verify your design without needing physical devices. Regular testing allows you to address any issues and ensure your design remains responsive. Finally, you can make your design even more adaptable through the use of relative units. Relative units help your design adapt naturally to different screen sizes, reducing the need for multiple media queries. Instead of setting fixed sizes for elements, use scalable units that adjust with the screen size. You might use percentages to set the width of a container or EM units for font sizes, or use viewport width and viewport height to represent a percentage of the width and height of a browser window or viewport. This way, as the screen size changes, your layout elements and text will resize accordingly, maintaining readability and a consistent layout across devices. Using relative units ensures that your design responds automatically to screen sizes, complementing your media queries and making your layout more flexible. By using best practices like content-based breakpoints, a mobile-first approach, and smart testing, you'll create websites that deliver an optimal experience no matter what device your users have in their hands.
In this lab, you'll write CSS code and to incorporate media queries, and this will create a simple responsive web page. In step 1, you're setting up the basic HTML page. So you can see the we have a head section, and then below that in the body we have a header element, and it has an H1 as well as navigational elements. So the nav has an unordered list, which is essentially a list of bullets, and then a list item for the home, about, and contact references. Now those list items will appear as bullets on the page because we're using unordered list, and OL, an ordered list, would be numbers. You'd still use LI, the list item, for those, but they would appear as numbers. And then we finish out the rest of the page with a main section and then a subsection below that that has a paragraph tag and an image in that section as well. In step 2, we're going to be adding some styling to our page. And to do that, we're going to go up to the head section, add a style section and style element, and then we're going to apply a style to both the body and the header. And this is just going to make our body and header a little bit more interesting. Before we do this, we're going to look at the page in real time. So this is the page as it appears now. And I'm going to put this to the side of the window. And then I'll open up the HTML on this side. And as we make changes, this is called Live Preview Extension. And as we make changes to the code, we can actually see it appear here in our web page. So I'm going to go ahead and apply those two styles to our web page, and we'll see the changes that will appear on the page itself as we add the styles. So inside the head, I'm going to paste in our styles. So we've got a style that applies to the body and a style that applies to the header. We bumped up the font size to 16, the line height to 1.5, and no margin and no padding. And then we put a background color of a little bit of a dark gray on the header, and the color of the font is white. And these are all links. We can change the color of the links if they don't appear as nicely on the gray background if we wanted to, but for now we'll leave that. We can continue to modify that. Now, this is going to help us improve our web page as we continue to modify the styling here to make it a little bit more accessible. In step 3, we're going to add media queries for larger strings. Media queries can adjust how the page appears based on how large, how wide the page is. So if it appears on desktop, it'll look one way. If it appears on a mobile device, it'll look another way. And we're setting the minimum width that we need to use to apply the style in our media query. So I'm going to add that media query to the style element in the header. Again, we have a body and a header styling that's applied when the minimum width is 768 pixels. Anything smaller than that, then this style will apply. So we can take a look at how that works by shrinking the size of the web page. Let me actually pull it away from here. And now I'll move the page inside and out. And you can see when we pull the page out, the text in the header is centered to the page. When we have a smaller size screen, the text is left justified. So we can adjust based on the screen size. And you can see there in our media query and the header, the text align is center when it's large. The padding goes up to 20 pixels and the image width is 80%. We don't have our image here applied, but that would change as well as the page gets larger. That's what we're doing in step 3.
The effortless experience of navigating a website, whether on a phone, tablet, or laptop, is often the result of design using Flexbox. This powerful tool ensures a seamless user experience through functional layouts across all screen sizes. In this video, we'll explain how to use CSS Flexbox to create responsive layouts that adapt to any device. Flexible Box Layout, or Flexbox, is a CSS tool that helps arrange items in a container. Flexbox controls how this content is organized, adapting it to any screen size for a responsive experience. In CSS, a container is an element that acts as a wrapper for groups of other elements that make up your content. Containers are commonly used to control the layout, spacing, alignment, and positioning of the elements they contain. Flexbox CSS properties work together to arrange, space, and align content within your container, creating flexible, balanced designs. Let's examine these properties and how they are used. The first step is to set up Flexbox in CSS. This involves using the display::flex property to transform a container element into a flex container. Once you've done this, the child elements inside that container automatically become flex items, which can then be arranged and aligned along the main or horizontal and the cross or vertical axis. Now that we've set up a container in Flexbox, we can start to apply properties to the elements within it. The flex direction property in CSS defines the direction in which the container's items are placed along the main axis. It controls whether the items are arranged horizontally in a row or vertically in a column, and whether they are in default order or reversed. In this example, we've used the flex direction property with the value column to stack the items in our container vertically. Once you've set the main direction for your layout, you'll adjust how your items are spaced along the main axis. That's where the next property comes in. The justify content property aligns and distributes items horizontally along the main axis of a container. It controls how space is distributed between and around the items within the container. For instance, you would use this property to center a row of buttons or distribute images evenly across a gallery. Here, we've used the justify content property to center the content vertically in our container using the center value. In addition to setting your main direction and spacing, it's also important to control how your items are aligned relative to one another in order to create a clean and structured design. The align items property defines how the items inside a container should be positioned in relation to each other along the axis that is perpendicular to the main axis. For instance, in a photo gallery, this property would let you align images along the top, middle, or bottom of the container, ensuring a clean, organized appearance. In this example, we've used the align items property to center the items horizontally in our container using the center value. The flex wrap property defines whether items are allowed to wrap onto the next row or not. In this example, we've specified that items are allowed to wrap to the following row as necessary using the wrap value. The gap property creates space between the items and lines, which is useful for creating visually appealing and well-structured layouts. In this example, we've chosen to add a 10-pixel gap between our items to separate them from one another. Now that you understand these Flexbox properties, let's examine some of the main benefits of using Flexbox to build responsive web experiences for your users. Flexbox is great for creating responsive navigation menus. The items can be aligned horizontally on larger screens and stacked vertically on smaller screens. This enables you to create dynamic navigation bars that adapt to different screen sizes. Flexbox can help you create dynamic grid systems in which the number of items per row adjusts based on screen size. Because Flexbox is flexible, you can create grids in which items adjust their size and wrap as necessary. Flexbox makes it easy to create layouts that adjust dynamically based on screen size. It enables you to control whether items are placed in rows or columns, and you can easily switch between layouts using media queries to help ensure an optimal experience on any device. Flexbox supports flex wrapping, which allows items to wrap onto multiple lines if they don't fit on a single line. This is especially helpful when creating responsive grids or card layouts where the number of columns needs to adjust based on available space. Flexbox gives you full control over aligning and distributing items inside a container, enabling you to create usable and pleasing experiences tailored to each device type. This is crucial for responsive design, where items often need to be aligned differently depending on the user's scenario and screen size. Flexbox is a powerful tool that helps you create responsive, usable, and pleasing experiences for your users. By understanding its properties and how they work together, you can design balanced layouts that are visually appealing on any device. CSS Grid is an invaluable tool that brings responsive design to life. It creates flexible layouts that fit on any device and enables websites to effortlessly adapt to a variety of screen sizes from phones to desktops. In this video, we'll learn how to use CSS Grid to build responsive web layouts. Whether you're aiming for a simple structure or a more complex design, CSS Grid makes it easy to create responsive and adaptable layouts. So what is CSS Grid? CSS Grid is a two-dimensional layout system in CSS that allows you to design web pages using a grid-based approach. It makes it easier to arrange and align content on your web page. It is a grid that enables you to arrange items exactly where you want them on a web page. Let's use CSS Grid to add a responsive layout to an HTML document. We'll start with the style tag in our HTML document, which is used for embedding all the CSS rules that style the elements in our HTML. By defining the grid container class using .grid-container, we can specify all the styling that we want to apply to any grid container element in our document. We'll begin by defining our grid container by using the display::grid CSS property to first define the container as a grid layout. Now, we're ready to begin formatting our grid. Let's start by creating two equal width columns. We've used the grid-template-columns property to define columns with a 1FR unit of measurement, which specifies that each column should take up one fraction of the available space in our grid. Since our layout has two columns, each will take up an equal fraction of the available space, or 50%. Now that we've defined our columns, let's do the same thing for our rows. The grid-template-rows property, along with the value auto, means that the height of our rows will be determined by the content inside the row. This is critical for responsive design, where content needs to adapt depending on the screen size or device. Applying the auto value here ensures rows automatically expand or contract as needed. We'll finish styling our grid container by using the gap property to add a 10-pixel gap between items so that they're not bunched up together. This enhances usability, navigability, and visual appeal. Now that we've styled our grid container, we can style the individual grid items inside it. We'll use the .grid-item class to lay out our specifications for the items inside our container and make them stand out a bit. Here, we're setting the background color of each grid item to green, the text color to white, and adding 20 pixels of padding inside each grid item to create spacing between items. We're also improving readability by centering the text within each grid item and setting it to a readable font size of 20 pixels. Now that we've finished specifying our styles for both our grid container and the individual grid items it will contain, we're ready to close out the style tag and move on to the body of our document, where we'll provide the specifics for the grid container itself. To do this, we'll use the same grid-container class again, but this time inside a div element in the body of our HTML page. This is where we'll define the container for our grid layout, which will be styled according to the CSS rules we just specified in the style tag above it. Each of the 4 div elements represents an item inside the grid container. Here's how our example page would appear if we rendered it. As we specified within our style tag earlier, the 4 div elements inside the grid container are arranged into a 2-column grid with 2 rows with 10 pixels of space between each item. Each grid item contains 20 pixels of padding and uses centered 18-pixel white text on a green background. This grid layout will work well on large screens, but let's not forget that our page must be responsive. Let's ensure that the layout adjusts smoothly for smaller screens as well. To do this, we'll go back to our style tag and add a media query using @media. In practice, you'll want to make sure that you cover a large range of screen sizes from PC to tablet to smartphone, but for our example, we'll add a specific query that will apply only when the detached viewport width is 600 pixels or smaller, using max-width: 600 px in parentheses. On these size screens, the grid layout will change from a 2-column layout to a single column, making the content easier to scroll through and interact with, and better suited to one-handed navigation. Here's how our example would appear on a typical smartphone. Mobile users on smaller screens will be presented with a single-column layout that is more usable and much better suited to one-handed navigation. In this video, you learned how to use CSS Grid to build responsive web layouts. Whether you're aiming for a simple structure or a more complex design, CSS Grid will help you create flexible, adaptive sites that will work on any device. Creating a layout that's both simple and flexible can be challenging. Combining Flexbox and CSS Grid is an effective way to build adaptable and responsive web designs. In this video, we will identify scenarios where combining Flexbox and Grid provides optimal results. Both Flexbox and Grid are CSS models used to create page layouts in responsive web design. Developers use these models in combination to handle both simple and complex layout requirements, creating designs that adjust well to different devices. Let's discuss why web designers like to combine these 2 models in responsive design. CSS Grid gives you precise control over placement and sizing in both rows and columns, so it's ideal for structuring main content sections or complex layouts like dashboards. Flexbox provides flexible alignment and distribution of space within a container, making it ideal for laying out and aligning items within individual grid cells. This combination gives you a flexibility in defining a page's structure and fine-tuning details within each section, especially for components like headers, footers, and sidebars. CSS Grid allows for simplified management of columns and rows on a larger scale, making it easier to adjust layouts responsively based on screen sizes. Flexbox is highly effective for small, dynamic adjustments like reordering items within a row or changing spacing between items. Combining them lets you build responsive layouts that adapt to different screen sizes and devices with minimal CSS code. Grid helps you establish consistent layout patterns and spacing across pages while Flexbox allows you to control the internal alignment and distribution within each component. This combination helps you maintain a unified and cohesive design across different sections of your application or website, ensuring that the layout and alignment remain consistent regardless of the screen size. CSS Grid's syntax is highly intuitive for defining large layouts, while Flexbox's properties are well suited for smaller content adjustments. By using Grid to define large structures and Flexbox for small adjustments, you can keep your CSS organized, modular, and easy to maintain by making sure that each part of your layout has a clearly defined purpose. This makes your code base more readable and easier to troubleshoot. Combining Flexbox and CSS Grid in a single layout allows for powerful, flexible, and efficient design solutions. Each has unique strengths that complement the other, making them ideal for creating complex layouts that are responsive, adaptable, and easy to maintain. Let's examine some common scenarios in which these two models work together to create flexible, responsive designs. Think of the typical product gallery design you might find on an e-commerce site. The goal of such designs is to provide a responsive, organized, and visually appealing product gallery that is easy to navigate on all devices. Here's how the code for this frequently encountered scenario might appear. In this example, Grid is used to create a gallery structure with responsive columns that adjust based on screen size. This gallery contains our product cards, which are visual representations of each product, and include the product name or title, as well as buttons and calls to action that we would interact with when selecting the product. Meanwhile, Flexbox is used within each product card to align card items like product images, tiles, and buttons, ensuring a consistent visual flow. Let's consider another common scenario. Think about the last time you visited a typical blog. You probably noticed that the footer section contained a variety of information and links. Designers often use this section of the page to provide contact information, helpful links, and social networking options. Here's an example of the code a designer might use in this typical scenario. Here, we've taken advantage of Grid to define a multi-column structure for a footer with sections for external links and social media icons. Each section is assigned to a specific grid cell within the footer, creating a clear structure. Meanwhile, Flexbox is used within each footer section to align items in a way that makes sense for the specific section. Here, for example, we're choosing a vertical layout for the footer links. And in this section, we're choosing to center our social media icons for a more balanced appearance. Now think of how often you've come across a typical product page layout that uses a hero graphic with text and links superimposed on it. Typically, the hero section is a background image, and the overlay contains a title and a call to action link or button. In our example code for this common scenario, the designer has used Grid to create the overall hero layout, positioning the overlay in the center. Meanwhile, Flexbox has been leveraged inside the overlay to center align the title and call to action button vertically and horizontally. In this video, we discussed the advantages of combining Flexbox and Grid in responsive design and identified scenarios where using these two models together provided optimal results. By leveraging the strengths of both models, web designers create layouts that are adaptable, user-friendly, and easy to maintain.
In this lab, you'll be using Flexbox and Grid techniques to create a responsive layout on an HTML page. In step 1, you're setting up the basic HTML structure. You can see we have a head section, and then in the body we have a header. So we have our body tag, we have a header, and then we have an H1, which is a header text block, so that it will appear bold and large on the page. Down at the bottom we have a footer section. We're using divs to create the link section and the social section. So those will appear at the bottom of the page in the footer section of our web page. So you're just essentially setting up this basic HTML element, and then we'll modify it as we go along. In step 2, you're creating a responsive navigation bar by using Flexbox. And to do this, we're going to create styles in the head section of our HTML page. And to illustrate this, I'm going to actually show the page as it is now, and then we'll make the modifications as we go along. So let me pin this to the side, and then I will add our VS Code to the other side so we can see as we change the code how this updates in real time. To add the Flux grid, we're going to add a style to the head, and we'll see some changes as we add that style. You can see here we have a style sheet as well, but we can add the style inline right in our code. So as soon as we added that style, we saw some things change. We're using the Flux grid up at the top to modify the way that the HTML appears. So now the elements are appearing in a row rather than vertically. So they're appearing horizontally now that we're using the Flux grid at the Flux direction of row. And we're aligning the items to the center on the bar. And then we're setting the different properties like background color and the gap. Now we set the color of the text to white, but in the display, because they're links, they're appearing as blue. So we might want to change the background color of our nav bar to make it a little bit more visible, but we can do that as we continue to edit the web page. In step 3, you're going to organize the content with a CSS grid. So this will make it a little bit easier to lay out. And we're going to use a media query for this, as well as use this main content tag. So what we have to do here is, again, apply styles. We're going to apply a main content style and a media query to make our navigation a little bit easier. So I'm going to go back into the style element of the head, add more styling. So we have the main content class, and you can see the main content class is being applied on the main element in our body. So that main content class is displaying now this content as a grid. It has 2 columns, and it will repeat as needed. There's also a gap of 20 pixels between the columns, and we have some padding. So now we've got our grid applied to the middle section of our web page. We've also added a media query here. So when the max width is 768 pixels, then the template will change. And we can look at that by modifying how wide the page is. The media query will apply to smaller screens, particularly if you're on a phone, you'll be able to see those changes. In step 4, you're going to combine the Flexbox and the grid for better responsiveness. And we're going to apply these changes to the footer. We're taking these CSS classes, and we're using the classes to modify how the footer appears. I'm going to go ahead and paste those style sections into the head, and then we'll see the changes to the footer. So now the footer, the links are appearing as a row rather than as a column, and the footer is a dark gray. It's in a grid format. So as we make these changes to the HTML using these affordances, we can build more responsive layouts, and they will respond to smaller screens and apply a little bit different styling as the screen does change. It also expands and contracts a little bit nicer. So as we make the screen larger, the content in the middle section will expand into rows, and you can see that in the footer section, each section maintains kind of the same distance from each other, so it's a much easier way to read the links at the bottom. So that's how you can improve your layout and make it more responsive with these attributes in the CSS.
Today, over half of global web traffic comes from mobile devices. More than ever before, people are using smartphones to browse, shop, and interact online. Adopting a mobile-first design approach will ensure that your site provides a high-performing, usable, and consistent experience across all devices. In this video, we will define mobile-first design and explain its significance in responsive web design. Let's start by defining what mobile-first design is. Mobile-first design is a web design approach that calls for creating foundational designs for mobile devices first, and then progressively enhancing the design for larger screens. Since mobile devices have limited screen space and slower internet connections, this approach helps create a clean and user-focused experience. Let's explore some best practices for effectively adopting a mobile-first design approach. When using a mobile-first approach, start by wireframing your smallest target screens, like those found on smartphones. By starting with smaller screen sizes, you prioritize what users will interact with immediately, laying the groundwork for a focused and coherent design approach that you can progressively enhance for larger screens. Prioritizing core content and features is also a crucial aspect of mobile-first design. Mobile devices tend to have limited screen space, slower network connections, and rely on touch-based interactions. You want a streamlined and efficient experience, making sure that the most important content and features are discoverable, usable, and accessible. Finally, we also want to use responsive layouts to ensure that websites dynamically adjust and adapt to different screen sizes and orientations. A responsive layout aims to provide an optimal viewing and interaction experience across a wide range of devices, from small smartphones to large desktop monitors. This approach uses techniques like flexible grids, fluid images, and media queries to ensure that your site is easy to read, navigate through, and interact with, regardless of the device being used. Using responsive layouts in mobile design is essential because it ensures that websites adapt seamlessly to different screen sizes and devices. A responsive layout allows your content to be displayed optimally, whether it is viewed on a small mobile phone, tablet, or large desktop screen. In this video, you learned about mobile-first design and its significance in responsive web design. By optimizing your design for smaller screens and using responsive layouts to scale seamlessly across devices, you can ensure that your sites are always easy to read, navigate, and interact with, regardless of the device being used. Have you ever tried to select a button on a website only to miss it because everything's too small, or found yourself zooming in just to be able to read the text? Mobile-first design helps web designers address these challenges by ensuring that sites are appealing and easy to navigate on any device. In this video, we will identify the benefits of adopting a mobile-first design approach. Let's begin by examining how adopting a mobile-first design approach can help you improve user experience. Recall that mobile-first design prioritizes the most important content so your website remains highly usable on the smaller screens found on mobile devices. Since mobile devices have less screen space, this design approach removes distractions and unnecessary elements, creating an improved user experience. By streamlining the interface and highlighting key features, mobile-first design creates a more straightforward, more intuitive user experience. For example, a financial site might emphasize only critical announcements, account summaries, and account actions for quick access so that users aren't overwhelmed with too much content. This approach ensures that visitors are presented with the most important content first and can easily navigate the site to find information about their finances without unnecessary distractions. Mobile-first design is about more than ensuring better usability. It is also about optimizing performance for resource-limited mobile devices. Designing for mobile scenarios means prioritizing the loading of the most essential elements, like text and key images. By stripping away unnecessary content and features, the site becomes lighter, more performant, and quicker to load. In our financial site example, in addition to emphasizing critical announcements, account summaries, and account actions, our design will only use limited multimedia and minimal text instead of large, high-resolution images or videos that might be slow to load on a mobile device. This focus on performance helps keep users engaged and prevents frustration, especially when they're browsing on the go with limited data speeds. Finally, mobile-first design keeps your layout simple, making it much easier to adapt for larger screens like desktops. By starting with a clean, straightforward mobile design, you can later expand by adding features like extra navigation options, detailed information, or even a print button, all without disrupting the original layout. This way, you maintain the core design and features while enhancing the user experience on larger screens. For instance, our financial site could start by displaying only essential sections on mobile devices, such as announcements, summaries, and account actions. But when viewed on a desktop, the design can expand to include more detailed content, related links, and additional images, all while maintaining the same overall structure. This makes it easy for users to seamlessly switch between the two experiences based on their needs. In this video, you learned about the benefits of adopting a mobile-first design approach. By maintaining a mobile-first mindset, you can ensure that your site is not only visually appealing, but also functions seamlessly across a variety of user scenarios and devices. Mobile devices have become one of the primary ways people access the internet, with over half of global web traffic coming from mobile devices. By prioritizing mobile-first design, you can help ensure that your site is usable, accessible, and enjoyable for the broadest range of users and scenarios. In this video, we'll describe practical steps for implementing a mobile-first design approach. As we have learned, mobile-first design involves optimizing your website's content and features for mobile devices. So how is this done? One of the first steps in implementing a mobile-first design approach is setting up base styles. Base styles are the initial set of CSS rules that are applied to a web page and optimized for mobile devices by default. The idea is to use CSS to design the layout, typography, and other styling elements to work well on smaller screens first, before progressively enhancing the design for larger screens, such as tablets and desktops. In this example, we first use the viewport meta tag to ensure the layout adapts to the screen size of the user's device, setting a page width to match the width of the device. Now, we use the style tag to define the default styles that we want to apply to mobile devices. We use the font-size property to set the font to a readable size of 16 pixels, the padding property to set the padding to 10 pixels, and the line-height property to set the line height to 1.6 pixels. These settings help ensure easy readability on smaller screens. We also use the font-family property to specify that the text should be displayed using the Arial font. If Arial is not available on the user system, the browser should fall back to any generic sans serif font. After defining the base styles, we'll use media queries to progressively enhance the design for larger screens, like tablets and desktops. Using media queries can increase font sizes, adjust layouts, and add features that benefit larger devices. For example, we've written a media query that keys off the min-width property when the user views our page on a screen that is 768 pixels or less, the typical screen size of most tablets. When the user's screen matches these dimensions, the font-size property raises the body font size to 18 pixels, while the padding property increases the padding in the body to 20 pixels. This media query also uses the font-size property to increase heading sizes to 28 pixels to match the tablet's larger screen space, while the .container element sets the container width to 80% to prevent the content from being stretched too wide. With the structure set, it's time to prioritize content and make it easy for mobile users to access. Start with key details that users might need right away, like a clear title, a brief message, and a clear call to action. Avoid cluttering the screen with too much content. This will help users quickly find what they need without scrolling or searching. In our example, we are using the H1 header tag, which immediately grabs attention with a bold, prominent title that tells users what the page is about. The P or paragraph tag follows on the next line with a concise message that provides users with important key details directly after the title. Finally, a prominently placed Shop Now button using the A inline element tag with class button on the following line immediately presents a clear call to action for the user. Together, these elements ensure that users receive the most crucial information at a glance without having to scroll or search. Now that we've ensured the most important information is presented clearly, let's explore organizing visual content using CSS for layout and styling. First, we'll examine how to showcase multiple pages using a gallery. A gallery is a CSS layout used to display images, items, or cards in a visually organized grid format. A gallery helps make the page visually appealing, keeping the images neatly arranged, and uses space efficiently. Galleries also make it easier for users to browse and interact with visual content. For mobile scenarios, it's important to design galleries that adjust well to different screen sizes so users can view them easily. To create a gallery that works well on mobile, start by setting up a simple HTML structure and then use CSS to style it for different screen sizes. In our example, we're using a div element with the class attribute gallery to create a specific section on the page for our gallery of items. Next, we add 3 images to our gallery using the image tag and the src attribute to point the browser to the file path, which specifies the location of the target image file. Then, we use the alt attribute to provide a description of the image, which is important for accessibility and search engines. Finally, we close the div container to mark the end of our gallery section. We've now wrapped all the images in a container that can be styled with CSS. Now that we've created the basic structure for our gallery, let's move on to styling it for mobile devices. To ensure the gallery is visually appealing and functions well on small screens, we need to use simple CSS to make the text readable, add space around the content, and adjust font sizes. To do this, we set up the basic styles for the entire page by using the font-family property to specify a mobile-friendly font, in this case sans serif, and the padding property to specify a 10-pixel padding, providing enough space around the content so it doesn't touch the edges of the screen. Next, we use the font-size property to style the main heading using an 18-pixel font size, which is large enough to be easily readable on a small screen without being too overwhelming. Now, we define the paragraph style using the font-size property to specify an easy-to-read 14-pixel font size while using the line-height property to set the space between the lines of text at 1.6 pixels, making paragraphs easier to read. Now, let's turn to how to organize that content in a way that's easy to navigate. A single column layout works well for mobile. Content stacks vertically, making it easy to scroll and read. Since mobile users often scroll, this makes navigation simple. In our example, display flex turns the gallery element into a Flexbox container, while flex-direction column stacks our images in a single column. The gap property specifies a 15-pixel gap between the image tiles to separate them, and the padding property sets a 10-pixel padding around the gallery itself for a better visual appeal. After setting the base mobile styles, the next step is to ensure the layout adjusts well to larger screens. Fluid layouts and flexible images ensure that your content adapts to any screen size. In our example, we've used the width property to set the gallery width to 100% so that the images take up the full width of the container, while setting the height property to auto to maintain the image aspect ratio. Now that the layout adapts well to different screen sizes, let's ensure users can easily interact with it, especially on mobile devices. Here, we're using a media query that targets touch devices, where users interact without hovering over items, as they would with a mouse. The touch-action manipulation property improves responsiveness on devices with touchscreens by controlling what actions, like scrolling, zooming, or panning, can be performed by the browser in response to touch gestures. In this video, we learned about practical steps for implementing a mobile-first design approach. Starting with mobile-first CSS ensures a simple, efficient design that prioritizes key features for smaller screens. By using media queries to enhance the experience on larger devices, you create a smooth and consistent user experience across all screen sizes.
A well-designed site works seamlessly on any device, from desktop to mobile. Responsive design testing helps ensure that your users have a smooth and consistent experience no matter what device they use. In this video, we'll identify tools and methods for testing responsive design. First, let's define responsive testing. Responsive testing is a process that ensures a website appears and functions well on different devices, screen sizes, and browsers. Responsive testing helps you find and address layout or functionality issues across different screen sizes, resolutions, and device types. Several essential tools are available for web designers and developers to facilitate responsive design testing. Did you know that all major browsers incorporate developer tools that help you test how your site works across different devices? Both Google Chrome and Microsoft Edge come with a suite of powerful built-in dev tools that you can easily access by hitting F12 on your keyboard or right-clicking in the browser window and selecting Inspect. For instance, Chrome DevTools includes a responsive design testing tool called Device Mode that helps you verify how well your site adapts between desktop and mobile modes by simulating mobile viewports and navigating as well as emulating mobile CPU and network performance. These features help you get an early idea of not only how your site would appear on different screens, but also how well it would perform on resource-limited platforms such as mobile devices. While browser tools are very beneficial during development, testing your website on a range of real devices and browsers can help you identify and address more specific issues. BrowserStack is a great option for this kind of testing. It's a cloud-based platform that helps developers test websites and mobile apps across different devices and browsers without the need for physical hardware. Its emulation features allow you to switch between iPhone and Android experiences to discover how your site performs on each. This enables you to help ensure you're offering an optimal experience to a broader range of your users. If you need a quick, no-nonsense comparison of how your site displays across multiple screens, you might consider using Responsinator. Responsinator is a simple web-based tool that helps you test how a website appears on different devices and screen sizes. You can choose from a list of devices, including common iPhones, Android Nexus devices, and iPads. By simply entering your URL, you can preview how your site will appear on different user devices. Finally, while tools are helpful, testing on real devices is sometimes crucial. Sometimes a button that works fine on a simulated mobile device screen might be hard to tap on a real phone, or an image might not load slowly on an older device. Additionally, mobile devices include sensors like GPS, accelerometers, and cameras. Interactions or dependencies on these sensors are best tested on real devices in order to ensure that features that rely on them work as expected. Just as importantly, some apps or features may consume more battery power on a user device than expected, which can only be tested on physical devices. Now that we've considered the tools available for testing, let's consider an example of how you'd apply some practical methods to ensure your design works well on all devices. Let's imagine that you are working on an interactive product that catalogs and showcases a wide range of sustainable living products. The goal is to provide a seamless shopping experience across all devices for eco-conscious consumers. As part of the development team, you need to ensure that the site functions well on different screen sizes and across various browsers. A good starting point might be testing for breakpoints. This means checking key screen sizes like mobile, tablet, and desktop to determine how the layout adjusts. As you resize the browser window, you're watching to make sure the product images shift from a grid layout on a desktop to a single column on mobile, making all the details visible without overwhelming the user. Next, you're focusing on touch and click interactions. This involves ensuring that interactive elements like the Add to Cart button are optimized for both touchscreens and mouse interactions. It's important to ensure that your users will be able to interact with your site effortlessly, whether they're on a mobile device or a PC. One very important aspect you need to check for is usability and accessibility. For instance, in addition to ensuring that you're employing a user-centric design that's easy to use and efficient, you need to verify that your site meets established standards for accessibility and is compatible with assistive tech for users with physical needs. Think about the basic experience of filling out a form to subscribe to Groove Eco's newsletter. Not only should the form fields be clearly visible and the submit button easy to use on any device, but the color palette should be friendly to users with color vision deficiencies. And the content should be compatible with screen readers and similar assistive technologies. Testing like this helps keep the interface accessible and user-friendly to the widest possible range of your potential users. Finally, you need to conduct cross-browser testing to ensure that Groove Eco's site behaves consistently across different browsers, such as Chrome, Firefox, and Safari. It's important to verify that the site functions as intended, whether someone is using Safari on a Mac or Chrome on a Windows PC. This critical step helps you identify and address any browser-specific issues that might degrade the user experience. In this video, you learn about the tools and methods you can use for testing responsive designs to help you ensure that your site meets the needs of all your users, regardless of what device they're using. A great user experience means your design works smoothly across all devices. By using the right tools and methods, you can make sure every visitor has a seamless experience, whether they're on a desktop, tablet, or smartphone.
The best websites just work no matter where you access them. This seamless user experience doesn't happen by accident. It's the result of testing and validating responsive designs to make sure every user gets the same high-quality experience, whether they're on a desktop, tablet, or phone. In this video, we'll describe best practices for testing and validating responsive designs to ensure a consistent and accessible experience for all users. Testing and validating responsive designs is all about ensuring that your site functions correctly and consistently across a variety of device types, screen sizes, and user scenarios. Did you know that you can start testing your site on various devices even while it's still under development? Built-in browser features like Chrome DevTools and web-based platforms like BrowserStack and Responsinator help you verify how well your design adapts between desktop and mobile, giving you an early idea of how users on different devices would interact with your site. These tools help you verify functionality across a range of devices, smartphones, tablets, and desktops, to ensure that your site appears and functions as expected. In addition to verifying cross-device functionality, you need to ensure that users don't have an inconsistent or confusing user experience when accessing your site on different devices. Common user interactions like navigation, search, and calls to action need to be consistently represented on desktop and mobile views so users don't have to search for content or features in different places when they switch devices. For instance, a customer on an e-commerce site should be easily able to use their desktop device to browse and add some items to their cart, then use their smartphone later in the day to add more items before finally making their purchase. In addition to ensuring a consistent experience across devices, you need to ensure that all interactive elements such as buttons, text fields, and navigational components are easy to use for the variety of individuals who will be accessing your site. They need to be usable for those navigating your site with a keyboard and mouse, and optimized for touch and tap control on mobile devices. It's also critical to verify that your site meets established standards for accessibility, such as the Web Content Accessibility Guidelines, or WCAG, and Americans with Disabilities Act, ADA, standards, and is fully compatible with assistive tech for users with physical needs, such as those who rely on screen readers or keyboard-only navigation. Once you confirm that your site is functional, usable, and accessible for everyone, you need to verify that it performs well. Performance is a particularly important consideration for mobile scenarios since mobile devices tend to be the most resource constrained. Slow load times can discourage users from staying on your site, so ensure that your site is optimized for mobile scenarios by prioritizing the loading of the most essential elements, like text and key images. By stripping away unnecessary content and features, the site becomes lighter, more performant, and quicker to load. Consider the example of a photo gallery. It might load quickly on a PC, but take much longer time over a mobile network. You can improve this by compressing images and using lazy loading, which means only loading images when they're about to appear on the screen. Finally, while tools are helpful, testing on physical devices is always crucial. Sometimes a button that works fine on a simulated mobile screen might be hard to tap on a real phone, or an image might load slowly on an older device. Additionally, mobile devices include sensors like GPS, accelerometers, and cameras. Interactions or dependencies on these sensors are best tested out on real devices in order to ensure that the features rely on them work as expected. Just as importantly, some apps or features may consume more battery power on a user's device than expected, which can only be tested on physical devices. By following these steps, you can help ensure that your design provides a usable, accessible, and performant experience for all users. Testing and validating responsive designs helps ensure a consistent and accessible experience for all users. By applying these best practices, you can ensure that every user has a smooth, accessible, and performant experience, no matter what device they use to access your site. Users have a variety of device options for accessing mobile content. If your design doesn't adapt perfectly across all of them, it can result in a frustrating or even broken user experience. Properly documenting and addressing responsive issues can make the difference between a user-friendly site and one that turns visitors away. In this video, we'll explain how to document and address issues found during responsive testing so you can ensure that your design works smoothly across all devices. Documenting and addressing issues means recording any problems that appear during testing and taking steps to fix them. This involves integrating feedback, tracking changes, and updating the design to enhance functionality and usability. When testing your responsive design, you need to document issues as early as possible to allow the necessary time to deal with them properly. Several best practices exist for recording design issues in a way that sets you up for effective troubleshooting. As you progressively test your design, be sure to capture every issue you encounter. Document key details such as the page URL, device type, screen size, the browser being used, and a short description of the issue and its impact on users. Including screenshots helps to clarify the problem for anyone reviewing the issue later. Thoroughly documenting these key details ensures that problems can be efficiently reviewed and addressed. Once you've documented an issue along with its key details, you continue to track its progress until it's resolved. A simple spreadsheet works well for small projects, allowing you to log and keep track of the issue, its priority, status, owners, and other important information. As your project becomes more complex, consider project management tools like Jira, Trello, or Asana, which allow you to organize tasks and assign issues to team members. Logging and tracking every issue through to resolution ensures you address each problem thoroughly. How you manage your code has a direct impact on the way that you track changes. This is where version control tools come into play. Version control tools like Git help you manage your code efficiently by enabling you to create a code branch, which is essentially a version or copy of your code that you can freely modify without affecting the main version. You can then work on the version of code within this branch to fix any issue you've chosen to address. Once all code changes are complete, you can merge the branch back into the main project. This process is known as version control and enables you to work on code fixes and updates without interrupting other ongoing work. Version control also lets you revert to earlier versions of the code if something goes wrong or changes don't work as expected. It is also important to communicate and collaborate with your team when working through design issues. Collaboration tools like Figma or Miro help teams streamline joint efforts by enabling teams to collect and share feedback and updates while iterating through joint projects. This centralized approach makes it easier to share suggestions, track design adjustments, and ensure that all team members are up to date and aligned. Finally, you need to iterate on the design based on the feedback and issues you've collected and tracked. Iteration is all about making step-by-step improvements and then verifying them in successive versions of the design. After fixing an issue, thoroughly retest the site on a range of devices to confirm that it's resolved. Then, continue the cycle. Document issues, make changes, test fixes, and gather feedback until you and your team are comfortable with the quality and functionality of your site. This continuous loop ensures that you're progressively enhancing your design and should be followed each time you detect an issue or introduce an update or change. Ensuring a website works seamlessly on any device requires careful documentation and attention to detail. By mastering the process of recording, tracking, and fixing issues, you're not just improving a design, you're creating an inclusive and accessible experience for every user. Building responsive design skills is key to creating polished, adaptable websites. By mastering these principles, you're prepared to design user-friendly sites that deliver a consistent experience on any device. We began by exploring the fundamentals of responsive design, focusing on key concepts to make web content look polished and functional on any device. Then, we examined media queries, where you learned how to adapt layouts and elements for various screen sizes to achieve fully responsive designs. Next, we discovered the techniques for creative flexible layouts using practical methods to ensure content flows smoothly across different devices. Then, we explored approaches that optimize for mobile use first and expand easily to suit larger screens. Lastly, we examined testing and validating responsive designs, applying techniques to ensure smooth functionality across various devices for an optimal user experience. Mastering responsive design principles is essential to creating adaptable, polished web content that performs seamlessly across all devices. From understanding flexible layouts to optimizing for mobile first and validating designs, each step empowers you to build user-friendly, modern websites. Welcome to using Microsoft Copilot for generating CSS and design suggestions. Here, you'll learn to harness Microsoft Copilot's capabilities to streamline CSS development, create responsive designs, and elevate UI/UX quality. By integrating Copilot into your design workflow, you'll be ready to build modern, adaptive websites efficiently and creatively. We will begin by discovering how to enhance CSS with Microsoft Copilot, using its features to write and improve CSS code quickly and efficiently. Next, we will examine generating responsive design with Microsoft Copilot, learning how to leverage its suggestions to create layouts that adapt beautifully across all devices. Then, we will explore optimizing UI/UX design with Microsoft Copilot, applying its insights to elevate design quality and user experience. After that, we'll integrate Microsoft Copilot into the design workflow, practicing seamlessly incorporating its tools and recommendations into real-world projects. Finally, you will submit your project showcasing how you've applied Microsoft Copilot to enhance CSS, responsive design, and overall UI/UX. By the end, you'll have completed a project that showcases your skills in applying Copilot suggestions to real-world design challenges. Imagine having a helpful companion that makes coding easier by offering CSS suggestions. That's what Microsoft Copilot does, helping you focus on design while it takes care of repetitive tasks. With the free version, you can access this assistant right from your browser. In this video, we'll explain how to use Microsoft Copilot in the browser to assist in writing CSS code. First, let's go over what Microsoft Copilot is and how it works through a browser interface. Microsoft Copilot is an AI tool designed to assist with tasks like coding. You can access it directly in your browser. This version supports writing CSS by providing suggestions and code snippets, helping you avoid repetitive work. It's easy to use. Start typing your questions or CSS tasks. Now that we know what Copilot is, let's explore how it can help with common CSS tasks through the browser. Simply open the Copilot interface and type what you need, such as suggest CSS for a button. Copilot will provide relevant code suggestions you can copy and paste into your project. Let's discover specific ways it can assist with styling. We'll begin with the basics, styling individual elements like text, buttons, and borders. Copilot simplifies CSS tasks by offering suggestions right as you type. When working with text like headings or paragraphs, you can ask Copilot to suggest font sizes, colors, or alignment. For example, you might ask, how do I center a heading? Copilot will suggest CSS code to get the job done quickly. Copilot can also help you style buttons. For example, you might ask it to suggest padding and colors for a call to action button. It will return useful CSS you can apply directly. Need a border for a card or image? Type your question into the browser-based Copilot and it will suggest options like dashed or solid borders in various colors. Now that we've covered basic styling, let's explore how Copilot can help organize your page layout. Layout involves positioning elements neatly on the page. You can ask Copilot how to center content or space elements evenly. To do this, you can ask Copilot, how do I center a div horizontally? It will return CSS code with options such as using Flexbox or margins, which you can apply right away. Let's explore how Copilot can assist with real-world tasks. Imagine designing a landing page with a header, some text, and a button. Ask Copilot for suggestions as you style each element, whether it's font size for the header or padding for the button. It ensures your design appears polished and saves time by offering ready-to-use code. For example, you might type, suggest CSS for a header to make it stand out. I want it centered, bold, and around 36 pixels in font size. Copilot can also help with responsive design. You can use media queries suggesting CSS to adjust layouts for smaller screens. For example, you can ask, what media query do I use for mobile devices? It will provide code that ensures your page works well on phones and tablets. Finally, Copilot can provide snippets, small pieces of code for common tasks like hover effects. Simply ask for them and paste them into your project to save time. You might say something like, provide a CSS snippet to add a smooth color transition on hover for a button. Using Microsoft Copilot in the browser to assist in writing CSS code can help with styling, layout, and responsive design, making your workflow smoother and more efficient. You can quickly generate CSS code, saving time and focusing on what matters, building great designs.
CSS is one of the most important parts of web development because it's what your users interact with. It's what makes things appear pleasant and understandable, but it's also one of the hardest pieces of good UI to get right. CSS is a big language, and if you're not working with it really regularly, there are all these different styles and selectors that can interplay. So I rely heavily on Copilot when generating my initial stylings because it's not something I use very often. I'm often working with sort of code logic and not with CSS. So I don't need to remember every little selector that you can possibly use in every little stylistic rule. So in this video, we'll demonstrate how to use Copilot to generate advanced CSS techniques. So I've put together a simple sales page for a sock company. I have the project open here in Visual Studio. We've got an index.html file and styles.css. I am going to use this handy live preview extension. I highly recommend this. If you haven't installed it, you can type live preview here in the search. It should come up like this. And then you can just click the install button here. Again, I already have this installed. So if we go back to our file explorer, I can open up this index file and now I can click this show preview button. And this will start up a little server that will serve my web application, in this case, just a simple website, and it will show it with all the styling. So I can come down here and say something like, why walk when you can? Maybe I want to say run. And now that has changed and I can see that change live. I could also change my styling. Let's say I want to come over here and I want to change this color to just something random. So now it's white. Go ahead and change that back. So that is what live preview does. Highly recommend this extension. You could also just open it up in a web browser if you want to, but you're not going to get that live reloading. And so you can see this page. This is a pretty aggressive looking sales page. Now, CSS isn't all just about making things super beautiful and artistic. CSS fundamentally is about making things look a way that makes them functional for what they're trying to do. In this case, it is very bluntly trying to sell someone a product. And now this might look a bit ridiculous, but I promise you, if you go to the website that is on just about any television commercial, it will have a website that looks a lot like this. And so the goal here is to make this really clickable. We're trying to make someone order so they can transform their feed. So we want them to click this call to action. But the problem is right now, it doesn't really look like a button. It's not really obvious that we want them to click it. And so we're going to use Copilot to help us fix that. So I'm going to go ahead and open up Copilot. And you can do this in a few different ways. So one is to open up Copilot here on Windows. You can find it right there. If you don't have it pinned down here, you can also just search here in the search bar. The other way you can access Copilot is to come over to an Edge browser and go to copilot.microsoft.com. And that will bring up this Copilot interface. Additionally, if you are in Edge and not using a different browser, you can pull up Copilot right there. I'm just going to go ahead and use this because it is already up. Now, there's a couple different things you can do here. One, you can click here and get a history of all of your different conversations. Another thing you can do here is you can start a new chat or upload an image. Now, I always recommend anytime you're starting a new project when working with Copilot, start a new chat. It will often try to start you with a previous conversation. And the problem is Copilot will be a little bit confused why you're talking about something different than you just were. It'll be like, we were just talking about burritos, and now you're trying to talk about a sock website. And all of a sudden, it's going to try to put burrito information in my sock website. And that just confuses everybody. So always give it a fresh conversation. This is what is known as the context that Copilot has. So it's sort of the information is being fed. And you don't want it to have a bunch of context that's not related to what you're currently working on. Context is really important because you can think about working with a tool like Copilot like working with another person. We're going to have Copilot help us fix this website. And what would another person need to help us fix our website? I can't just tell them, hey, fix my website. They'd say, what website are you even talking about? And so you need to feed them information like that. You need to give them the information like the HTML and the CSS that makes up the website. And so we are going to go back to our code editor, and I'm going to grab the HTML and put it in there. And then I am going to come down and grab the CSS and put that down there too. And so now this is the context that I need for it to help me make my request. And what is that request? I'm going to say something along the lines of, I need to improve my call to action button on this website. It currently doesn't appear to be very clickable or enticing. How can I improve the style and add an animation that makes it more enticing? And so now it has our request, and it also has the context for what we are trying to do. So here it says we will style the call to action button and add an animation. So it's going to feed us back some CSS. Said it added a box shadow, some transitions, keyframes, and a move button. So I always recommend checking any code that Copilot gives you. It will not be perfect. It is not guaranteed to maintain what you gave it. It will sometimes subtly change things that you did not intend to change. So sometimes I will just grab the exact styles that I need, which in this case, it looks like it gave us. It just gave us some new CSS that we can add rather than the entire CSS file. So I'm going to grab those, paste that in. So now we can see it is laid out pretty well, and I can see all my code, but this is a little bit aggressive. So I want to make a few changes here. Now, the thing I really like about working with Copilot is it gave me sort of the scaffolding of what I'm looking for. This is pretty close to what I wanted, but it's a bit aggressive on that animation. So let's tone that down a little bit, and let's maybe bump that up a smidge. And now I want it to sort of stay at rest and then pop every now and then. So let's tweak these animation keyframes so it will only be just a short bump. It's much more noticeable. Awesome. And now I want to make that just take a bit longer. So let's go find that animation. This is the move button animation. If I search for move button, it's probably right in front of my face. There it is. And let's make that 3 seconds instead. And let me bump this down just a smidge because I want to make that still poppy. Awesome. I think that looks much more clickable now. It comes up when we hover over it, and it gives it that little animation to try to get people to click that. Excellent. So this shows a really good example of how Copilot can be used to produce code for us. We gave it existing code, we had it make some changes, and then we sort of tweaked those to meet our own needs. Now, we could absolutely have gone right back to Copilot, said, hey, can you change that to not animate quite so long, to just pop up really quickly and then have a longer animation? Absolutely would have worked. But I find that often, if you know what you want to do, you can just make a tweak really fast rather than going right back to Copilot. Another option is to use the Copilot editor tool, which is another great option. They just recently made that free to all users. So if you don't want to use the chat interface, you can also use the Visual Studio Code editor version of Copilot. And that would allow you to inline here, ask Copilot to say, hey, change this in a particular way rather than having to copy it back. So hopefully this sort of opens your mind to some of the possibilities of the types of things you can have Copilot do for you. You can have it write code for you. You can have it modify your code. You can have it just help you sort of be a thought partner and help you think through different problems. It's a really, really useful tool. As you can see here, our page is now much more enticing, and we didn't have to write much code at all. I just made a couple of changes to a few numbers in there, and now it's doing exactly what I wanted it to do. Making your user interfaces and user experiences functional and attractive is why you write CSS. But often you need to optimize your code to make your website more performant and easier to maintain. And this is one of the most tedious parts of writing CSS, and it's something that Copilot really excels at. So in this video, I'm going to explain how to use Copilot to optimize and refactor CSS code. So let's start by exploring the website we are going to be working on. Welcome to Bubble Bliss Aquatics, this neat little site that sells aquarium pumps, I guess. And it has some issues with the CSS that we are going to try to fix. I'm going to click up here in the top right and open this in a browser to really showcase what is going on here. So the first thing I notice when I open this site is I am having some stuttering in this background. This should be a perfectly smooth animation. This is what is known as jank. This happens when our computer is struggling to animate something fast enough. It becomes much more apparent if I start to scroll. You can really see it start to bog down. That is that jank happening. And it just doesn't look great. And this is running on a relatively powerful laptop. If you pull this up on your phone, it would really, really struggle. This just isn't good code to have here. And now we could absolutely change the design. We could rewrite it in JavaScript. We could do all kinds of things. But we can just make a few tweaks to our CSS potentially and actually make this work, which is often just get it to work. You don't need to do it perfect. It just needs to be good enough. And so that is where a tool like Copilot can come in really, really handy. So let's go ahead and grab a copy of our CSS. I am going to go ahead and open up Copilot. And I will say this CSS seems to be causing jank in my application. How can I improve the code? Then I will copy that in. And again, I did the whole thing. And if you're wondering how to get that line in there, you can hit Shift Enter and add in lines without having to hit Enter. It will let you add in things below like this really cleanly. So it says, consider these CSS improvements. We could do some will change. Probably not going to be a problem here. Modern browsers tend to not really need to worry much about that. Optimize certain properties before they're changed. And use transform for animations. Now this is the one I was hoping it would pick up on. So you can see over here, I am changing the top width and height of these bubbles to change their position, which causes performance problems because it causes the entire web page to sort of recalculate where everything goes on the page. And because there's, I think, 2,000 of these bubbles, it's doing tons and tons of calculations. If I use translation, it will say, hey, you would normally go here, but move sort of slightly out of position, and it actually won't change the layout of everything else. It's a really common optimization for working with animations like this. And that is absolutely what I should be doing here. I bet you this will fix our problem. So I am going to take this float animation, and I will pop that in there. And let's go ahead and save this and go back and check that in the browser. And I only want one copy open. I'm going to close this. And so now we should see none of that stuttering. It's just running this nice, smooth animation now. We can sort of scroll up, scroll down, and it just continues to look smooth, which is totally what we were looking for. And again, you could take this further than this. Maybe you want to look at the JavaScript and do your animation with JavaScript instead of CSS, or do this some other way, a particle system, draw it onto a canvas rather than using individual HTML elements, which isn't terribly performant, but absolutely is something you can do if it's the tool you know and the tool you have in front of you. The next thing I want to work on here is our styles.css file. So if we come over here to styles.css, I have a bunch of code in here. I've been working on this file for a long time, and you can see that like I have kind of this gray, and there's another gray down here. I'm just kind of making up grays, and none of them are quite the same. It would be really nice to like have those standardized. There's a bunch of selectors in here that I probably don't need. There's a lot of these are like hyper specific selectors, which tend to be really hard to debug and diagnose. So there's just kind of messy CSS here. So I am going to go ahead and copy that, and I will come back here, and I'm going to go ahead and start a new conversation here because I'm talking about something different with Copilot, and I will say, how can I improve this CSS to be easier to understand and maintain? I think I have unnecessary styles and uncoordinated colors. And then I'm going to hand it my CSS. Now you might just think I'm going to give it my CSS. But for finding things like unused styles, it actually needs to look in your HTML and see what kind of selectors you have there. And so I'm going to give it my HTML as well. And it may not pick up everything. This is a lot for it to look at, but hopefully it'll give us some direction here. So it says you can remove unnecessary styles, group related styles. I like that. Right now they're really out of order. And then simplify the color scheme and actually use some variables here, which I think sounds great. Excellent. So let's check this as finished. Awesome. So I'm going to grab this. I'm going to pull up our live preview. And then I am going to pull this over a little bit so we have some more space there. I'm going to go to my styles, and I'm going to replace those, and let's see how we look. And that looks very, very similar. I'm happy with sort of all the color schemes that it kept there. But now this code, you got the footer, you got footer.social links. I mean, look how small all these selectors are. You don't have all those huge selectors anymore. Looks much, much better. And maybe it missed something. You'd want to go through a little bit more thoroughly and check this. But that definitely gave us a big jump towards having much, much cleaner CSS. And so you can see here, we have some issues, like it doesn't look like there's quite enough space in these elements, and that might be something else we might want to have Copilot help us tackle. We haven't implemented our icons yet, so we could have it help us figure out how to do an SVG for those. I don't recommend having it try to write you an SVG. It will make complete gobbledygook often that won't look like anything useful. And then maybe like this padding here, clearly this website looks much better and is more optimized on desktop. And so we have now successfully used Copilot to improve and optimize our CSS. We have some ideas of where to go next. And this task that rewriting the CSS could have taken us hours, and we did it in a couple of minutes thanks to Copilot.
Think about how often you switch between devices, like scrolling through a website on your phone and continuing on your laptop. You expect the website to adjust seamlessly, but making that happen takes time and skill. Microsoft Copilot is here to assist, helping you create layouts that automatically respond to any screen size. In this video, we'll describe how Microsoft Copilot can assist in creating responsive designs. One essential part of responsive design is media queries, which allow you to change how a web page functions based on the size of the screen. For example, a 2-column layout on a desktop can shift to a single column on a phone. Copilot helps by suggesting when to use media queries so you don't have to figure it out on your own. Imagine you're building a photo gallery. Copilot suggests switching the layout from 2 columns on wide screens like a desktop to a single column on narrow screens like a phone, keeping the design easy to use. Another way to ensure consistency across devices is to use design patterns. A design pattern is like a reusable solution or template that helps you create layouts more efficiently. Let's find out how Copilot assists with design patterns. Design patterns are reusable solutions like grids or navigation structures that save time and help ensure your web page adjusts smoothly across different devices. Copilot recommends patterns to ensure your layouts are flexible. For instance, if you're creating a blog, Copilot might suggest a grid layout that displays 3 posts per row on a desktop and shifts to 1 post per row on smaller screens to keep everything easy to read. While design patterns provide structure, code snippets make it faster to put those layouts into place. Let's explore how Copilot offers snippets to save you time. Code snippets are small pieces of code that can be reused to solve specific tasks, like adjusting fonts or layouts for different devices. Copilot provides these snippets to help speed up development. For instance, if your site has a sidebar, Copilot can offer a snippet that hides the sidebar on smaller screens, switching to a simpler one-column layout. Once your layout is ready, small problems can appear like buttons that aren't aligned properly on certain screens. Copilot helps catch these issues early so you can avoid spending too much time fixing them later. For instance, if a button is off-center on tablets, Copilot might suggest adding a media query to align it correctly so it stays consistent across all screens. By offering suggestions and solutions along the way, Copilot helps ensure your project stays organized and efficient. Let's find out how this improves your workflow. Copilot keeps your project on track by suggesting improvements along the way. This saves time and lets you focus more on the creative aspects of your design instead of troubleshooting. Microsoft Copilot can help you create responsive designs by assisting with layout patterns and troubleshooting issues, as well as providing snippets of code to enhance your design. Together, you can confidently build sites that respond to any screen size and deliver a seamless user experience.
Responsive design is a hallmark of modern web, and it often relies on CSS, like grid layouts and media queries that can be incredibly tedious to produce by hand, which is a big part of the reason that people have made all these different front-end frameworks. But you actually often don't need a front-end framework or a styling framework to make a lot of websites. You can just write the code yourself, especially if you have a tool like Copilot to help you do a lot of that heavy lifting when creating the responsive CSS. So in this video, we will demonstrate how to implement responsive design suggestions using Copilot. Once again, we will start with a website. This time we have this sort of gallery site that shows the different courses about programming that we might offer. Right now, it's pretty good layout. The colors are okay, but we haven't designed the code to be responsive. We can already tell that, like, you see things kind of falling off the edge over here. This top nav looks terrible. There's just so much going on there. You really can't make sense of what links are what, and they'd be very hard to click, especially if you're on a touch screen. So let's go ahead and open Copilot, and I will grab a copy of our HTML, and I will grab a copy of our CSS. Again, Copilot can't really do a good job if it has CSS without HTML typically, unless it's a very specific topic that has nothing to do with the selectors or the structure of your HTML. So I will hand both of those, and I will say I want to improve the layout of this page to be more responsive. What design considerations should I be thinking about? Okay, to make our page more responsive, following design principles. The viewport meta tag, flexible grid layout, yes. Responsive images, also useful. When I go to actually put my images in here, responsive images would probably be very useful. Media queries, to adjust the layout and styling based on the device's screen, and the navigation menu. Cool. So I think it's given us a few good options here of how we might improve the responsiveness of this web page. I want to go ahead and dive in. Let's start with the navigation menu, because that's the part that probably bothers me the most. So I will say, please modify the HTML and CSS to make the top navigation responsive. And now I'm not going into great detail here saying I want it to do this when it's on a small viewport and this when it's on a large viewport, and this is how I want you to handle a menu on mobile. I'm sort of letting it take the wheels here. You could be more specific if you want to, but I often find I will try the simplest thing that might work and then make it more complicated as necessary, get more specific as necessary. So there's our HTML. I'm going to paste that in, and it currently does not look good at all, and I'm guessing that's because we don't have the correct styling. So let's grab our styles and put those in, and now we are looking quite a bit better. It tried to do a little menu button over here, and that doesn't look quite right. But it also touched up our gallery here, which is actually what we're going to handle next. So it has actually done a couple of things here to make it more responsive all at once. So let's go ahead and save these, and let's see if we can have it help us do some other improvements here. It clearly has made our grid more responsive. Let's go ahead and open this in the browser where we can see a little bit better if we try some different view widths, how this looks, and those look okay. And this is a great time to bring up. So this is a perfect example of when we asked Copilot to do a very specific thing for us, and it actually did something else. So it did what we wanted, but also added this additional styling. In this case, it's something we wanted, but it's something you really want to watch out for when you are working with these AI tools. And now one potential way to get around that would have been to have opened up a new Copilot conversation, because previous in its context, it had recommended that we made these 5 changes. It probably made all 5 of those changes, to be honest with you, if we went and looked back at the code it generated. So let's go ahead and get it to fix one more thing here. This menu does not look great on mobile or on these narrow views. So let's pop back to Copilot and see if it can help us with that. The menu drop down button on narrow views looks a bit awkward. It sits above the blue background of the next element. See if that gives it enough context to fix that issue. So you can see here, it updated our HTML and it updated the CSS once again. So let's copy in that CSS. And let's see if it's finished with the HTML, and it has. So let's copy that HTML, paste that in. It's on the correct side now, and it still has not fixed it. So let's go ahead and look at what our elements look like. Pull up our website here. We should be able to, let's pull up the browser tools, more tools, and we want the developer tools. And we can check our elements, and we can view this as mobile. And now we can see what's sort of going on here. So it looks like our menu button toggle is sort of hanging down there. So I don't love this header. So what seems to be going on here is the menu is actually a bit bigger than our nav bar. So yeah, the button there in the nav is extending out of it. So now we know what's going on, and we can tell Copilot what we see. Button is taller than bar. It hangs out the bottom. That is why it looks off. You can see here what it comes up with. Let's make CSS to ensure the button aligns well with the nav bar height. Perfect. That should hopefully be what we want. So let's grab this code, pop over to our editor, paste that CSS in, and it's closer, but it didn't quite get it. And so once again, let's go back to our browser and check to see what's going on here. So we have this with a height of 40 and that with a height of 32. And so I am going to come over and I'm going to manually see if I can find that nav bar. There's the nav A. And let's try giving it a min height. And we will say this is 40 pixels. It's a bit bigger than I want. 30 pixels, 20 pixels, 15. I'm pretty happy with that. Let's go back and check our browser to see how that looks. That looks pretty good. Open up those developer tools again. We can see this on mobile view, and there we have our menu. And so now we have this, we can open it, we can close it. I don't love that it just says menu, and this would be a really good chance to come in and say maybe put a little vent or a hamburger, the 3 horizontal lines here is an SVG, and then maybe have an X here to close it to make it really obvious where our elements are and what they are doing. Or maybe make this say close and open. We have some different options there. And now, as mentioned in a previous video, Copilot really can't be trusted to generate SVGs most of the time. So I do recommend, if you want to do that, go grab an SVG somewhere for your graphic for a little X or event menu. Go ahead and hand that to Copilot and ask it to give you the code to implement that to make it work how you want to. But with that, our website is now looking much, much more responsive. We have this nice layout here. You can see it flexes at different sizes. Our menu is appropriately sized. I would probably change this breakpoint just a smidge, because it's clearly wrapping there because I have a big long menu, or maybe I'd get rid of a couple of these menu items. We have some different options, maybe move them down to the footer. And with that, we have had Copilot help us make a much, much more responsive website. Responsive design ensures that websites look great and function seamlessly on any device. From widescreen desktops to smartphones, creating responsive layouts is one thing, but testing them thoroughly is a whole other ballgame. So in this video, we'll explain how to evaluate and test responsive design enhancements made with Copilot. Now, this is an area where Copilot isn't going to be great at, say, testing your design for you. It doesn't really thoroughly understand the visuals of your website like you do. So anytime you have Copilot make you code that is going to change the visuals, you definitely want to check that output. So imagine that on our development machine, everything looks great, but maybe a user views it on their phone, all of a sudden the layout breaks and things look weird and they can't find the elements they're looking for. And that's a really terrible user experience. And this is why testing responsive design matters. It helps us catch issues that aren't obvious in a static or single device view. So let's dive into some tools that can help us test and refine our design. Now, the first one I always reach for, up whatever I'm making in a browser. And I can go ahead and resize this manually. So you can see here, I have my full desktop view, and then I can get smaller, 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 see how it resizes, and you can see there's a break there. It's actually breaking later than it should. This menu is too wide. So I would want to think about maybe taking out some of these elements, making the text smaller, or somehow making all these fit better, because you probably don't want to have 2 rows on your menu on this sort of medium-sized view here. And you can see that it breaks there. So somewhere between here and way out this wide, it doesn't look great. Now, if we open up the developer tools, we can see that desktop view. Now, a handy thing you might have noticed there, if you look in the top right corner of my browser window, you can see it's telling me the pixel width. So we can see exactly where we start to have problems. So it's somewhere around 900 pixels and then goes all the way to like 700 pixels or something around there. Looks like that break is maybe 780, probably somewhere around there. 770. So it looks like our break where we don't have something we like is between 770 and 900. So those are really handy tools for evaluating where your breaks look funny. The rest of it looks okay. And so in case you missed this, these are the developer tools. So you open these using Control-Shift-I, and as soon as you have them open, you will see that number up in the top right. You can also get your developer tools open by coming up to the menu, going more tools, and then developer tools. And again, you see that hotkey right here. And so the developer tools have a bunch of handy things in them. You'll see the sort of welcome here that'll give you some information. And so we have the elements here. This will show us our entire document object model. We can click this button here on the inspector and click on any element, and that will give us information about it. You can see here, these are all the different CSS rules that are being applied to this element. And over here, we have this handy computed. So this tells us what the width and height of this element are, if there's padding, if there's borders, and we can see here that there's a 16 margin on the left and right. It's a really useful tool. We can click another element, say maybe this one. And you can see there we've got 32 padding on the top, 16 on the side, no margins. So it's really nice for seeing why your layout looks kind of weird. really killer evaluation tool are these dev tools. So I can come in here and I can take my dock and I can move my dock from the bottom to the right, and that'll work a little better for this mobile view. And so this is actually emulating a 370 by 686 pixel device. And I can take this and I can tweak it to make it wider. But where this is really useful is I can say, I want to show this on an iPhone SE. And these are now the dimensions of an iPhone SE or an iPad mini or a Surface Pro 7. So I can check these different devices to see what my application will look like on each of those at their exact dimensions. Now, this is really handy if you are, say, building an application that's only going to be used on a Microsoft Surface Pro, and it's going to be like a checkout app at one particular store. So you know it's always going to be used on this one device. You can design for just that device. So you really want to make sure it looks good on just that one. What gets harder is when you're using lots and lots of different devices. So this emulator is a really great tool to come in and start checking what it might look like on different size displays. Another really useful thing to check is CSS works differently in different browsers. So I'm using Edge here. You could be using Chrome or Safari or Brave or any of these different browsers. They implement CSS, sometimes meeting an exact standard, but not always. So if you tend to use some of the more standard CSS APIs, they tend to work really well. Like Flexbox and Grid are pretty well defined at this point. But a few years ago, they weren't. And so you'd go to different browsers and they'd be actually implemented slightly differently, and some things would or wouldn't work. So a really good tool there is caniuse.com. And Can I Use allows you to look for different things. So like look for Flexbox, and we can see here all the different browsers that support Flexbox. Green means they're good, yellow means they're partially supported, and red means it's not going to work. So if you need to use, say, an old version of Opera and you're trying to use Flexbox, it's not going to work. If you want Safari on iOS, an old one, it's not going to work. Any of these 18.3, 18.2, these versions will all be just fine. If you want to support Internet Explorer, you might have some trouble. Luckily, Internet Explorer largely isn't a requirement of most apps these days, but this is a really handy tool if you're trying to see where you might have trouble with a particular browser. And speaking of websites, another really handy tool for testing your applications. So we showed before that you have an emulator here. Now imagine you want to test this on dozens of devices, dozens of browsers, all over the world using different scenarios. It's really not practical that every time I make a change, I'm going to come in here and check this device. I'm going to check this device, and I'm going to check this device. It just gets really tedious. So there's tools like Browser Stack that can actually set up entire suites of testing. And so these will actually allow you to set up and simulate large numbers of different development environments so that you can actually sort of in a big suite of tests, make sure your design looks good rather than doing it one device at a time. Now, this is the type of tool I wouldn't recommend using unless you have a really strong need to. It's kind of a big beast of a piece of software. There's a lot here. There's a lot to set up. There's a lot to get going, and there's a price associated with it. So only reach for a tool like this if you really, really, really need it. Typically, you can make a design that will just sort of look good at all different sizes. You have some broad generalities, but if you do have a need to test on very specific devices, tools like this can be really, really powerful. So hopefully that gave you some ideas about how you can test your responsive designs that you've made with Copilot. Again, I always recommend checking to make sure that your designs look good at all these different viewports, especially if you're taking a big chunk of code from Copilot. It is very common for it to add in some subtle changes that might make things look weird that you weren't intending it to make. So go out, make some fun responsive designs, and I hope that someday I'm browsing the web and get to see something you made.
From form submissions to dynamic tooltips, effective user interactions require attention to detail and code consistency. Copilot helps you implement these interactions with less manual coding, generating clean, reusable snippets that improve both the efficiency and quality of your UI elements. In this video, we will describe how Copilot can suggest enhancements to user interactions. Let's familiarize ourselves with the interactive elements that make Copilot easy to use. Once we understand these tools, it'll be easier to understand how Copilot elevates the experience. Buttons trigger actions, and Copilot ensures the right buttons appear when needed by suggesting or generating the underlying code that makes them work seamlessly. For example, Copilot can generate a submit button tied to a JavaScript function, ensuring the action validates user input before submission. In a form, it might help generate multiple buttons like save and cancel, each linked to specific backend routes or modal triggers, ensuring smooth transitions between actions. Tooltips are small but powerful elements that offer instant help when users hover or focus on UI elements. Copilot can generate snippets for these tooltips, saving time and ensuring consistency in their placement and behavior. For example, Copilot can generate tooltips that appear when users hover over complex settings, explaining what each option does. Copilot might generate a tooltip that displays dynamic content, such as the current status of a process or system alerts based on API responses. Modals are critical for gathering input or alerting users about important information. Instead of building modals from scratch, Copilot can generate the necessary code, reducing friction in the development process. Copilot could generate a confirmed deletion modal with buttons linked to event listeners, ensuring actions are intentional and easy to reverse. It can generate a modal that appears when a user adds an item to their cart. The modal displays product details and checkout options, all coded with animations for smooth transitions. By generating the code for buttons, tooltips, and modals, Copilot helps teams focus more on the creative and strategic aspects of design. It removes repetitive coding tasks and ensures consistency across the interface, making collaboration between designers and developers smoother. With Copilot writing the core code, teams can iterate faster, stay aligned, and deliver higher quality products, turning smart ideas into working features in no time. With Copilot, you're not just working faster, you're working smarter with interactive elements that are generated, refined, and aligned perfectly to fit your workflow.
Poor visual aesthetics can ruin an otherwise perfectly good design. So in this video, we will explain how to use Copilot to enhance the visual design of a project. So I have some HTML open here for this website that I'm about to show you, and it looks absolutely terrible. It looks like something out of the early days of MySpace, when people were trying to design things with really no real sense of design aesthetic. The colors are bright and clashing, things are really busy, the layouts are just absolutely terrible. So there's a lot here that we can fix. But the key here, this is an otherwise perfectly good website. So let's go ahead and have Copilot help us improve the design of this page. So one of the first things I'm noticing here is that I scroll, I've got this banner that's very noticeable, but it sort of does this in a way that it's really hard to read. And then we have this pop up here that should probably be a modal. It doesn't look like there's any way to send that away. There's just really no sense of hierarchy. There's things going on all over the place. The first thing we should do is try to tackle this sort of hierarchy and layout of this page. So I am going to grab this code, and let's pop over to this new conversation, and I will paste that in, and I will also grab my styling. And let's go ahead and give it the request now that we've provided the context. So improve the layout of this website. I want everything to be appropriately sized and visible with reasonable margins and padding. Then looking here, so it says here's an improved layout of your website to enhance readability, usability, and overall aesthetic. Everything appropriately sized and reasonable. So there's our code, and see if there's any more notes here at the end. It's good. Awesome. So no notes at the bottom. So let's go ahead and grab this code and see if we have those improvements. And you can see now it already looks so much better. And so the next thing I want to do here is looking at these colors. They're a little bit clashy. The red and green feels a little Christmassy. Then we've got the yellow, and we've got these two yellows here. and this other red, they don't exactly look amazing to me. So let's see if we can get Copilot to produce some better colors for us. I want a color palette with pleasant, neutral tones for the text and background, a primary brand color, and a few accent colors. What are some potential color schemes that would look professional? We've got light gray with a charcoal gray, primary brand colors, a medium blue and a green, accent colors of yellow and red. Okay, then we have modern and sleek. We've got soft gray, dark gray, deep blue, emerald green, navy blue, and teal. I'm intrigued. So let's grab this code and say modify this CSS to use the colors from scheme 3. I'm also going to ask it to please abstract those colors out as variables. This will make it easier for me to tweak those colors. Excellent. All right, so let's grab this, paste that in, and that looks much better. I'm much happier with that. I do not love that orange bar though. So let's see if we can change that. Let's go ahead and reuse this color in accent 1, and we can always change this later, but for a quick fix, I think I'll be much happier with that. And then that means we want that text to be white down here. Let's find that other red text. And it looks like it is probably using our accent color there. So we got background, red, text, white. And this is probably our special feature down here. So let's make this. So now I'm pretty happy. The only spot that I don't love here is this contrast still isn't great with that text in the webinar section. And let's go back and check what our handles are for that. So we've got the promo section here. I don't love the contrast there, but it looks pretty good down here. So let's go ahead and change that color to white. All right, so now that is looking much, much tidier compared to what we previously had. If I undo a few times, we can see, I mean, just look how far that has come. Look how far we've come. All right, then the last thing we had here was there used to be what looked like it was supposed to be a modal. So let's see if we can't get that back. So let me look at this HTML, and I do see there's an audio in here. Definitely don't do that. So let's not autoplay audio. Let's get rid of that. And then let's come down here and check what we have going on. We had this alert. Don't want that either. Pop-up alerts. Going to be kind of terrible, but we do want this join our webinar to be a modal. So let's see if we can't have our Copilot help us do that. Please modify this code to make the join our webinar section a modal that appears after the user has been on the page for 30 seconds. So the idea here, the user's been around for a while, maybe they've read some of that copy, they're excited about what we have going on, and so then they might click that modal, they might be excited. There are debates about whether or not modals are anti-patterns in good design, but they do work in certain scenarios. So let's go ahead and pop that code in. And it seems to have moved the styles into the head of my page, which I will rip those out and put them in our own CSS sheet. All right, so let's go ahead and grab this to make sure it works first and foremost. And reset our page, and then make this much faster so we can test it. Then join our webinar, so we have this modal here. I like that. I can click outside of it. Let me refresh one more time to get that back. And I can close that, and it's also down here at the bottom. That's actually probably the right way to do it rather than remove it from here and put it up there. I'd been intending to remove it. Copilot for the win. Join our webinar. We'd eventually want to put a link here, but I actually think this looks pretty good for now. So I am going to go ahead and close that out, and I am going to turn this back to what it originally was, that 30 seconds. So if someone's here, they're reading, they're excited, they can see that. And I might actually bump that down to 20. Looking at the length of the copy on here, that's probably enough time for someone to get and see that. So there is our script. We could abstract that out at some point, but I'm going to go ahead and take these styles and move them back into our style sheet to keep everything cohesive. Save that and remove this style tag and reset one more time. Let's give one last pass, check to make sure nothing looks especially weird. I don't love that red there, but it'll work for now. Awesome. That looks like everything is where it should be. And there is our model. So here in a few quick minutes, we made our website much more visually appealing. It doesn't have those crazy neon colors and the terrible layout anymore. And Copilot did that all in a very short amount of time. So no matter how messed up your site styling is, Copilot can be incredibly useful to help you get it to a much better state. Copilot isn't just useful for initially creating code, but it's also really useful for maintaining it. Even really well-made code, eventually problems will arise. Maybe you didn't think of certain things, maybe the world has changed and you will need to make updates. And often these updates will come as the form of user feedback. So in this video, we'll demonstrate how to use Copilot to refine user interface and user experience design based on feedback. So for this project, I went ahead and made a form here, and you can see that this form very quickly has a few issues. And unfortunately, our users have been letting us know. Technically, it's all functional, it all works, but it's not a great user experience. So I have 3 pieces of user feedback here, and let's go ahead and see what they say. So the first one says, when I opened the contact form, I was immediately seeing red error messages, which they're not wrong. Even before I started typing anything, it felt like the form was constantly pointing out mistakes I hadn't made yet, which was pretty off-putting. And this is a very fair piece of criticism. So let's go ahead and get some of this out of the way so we can go grab our code. So we've got the index there, and then we've got the styles. Pull those over a smidge. Okay, let's grab index.html, poke that in, and then grab styles.css and put that in as well. And now we should also put in this user feedback. And then I will tell it what I want. I received this user feedback. How can I fix this issue? We should quickly get a response. So error messages are being displayed prematurely. It picked up on that. So it says we can modify the CSS to only show error message after the user has interacted with the form fields. So if we look here, we have some new HTML and some new CSS. And let's go ahead and check at the bottom if it did any other notes here. Nope, this looks pretty good. So let's grab this code and let's go ahead and see how this works. So that so far looks all right. And then let's grab the CSS as well. And now I still get that styling, but I don't see the error messages. So that is much better at this point. So we'll go ahead and save that. You might commit it to your code. And so in the name of brevity here, I am sort of running through this without really thoroughly looking over this code. But you would always want to go through, if you're really familiar with this code base, and actually make sure that the changes it's made it are appropriate. Often, rather than replacing the entire file, I would prefer to just make the specific changes that it made to make sure that it's not coming up with some kind of artifacts that are actually changing parts of the code I didn't intend to have changed. But having said that, let's crank forward because that fixed our first problem. All right, so this next piece of feedback I have here is I wanted to leave a detailed message, but the text box was just too small. I had to keep scrolling to see what I was typing, which was really annoying. So we have this text box here, and it can be a bit small, especially on a narrower view. So maybe we want to make that a little bit bigger. Now, this would be your sort of time as a front-end developer or designer to decide whether or not it makes sense to have that message be big. If you're getting a lot of long feedback, yes, maybe you want to make this bigger. Let's go ahead and assume this is correct. And so let's try and see if we can get Copilot to help us make this change. This is another piece of feedback I received. Say, without writing code, what are some options for fixing this? So this is resize the text box using browser tools, use the browser zoom, third-party tools or extensions. So we could put a little note there that said, hey, you can totally resize this. Let's see, is it possible to make the default size of the box larger? All right, so if we look at the output here, we can see that it says we can increase the rows to make it larger. So let's see if that will work. If we come in here to our CSS. Okay, so if we come in here and check this, I can change that to 10 or 20. Okay, I'm just going to double that size and we will see if that works for our customer. So that change has been made. Just knocking off all the tasks. So let's look at customer feedback number 3. All right, then this next piece of feedback is how am I supposed to find the subject I need without scrolling through every single item? Now, if I come to my subjects here, the first thing I'm confused by is this used to be a very long list, and now it says performance issues and other. So let's go back and check our index.html. So this is our farm group, this is our subjects, and I see this little comment here, and that led me to believe that Copilot truncated our list, which again is one of those handy little artifacts of it removing some code. So here we can see we once upon a time had a lot of options and it decided to just not reproduce them all. So let's go ahead and reintroduce all of these options and paste those in. And now we should see, hey, there is our big list of options, and it looks like I ended up with a couple of duplicates there. And this now looks much better. And we can actually see what their initial problem was. So they were looking through this list, and I don't really see any rhyme or reason to the ordering of these. It would make sense to put them in some kind of a logical order, maybe some kind of a hierarchy. For simplicity, let's just go with maybe an alphabetical order. All right, and so that is something that Copilot can help us with. Now, one option would be to turn these into data and then sort of generate these values based on that data. In the name of simplicity, I would start by trying something like this. Can you please reorganize these options to be in alphabetical order? And here you can see we have these options: accounting, affiliate, API, billing. Those all now look like they're alphabetical. Now, you would definitely want to go through and check to make sure it hasn't accidentally removed one of these. Again, in the name of expediency, I'm not going to do that here. And the real best option is probably to turn these into some kind of a data structure and then programmatically create them rather than doing them this way. And now if I look at these, I should see the options showing up alphabetically, and those look much, much better. Awesome. I will save that, and with that, we have met all 3 of our customer feedback goals here. These were all perfectly reasonable requests to make to this form. It now looks much better. You know, it's looking like I could still improve the styles, maybe them showing up red here, so I can put my name in there, and that goes away, and then email address. It's probably not ideal to have these look like they're sort of airing before anyone's put anyone in, again, but it is much, much better at this point, and those are all additional changes we could make using Copilot. That's how Copilot can help you quickly incorporate user feedback and improve your user interfaces and user experiences.
Copilot is more than a tool for generating code. It can support nearly every stage of a project, from initial ideas to final touches. In this video, we'll explain how to incorporate Copilot into daily development and design tasks, helping you seamlessly move from initial concepts to final delivery. First, when starting a project, you might only have a rough idea of the style you want. Copilot can help turn that into something real. Need ideas for themes, color palettes, or layouts? You can prompt Copilot to suggest designs that fit your vision. It can even provide color schemes and font pairings that create a cohesive style, saving time and offering inspiration. Next, as you define your project structure, you can ask Copilot to create layouts for key components. If you're building something complex, you can ask Copilot to lay out a homepage, navigation, or key components. Whether you're building a homepage, navigation system, or essential page elements, Copilot assists in visualizing and laying out these aspects for smooth progression. Then, to ensure your design resonates with your target audience, Copilot can even help create user personas. This gives you insights into your target audience and guides design decisions. This insight supports better design decisions and helps maintain focus on the user's needs. Moving on to organization, Copilot helps you keep everything consistent and manageable as your project grows. As your project takes shape, Copilot helps keep everything consistent and organized. It can set up layouts for websites or apps and suggest folder structures, component hierarchies, and file names, making the project easy to navigate and maintain over time. It can also be incredibly useful for generating standardized naming conventions for CSS classes or UI components. This keeps your code readable, helps avoid confusing names, and ensures your project remains organized and understandable as it scales. In addition, documentation is key for clarity, especially when sharing work with others or revisiting a project later. Copilot can generate helpful comments for your CSS or JavaScript, explaining each section's purpose. This is particularly useful for complex layouts or custom design elements. You can even use it to generate style guides or other broad design documents to support both current and future development. As you approach project finalization, Copilot helps you refine details and reinforce best practices like accessibility and responsiveness. If you're checking color contrast or focus states for accessibility, Copilot can point out areas that may need adjustments. This feature is vital for creating user-friendly and inclusive designs. Finally, preparing for deployment means cleaning up your code. Copilot can help optimize code by suggesting cleanups and pointing out unused styles or redundancies. It can assist with cross-browser compatibility too, identifying anything that might need tweaking to display correctly on all devices. The result is a streamlined code base that's ready for cross-browser compatibility and efficient loading. Once the project is live, you may need to make improvements based on user feedback. Copilot can support quick updates, letting you respond to feedback efficiently and continuously enhance the design. This ability to iterate on real-world insights helps keep the user experience fresh and responsive. In short, Copilot is a valuable companion from start to finish. It supports ideation, organization, documentation, finalization, and post-launch improvements, making each stage of development and design smoother. By bringing Copilot into your workflow, you can save time, maintain consistency, and deliver quality results.
Discussing great UI, aesthetics often take center stage. However, effective project management is every bit as critical. Well-organized code and consistent practices ensure functionality and reliability. That enhances the user experience and makes your interactions seamless and intuitive. So in this video, we will demonstrate how to use Copilot to complete a comprehensive design project. We'll start with the simple to-do app here. So it has a bunch of functionalities. If I restart this, you'll see a little toast pop up. This entire application is sort of built around these toasts. So it says we have 0 to-dos. I can add a to-do like get milk. Cool, there's a to-do. If I try to add a to-do that's empty, I get this toast here that shows me I can't do that. Let's just add in some random text here. And then I'll start to get some warnings that say I have more than 3 to-dos open. Now, this isn't the most beautiful design, and really our toast probably shouldn't be extending that far into this area, but there's some bigger problems I want to address here in this video. And so the first thing I'm going to look at here is you can see that we have no styles up here. and there is no CSS file. So all of these styles are inlined. So one of the things I highly recommend is that you abstract out those CSS rules and put them into a centralized style sheet, because that will make it much easier to manage them typically. There are some framework approaches around this, but in general, it's good to abstract those out. And that's something we are going to have Copilot help us with. All right, so I am going to copy this code. Then I am going to pop up Copilot. And now let's say what we want to do and make sure I have a new chat. Say extract the inline styles in this application into an external style sheet. And so now it should be able to do that for us. So let's go ahead and make a new file here. We're also working on that, and we'll say styles.css, and we will want to check once it has made that is what it did. You see styles.css, excellent. So let's actually just grab this whole thing, because that will get rid of our inline styles. And then let's save that. So that should look unstyled, which is right, because we have not pulled in our styles. Excellent. And then if we add to-dos, do things like that, we get all of our same messages. Awesome. So now we have external styles. It looks like our colors are okay. And again, this is one of those places where you really want to carefully sort of check what it did to make sure these changes are appropriate. It can help you do this work quite quickly, but it can be a bit error prone. It might make problems on the edges, and that's something you just want to watch out for. And so if we go back and look at our code, it is much cleaner now without all of those inline styles. You really just sort of get the idea of what the structure looks like. And then the next thing I really don't like about this code is that I have this info toast, this success toast, and a warning toast. There's sort of a common idea in programming to not repeat yourself. Do not repeat yourself. And so these are all almost exactly the same, and really all that should be different is the colors. And because these were each implemented differently, if we look here, you can sort of subtly see like this text is small, that corner rounding is different. It just doesn't look terribly clean. It would be nice to have these all consistent. And it looks like these actually got picked up when it made this external CSS. And this is actually really helpful, because now we can sort of see, oh yeah, this had a different font size and a border radius and all of these things. So we can make these more consistent and then have each of these different types of errors represented by their own warning that just has slight changes without having the 3 different warning toast functions here. So once again, I will grab this code, and I'm actually going to go ahead and say here, please modify this toast implementation to be easier to maintain. I want to abstract out the consistent behavior for all toasts from the individuality of the different types of toasts. Copy that code again. It already had a copy, but it's typically good to give it sort of a reminder. So let's refactor the toast implementation, and it has an updated HTML file. And you can see here that we now have a show toast function, and then we have the show info toast, show success toast, and show warning toast, and show error toast. Excellent. And so this has now taken that one change, which is going to be the color, I believe, is the info success warning error. See where that is being used, this type toast. Yeah, so that is our class names. And so now we have this central implementation where all the common functionality is held, and then the sort of differences are made in each of these. And we could actually take this a step further and just pull each of these out into their own CSS classes potentially. But this is much, much cleaner at this point. So now we can go ahead and come back to our styles over here. And here's our info toast, our success toast, our warning toast, and our error toast. And now if we look up here, we also have these common rules for all of the different toasts. Now we could make a separate toast class, which might be useful, but we can go ahead and leave it like this for now. And so I'm going to come down here, and I'm going to remove all this additional styling and just make it so the colors are different. That way everything will look much more consistent. So now if I save this, you should see a toast that looks like that, and then that, and now these are much more cohesive. They sort of all fit the same design language. Now I might want to move my buttons all to float to the right or something like that, but this just looks much tidier by keeping it much easier to maintain code. If I want to make a change to each of these, I can change the colors there, and then I have everything that is central right here. And then going back over to our HTML, let me make sure I actually copy that over, grab this, copy that in, test this one more time, because that was using our old implementation, and these look again much, much better. And then finally, let's have Copilot do one more thing for us, and that's have it generate a README file. So let's say, please generate a README file that explains how to use the application and what the purpose is. So it says, here's this README purpose. The simple to-do manager, basic web application, adds new to-do items, receives visual notifications for different actions. Setup, clone the repository, download files, open index.html. Adding a new to-do item, enter a new to-do, click the add button. Excellent. So this is looking like it explains what I want it to. So I will go ahead and copy this. And again, outside of a video like this, I would scrutinize this much more. But I don't want to make you watch me read an entire file. So let's say this is readme.md, plunk that in there. And now we have this index.html file. Now you would definitely want to check things like this license. If you did not want to release this under, say, an MIT license, that's something you really wouldn't want in there. You probably do want to have some kind of license. You will just want to be careful about what that is. And then maybe you don't want, say, these future enhancements. And now, if you're having trouble getting Copilot to generate the document like this, like it is taking quite a bit of liberty here. We did not give it much instruction. You could also give it some bullet points of what you want the README to look like, and then have it sort of flush that out into a more full document, so saving you a little bit of time, but not all of the time. What we did here was pretty heavy-handed use of Copilot, but this is totally a good way to sort of get someone up and running with your project. It's often better than nothing, but be careful of having bad docs, because bad docs can be every bit as problematic as no documentation. And with that, we have now improved the maintainability of this code. It functions the same as it did previously, but it is just much, much easier to work with and maintain. And that ease of maintenance will ultimately allow us to spend more time working on the things that actually matter, and that's making our app really, really functional for our users. So you've built your entire UI. Now what? Well, ideally you want to share it with the world, which means you probably need to host it somewhere that you or at least your team can access it. Before you do that, you often want to complete some final useful steps. So in this video, we demonstrate how to use Copilot to complete a comprehensive design project. A key part of deploying an application is making your CSS production ready. This involves linting your code before committing it and minifying it for production. Linting is a process that analyzes your code to catch errors and enforce coding standards, which ensures that your code is readable and easy to maintain. And minification reduces the file size, making your website load faster and improves user performance. So together, these two practices enhance the quality and efficiency of your application. Now, this is something you might look to Copilot to be able to do for you, but it's actually not something I recommend you use Copilot for. And so if we grab our styles here, I can take these and then I could say, come back to Copilot and say, please minify these styles. And this is a relatively small file, so it will probably make this appropriate. And so you can see here, it's taken away all the white space, anything that's unnecessary in there to make this really tight. So it will send to our clients really efficiently. And now again, Copilot and other AI tools like this are error prone enough that I don't recommend using them to do this, but this sort of shows you what would happen. I recommend looking towards other tools. If you look up CSS minification in your particular language, there's almost certainly a tool that will do that. And this might be a really good place where you could use Copilot. Ask it, what is a really good tool I can use to minify my code? What is a good tool for minifying CSS using C#? And so you see here that maybe this bundler minifier tool is the tool you want to use. So there might be some other options here. But when it comes to finalizing your project, I highly recommend that anything that can sort of be done through static analysis, so that means it just can look at the file and sort of know what the syntax is, and then very deterministically create an output, to use a traditional programming tool to do that rather than trying to use an AI tool. Where AI tools are really good is sort of on the fuzzier things, the things that are a little bit more subjective. And I think one good example of doing that with a project like this is having it look over our design doc and telling us whether or not we have actually satisfied everything we were supposed to do. So I am going to go ahead and come up here and start a new chat and say, I have these design documents. And so there are those. Tell me if this code satisfies all of the requirements. And so I will then grab my code and pull it over here, and let's see what it comes up with. So checking, we can add new to-do items. Yes, we can display to-do items. Yes, we have input validation. Yes, we have toast notifications. Yes, and we missed search and filter to-dos. So it looked at this file and realized that we have the ability to add them, filter if we don't actually want to add one. And so Copilot has caught here that we indeed are missing that search functionality. It's great that Copilot found this issue, or we might have released an incomplete application. Maybe this is a contract that we have, we're doing independently. And that means that all of a sudden we're not going to get paid because we didn't meet those requirements. This could be an internal project, and there's another team that depends on that functionality for it to work. If it was in our specifications, it's probably something we wanted to have, and this kept us from missing that. Now, these are just a couple examples of what you can do with Copilot when it comes to finalizing a project. There's a lot of steps to get from your code to actual deployment. So maybe you want to have it help you write continuous integration scripts that can help you make deploying this code easier. Maybe you want it to actually handle the deployment. So you can have it help you write deployment scripts. You can have it help you write your marketing and launch plan. So just because your code is done doesn't mean Copilot can't continue to be incredibly useful for the launch of your application.
Congratulations on completing UI/UX design principles, part of the Microsoft Front-End Developer Professional Certificate. Throughout this course, you've developed the foundational skills needed to create intuitive, user-centered, and accessible designs. By mastering these essential principles, you are now equipped to enhance user experience and contribute to impactful projects in the ever-evolving field of UI/UX design. You began by diving into the core principles of UI/UX design, including user-centered design and accessibility. Understanding these principles ensures that you can craft inclusive and meaningful experiences that cater to diverse user needs and expectations. Next, you explored the process of prototyping using tools like Figma and Adobe XD. By practicing wireframing and creating high-fidelity mockups, you gained valuable insights into building and refining designs, as well as collaborating effectively with teams to enhance workflows. You then implemented responsive design techniques using CSS. Mastering media queries and mobile-first design principles enabled you to create adaptable interfaces that deliver seamless experiences across devices. And finally, you harnessed the power of Microsoft Copilot to streamline CSS development and enhance responsive design workflows. This AI-driven approach not only improved efficiency, but also demonstrated how emerging tools can elevate your design process. Having completed this course, you now possess the skills to design accessible, user-friendly, and responsive interfaces that meet the demands of modern users. These abilities are integral to your growth as a front-end developer and position you to make a significant impact in the field. Congratulations on your accomplishments, and best of luck as you continue your journey in UI/UX design and development.